Hi everyone, welcome to PrepFusion. So this is the second part of DTFT, DTFS, DFT and FFT. In the first part we discussed DTFT and DTFS, and before that we discussed the basic concept of all these topics as well, right? So two kind of video we have already watched. First one was this one, and then we have watched this one. After watching these two videos only, you will come to this particular video. Okay, so in this video we are going to discuss DFT and FFT. But it's not that, sir, directly I need DFT and FFT only. No, first you need to watch these two videos as well. In a very quick manner you can watch. If you feel like that, sir, I am comfortable with DTFT, DTFS, everything, then in a very quick manner you can watch, and after that you should be coming to this part 2. So this was actually the part 0, this is the part 1, and this is the part 2. Okay, so after that you will watch this video. So we will get started. Just I am telling that I am targeting 100 likes, and within 2 days I am targeting we should get 2000 views. Okay, so you guys can complete it. Yeah, thank you very much. Let's get started with the video now. Hi everyone, welcome to PrepFusion. So continuing our discussion on the discrete part. So actually we started in the discrete part from jet transform, then we moved to DTFT, then we moved to DTFS. In between we saw the basic concept of circular convolution as well, and now we are going to study about discrete Fourier transform. So there was one video where I have given the basic fundamentals of a discrete Fourier transform. Basic fundamental, that how the discrete Fourier transform came into action. I hope that particular video you have already watched. So discrete Fourier transform, what is the basic fundamental that I have already told, that we already know. So here we are just revising it. So what is the meaning of discrete Fourier transform? That first there is some x of n that is aperiodic, right? This is a 4-point x of n which is aperiodic. 2, 1, minus 1, 3. So it is having 4 samples whose values are 2, 1, minus 1, 3. So this is a aperiodic signal, aperiodic sequence. Now what you are going to find out? You are going to find out its discrete time Fourier transform. When you find out its discrete time Fourier transform, so for a aperiodic sequence, for a aperiodic discrete sequence, the discrete time Fourier transform will always be periodic and continuous. So it will be periodic. So this process was our second chapter where we studied about DTFT. Look, the waveform could be different. I have just made a random waveform, a very random waveform I have made. Now what I am gonna do is that I am gonna sample this particular frequency spectrum, right? This is the Fourier transform that we are having. I am gonna sample it, and how I am gonna sample? I will sample in a manner that in this 2 pi window I am gonna get n samples. In this 2 pi window I am gonna get n samples. The value of n could be anything, 1, 2, 3, 4, 5, 6, it could be anything. Mostly they will take the value of n equals to the number of samples in x of n. What I am saying, mostly in 99.99% of the questions, the value of n will be equals to the number of samples in x of n. So here how many samples are there? 4. So this value of n they will take 4. Okay. So what I am gonna do is that in this 2 pi window, I am gonna calculate n samples. In this 2 pi window I am gonna calculate n samples. That means every sample I need to take after every 2 pi by n frequency. Basically in 2 pi window I need to calculate 4 sample. That means first sample I can take at 0. Next sample I will take at pi by 2. Next sample I will take at pi. Next sample I will take at 3 pi by 2. The next sample will come at 2 pi. So in the window of 2 pi, next sample is coming at 2 pi. So this 2 pi sample will not be counted. So in the window of 2 pi, you have calculated these 4 samples. So if there is a window of 2 pi and you need to calculate n sample, so every sample will be taken after 2 pi by n frequency, right? So every sample will be taken after 2 pi by n frequency. So in that manner you need to take the sample. Why I multiply with k? After every 2 pi by n frequency you are calculating the sample. So first sample will come at 2 pi by n. Second sample will come at 2 pi by, first sample will come at k equals to 0. Second sample will come at k equals to 1. Third sample will come at k equals to 3. And fourth sample will come at k equals to 4. Fifth sample will come at k equals to 5. So what kind of sequence you will be getting? That at minus pi you will calculate some sample, then at pi by 2 you will calculate some sample. What I am doing, I am considering n equals to 4. Here what I have done, I have considered n equals to 4. So what I am getting, pi by 2 k. That means if I put k equals to 0, so at 0 I am calculating the sample. If I put k equals to 1, then at pi by 2 I am calculating the sample. If I put k equals to 2, then at pi I am calculating the sample. All these basics we have already seen, right? So this kind of periodic waveform we will get, which is discrete plus periodic. Discrete plus periodic. Why periodic? Because if this is periodic, then surely this will also be periodic. So it is very simple. What you are doing, you are just sampling the frequency spectrum, nothing else. So this is how we have sampled it. So this will be a function of k. So we'll write it down as x of k. We write it down as x of k. Basically, in place of omega, you are putting 2 pi by n k. So this x of k could have been written as x e to the power j. In place of omega, what you are putting? 2 pi by n into k. So this is your x of k. But generally, we write down x of k in this manner, directly x of k versus k. Is that clear to you? So coming from this particular process to here and then here, this process is known as DFT, discrete Fourier transform, DFT of x of n. So this particular process was x of n. That means directly coming from here to here, this was known as discrete Fourier transform of x of n, and which is represented by x of k. Is that clear to you? So this particular process was DFT. Okay. Now let me know one thing. If x of k is discrete plus periodic, and now you go to the time domain, x of k is discrete plus periodic. Now if you go to the time domain, what you will get? Discrete plus periodic only. So when you calculate the inverse DFT, inverse discrete Fourier transform, what was your x of n? X of n was aperiodic. Then you calculated x e to the power j omega. From there you got x of k, which was your DFT. So DFT became discrete plus periodic. Now when you calculate the inverse DFT, just let me know one thing. If I calculate xt is having x of omega, this is the Fourier transform of xt. If I calculate inverse Fourier transform, what I will get? Xt only. X of n is having the Fourier transform of x e to the power j omega. If I calculate the inverse Fourier transform, what I will get? X of n only. X of n is having a z transform of x of z. If I calculate the inverse Fourier transform, inverse z transform, what I will get? X of n only. But here the scenes will be different. Here what will be the scene? You know one particular thing, that if your frequency spectrum is discrete plus periodic, then your time domain signal or your time domain sequence will have to be discrete plus periodic only. So what will happen is that this particular sequence will become periodic. So these samples will keep on repeating now. So a particular x of n was given, you find out its x of k, and when you calculated the inverse DFT, you are not getting x of n, you are getting the periodicity of x of n. That means this particular x of n is being periodically extended. So whatever the x of n was there, I will try to copy this x of n. Yeah. So we are able to copy. So whatever this x of n was there, what will happen is that this x of n will be periodically extended. That means 2, 1, minus 1, 3. The next sample what that would be 2, 1, minus 1, 3. Again 2 will come. Then again 2 will come. Then sample 1 will come. And in that manner it will keep on repeating. And here also 2, 1, minus 1, 3. So basically now it has become a periodic sequence. So it will just be repeated in this manner. Is that clear to you or not? So this has become a periodic sequence. 2, 1, minus 1, 3. And here 2, 1, minus 1, 3. So this has become a periodic sequence. So there is difference between this xn and this xn. For x of n, you calculated the DFT, you get x of k. When you calculated the inverse DFT, you are not getting x of n, but you are getting the periodic extension of x of n. Is that clear to you? Okay. So I'm not going to write down x of n, I'm going to write down this particular thing. Is that clear to you? We will see more points, more things will be clear to you. Okay. Okay. So have patience. Till this point in the first 10 minutes, whatever that we discussed, that we have already discussed, right? X of n was there, you find out the Fourier transform, you sampled it, and then you find out the inverse discrete Fourier transform. So this particular process was DFT, and this particular process would be IDFT, inverse discrete Fourier transform. So this particular slide was already discussed. Now let's see the formula. But this is the point that you can calculate DFT for both periodic and aperiodic sequences. Here you saw that it was an aperiodic sequence. But can you calculate DFT for periodic sequence as well? Yes, because for periodic sequence, can you find out its Fourier transform? Can you find out its Fourier transform? Yes. So if I can find out the Fourier transform, then can I sample it? Yes. That means you can surely calculate DFT as well. We will surely see the example as well. Are you able to understand what I am saying? For any periodic sequence or for any aperiodic sequence, for both of the sequence, you can calculate the discrete time. You can calculate the discrete Fourier transform. If you can calculate a discrete time Fourier transform for any function, then surely you can calculate DFT as well. Are you able to understand this point? If my DTFT is possible, then DFT is surely possible. So for both periodic and aperiodic, you can find out the DFT. Okay, but the inverse DFT will always be periodically extended. Inverse DFT will always be periodically extended. It might happen that sometimes it could be written that inverse DFT of x of k, inverse DFT of x of k, inverse DFT of x of k is x of n, which is equals to 3, what was there, 2, 1, minus 1, 3, which is equals to 2, 1, minus 1, 3, 2, 1, minus 1, 3. If it is written somewhere, that means first thing is that it is wrong, it is not correct. Secondly, you need to assume that, okay, this is the inverse DFT you are getting, but actually it will be periodically extended. That means 2, 1, minus 1, 3, then again 2, 1, minus 1, 3, then backward side as well 2, 1, minus 1, 3, then before that 2, 1, minus 1, 3, after that 2, 1, minus 1, 3, it will be periodically extended. Is that clear to you? All fine? Okay, so inverse DFT can periodically be extended any time. Is that clear to you? Is this concept clear to you? Surely it is clear to you. Now let's see the formula. N point DFT of x of n is given as x of k. Can you write down the formula of x of k? Surely I can write down the formula of x of k. That would be given as x of n. When I write down the formula of DFT, I will always think about the formula of DTFT. What is the formula of DTFT? N goes from minus infinity to infinity e to the power minus j omega 1. So x of n e to the power minus j. But when you find out DFT, what do? In place of omega, what you put? 2 pi by n k. So 2 pi by n k, and then n is already there. So in place of omega, what I need to put? 2 pi by n k. So what I will get? X of k. Is that clear to you? Now x of n was non-zero between n samples. Let's just say if I call these samples are n, number of samples are n. That means number of samples are 4. Here 4 samples are there, no? 0, 1, 2, 3. So number of samples are 4. That means the limit will go from 0 to n minus 1, 0 to 4 minus 1, 0 to 4 minus 1. So limit will go from 0 to n minus 1. So this is the formula of x of k. Is that clear to you? All good? All fine? Okay. Now from here you can get the value of x of n as well. What will be your x of n? Sorry, x of n you need, no? So here you will write down x of k. Since this particular part, if n is here, so here also n would come, but positive sign, 2 pi by n kn, right? And since you want the final answer in terms of n, so here what you will write down? K going from minus infinity to infinity. Will you write down k going from minus infinity to infinity? No, because x of k is periodic. Since it is periodic, so k going from 0 to n minus 1. Why n minus 1? Because x of k will be periodic with n. We will see more example, it will be more clear to you. Have some patience. But these are the formula which should be there in your mind. And it is not tough to remember. What you need to do, always remember the formula of x e to the power j omega, which very easily we remember. If we are remembering this formula, then very easily we can write down these formula as well. All good? All fine? There is something called twiddle factor. So this particular term you can see, no? This particular term. This particular term is twiddle factor. So it is written by Wn. Twiddle factor. So it can be written as e to the power minus j 2 pi by n. Okay. So this is a certain term actually, because whenever you calculate DFT, all the time this particular factor comes. So they have given it a name that is known as twiddle factor, because this particular factor will come again and again. So they have given it a name that is known as twiddle factor. Okay. So can you rewrite the formula? X of k could be given as 0 to n minus 1 x of n. This is Wn to the power kn, right? And what is the formula of x of n? You will never remember this formula, okay? You will remember this formula only. Although you are not going to remember any formula, you will remember only this formula. From there you can write down all these formula, right? So no pressure on your brain. Needless pressure should not be there that I need to remember this thing, that thing, or anything like that, right? And this formula also very easily you can remember from continuous time. And continuous time formula you can very easily remember from from CTFS. So from CTFS we move to CTFT. From CTFT we move to Laplace transform. So all the formula were related. All the formula we have written down in one page as well in that particular video, and there I told you that how you can write down the limit, how you can see the time period and everything, right? So for any single thing, I'm not putting any pressure on your brain that you need to mug up this thing, that thing. No, nothing. So x of k, wn to the power minus kn, right? Because what is wn? E to the power minus j 2 pi by n. Minus sign is there, no? But here there is plus sign. So minus minus, that would become plus. So wn minus kn. This is what we can write down. Okay. So these two formulas are there. Now some properties regarding the Tweedle factor. These are not properties, just treat this as a question. You know that what is Wn? It should be there in your mind. E to the power minus j 2 pi by n. This is your Wn. So e to the power minus j 2 pi by n to the power 0. So e to the power j, anything multiply with 0, e to the power 0, that would be equals to 1. So Wn to the power 0, that would be equals to 1. E to the power minus j, nothing you are going to mug up, okay? These results you are not going to mug up. Wn to the power 0, anything to the power 0 would be 1, that's it. Now this result you are not going to mug up. You will always derive it in your brain only. And will get cancelled, 2 will get cancelled. E to the power minus j pi, what is that? Minus 1. So can you derive it in your brain only? Surely you can derive it in your brain only, okay? Wn to the power n by 2. N by 2 is there, e to the power minus j 2 pi by n, and n get cancelled, e to the power minus j pi, answer will be minus 1. Wn to the power n by 4, what you will get? Minus sign. There is very high chance that whenever you write down this Wn, you will forget this minus sign. So always take care of this minus sign, okay? This used to happen with me when I was a student. So n will get cancelled. What you are getting? Array yaar, n will get cancelled, here you will get 2. So what you are getting? Minus j. Wn to the power n. N will get cancelled, what you are getting? E to the power minus j 2 pi, that is equals to e to the power j 0 only, right? And that would be equals to 1. So you are not mugging up anything, right? Wn to the power n plus n naught. So it can be written as Wn to the power n and Wn to the power n naught. So you know that what is the value of this one? That would be 1. So Wn to the power n naught. Again I am saying you are not going to mug up any formula. What about this one? To the power minus 1, right? So it can be written as e to the power j 2 pi by n, right? So can I write it down as Wn conjugate? Because what will be Wn conjugate? Wn conjugate, what is your Wn? This is your Wn. What will be your Wn conjugate? Wn conjugate will be plus j will be replaced with minus j. And what that is equals to? Wn to the power minus 1. Okay. So in this formula here, instead of writing minus sign, you could have written the conjugate as well. But forget about it, you can write down minus sign only. Right? And Wn to the power minus n, what that would be? So basically from here you understood that you are not going to mug up any property or anything like that. These are not the property, these are just simple results which you can derive without even picking up the pen in your brain only. So not going to mug up anything, right? Now we will understand everything with respect to question only. So let's follow the process. We are not going to apply any formula, we will follow the process. X of n is given, 2 point x of n is given. 2 point x of n is given. What is the meaning of 2 point? That means this has to be origin. They will not specifically tell that this is the origin. If they have written 2 point x of n, that means this is the origin. Now what you need to calculate? You need to calculate 2 point DFT. But what is my first task? Always the first task is you calculate DTFT. So I am going to calculate the DTFT first. So first I am going to calculate the DTFT. What is the answer I will get? Delta n plus 2 delta n minus 1. Now next what they are saying, 2 point DFT you need to calculate. So what is the value of n? Value of n is coming from here or value of n is coming from here. This is the value of n. Okay. This is the value of n. Always remember n point DFT. N point DFT. X of n could be anything. X of n could be having 2 point, 3 point, 10 point, 15 point, 100 points, 10,000 point. But n point DFT. So this is the value of n. Okay, value of n is 2. Mostly what will happen is that this and this would be same. 2 point x of n, 2 point DFT. So this and this would be till this point in the gate examination always they are same. But till this point they are same, but someday they will be different. So if they are different, then what you will do, that also we will discuss. Yeah. So what I am saying, what you need to do, you need to sample it. You need to sample it with what? Omega should be replaced with, in 2 pi window, you need to calculate 2 samples. That means every sample you will calculate after pi radian frequency, pi radian per second frequency. So what I will write down, 2 pi by n k, 2 pi by n k. What is the value of n? That is 2, that is equals to pi k. Method and everything we will learn, but let's see the basic concept, right? What is the basic concept behind all these things? So from here you will get x of k, that is given as 1 plus e to the power minus j pi k. Okay, so this particular process was your DFT. So this was your DFT. Okay, so x of k could be written in this manner. Put k equals to 0. Put k equals to 0. What that would be? 3. Put k equals to 1. So e to the power minus j pi. What that would be? Minus 1. 1 minus 2 will be minus 1. Put k equals to 2. So if you put k equals to 2, what you will get? E to the power minus j 2 pi. That would be 1 only. 1 plus 2, 3. Put k equals to 3. What you will get? Minus 1, minus 1. You can do this calculation, right? If you put k equals to 0, what you are getting? E to the power 0. 1 plus 2, 3. If you put k equals to 1, what you are getting? E to the power minus j pi. 1 minus 2, minus 1. If you put k equals to 2, what you are getting? E to the power 0. That means 1 plus 2, 3. If you put k equals to 3, what you are getting? E to the power minus j 3 pi. E to the power minus j 3 pi. What you will be getting? 1 minus 2, minus 1. In that manner, what you will keep on getting? This thing you will keep on getting. And similarly in the negative side as well, if you put k equals to minus 1, what you will be getting? If you put k equals to minus 1, 1 minus 2, you will get minus 1. What I am saying, if I say this is my n equals to, let's just say this is my n equals to 0. Okay. So in the negative hand side, if I put k equals to minus 1, what you are getting? Minus 1. If I put k equals to minus 2, what I am getting? 3. So this is how your x of k is there. But what they are saying, you need to calculate 2 point DFT. That means this x of k should also be presented in 2 points only. What I am saying, they are saying 2 point DFT. So many times answer could be written in this form, 2 point x of k. So from this x of k which is periodic, can you get 2 point x of k? Yes. That means you need to take the sample at n equals to 0 and n equals to 1. But this is not n, this is k. So this is your k equals to 0 and k equals to 1. So 2 point x of k is 3 and minus 1. We will see the method and everything, but as of now you are understanding the concept. Is that clear to you? So this is your 2 point x of k. And from here if you calculate the IDFT, from here if you calculate the IDFT, what you will get? If I calculate the IDFT, what I will get? So what will happen is that the same thing will come, but it will be repeated. 1, 2, 1, 2, 1, 2 and so on. It will be completely repeated. Okay. This will be your IDFT. But sometimes how the question could be asked, that what will be your 2 point IDFT? 2 point IDFT of x of k. So what will be the answer? So since you have got the 2 point IDFT of x of k, so since you have got the complete IDFT of x of k, now you need to write down 2 point IDFT of x of k. What that would be? 1, 2 only. And that is actually coming out to be equals to x of n. So did you understand the process? And did you understand the meaning of every 2 point and all these things? Because we have already seen the meaning of all these terms, right? I did not want to get the meaning of 2 point modulo all these points here, because if I discuss all these points here, then everything will be matched up. But what is the meaning of 2 point, what we are doing, every process is clear to you now. And this is the best thing about DFT. Like, people would not even understand the process. They will get to know that how to calculate the DFT, but they don't even know what will be periodic, what will be aperiodic, why the answer is periodic, when the answer will be aperiodic. Started with x of n, which was 2 point x of n. That means it was 1, 2 only. That's it. This was given. 2 samples were there, 1 and 2. You calculated the DTFT and then you calculated the DFT. Right? When you calculated the DFT, what you are getting? 1 plus 2 e to the power minus jk. So from there you got the answer, that was this thing. 3 minus 1, 3 minus 1, 3 minus 1 were keep on repeating. But what if In the examination, what they are asking? 2 point x of k they are asking. What they are asking? 2 point x of k. So your 2 point x of k would be 3 and minus 1. From n equals to 0, you need to pick, from k equals to 0, you need to pick 2 samples. So there you go, this is the answer. And from this x of k, if you calculate IDFT, what you will get? You will get this particular scenario. 1, 2, 1, 2, 1, 2, 1, 2, it will keep on repeating. This x of n and this is, both are different. This same x of n is being repeated till minus infinity to plus infinity. But what if they ask you 2 point IDFT? What I am saying, what they have asked, 2 point IDFT of x of k. 2 point IDFT of x of k. So that would be equals to x of n would be that will be 1 or 2 only. 1, 2 only. Right? 2 point IDFT of x of k. Is that clear to you? Everything is crystal clear, right? All the process is clear. Although there is a simpler process that how to calculate all these kind of things, that we will see later on. But as of now, the concept is clear to you that what is happening, right? Now you need to calculate the same thing for 3 point as well. So I'm not going to calculate the final answer. I'm just going to do the same process. That 1, 2, 3, we will write down. First, we will get to know that x e to the power j omega. The two same process we are going to follow. So 1 plus 2 e to the power minus j omega plus 3 e to the power minus j 2 omega, right? Next, what I need to do? I need to sample it. What I need to calculate? I need to calculate 3 point DFT. 3 point DFT. 3 point DFT means n equals to 3. 3 point DFT. N equals to 3. So omega should be written as 2 pi by n into k. So x of k 1 plus 2 e to the power minus j 2 pi by 3k plus 3 e to the power minus j 4 pi by 3k. Sir, every time we need to follow this process? No, there is different process. That process we will follow. But as of now, you need to follow this process only. Now you will put k equals to 0, k equals to 1 and k equals to 2. You will get the answer. Basically, x of k will be periodic. This periodic answer you will get. So whatever the answer you get, you can get it. Right? Basically, it will be complex. The answer will be complex because e to the power minus j 2 pi by 3, that will be complex, no? So answer would be complex actually. So you can do it on your own. Now what I need to do? I need to calculate IDFT. So when I calculate the IDFT, what I will get? They did not write 2 point IDFT or anything like that. That means they expect me to calculate the inverse discrete Fourier transform, complete inverse discrete Fourier transform. So what will happen? 1, 2, 3, 1, 2, 3, 1, 2, 3, that will keep on repeating. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, that will keep on repeating with this marking the origin. If they have asked me 3 point IDFT of x of k, 3 point IDFT of x of k, then what would be the answer? Only this would be the answer. Is that clear to you? All good? All fine? Okay then. Similar thing we can do with 4 point as well. So again the 4 point, do it on your own. Okay, write down with me, do it on your own. Don't look at the screen. First, what is the value of n? 4 point DFT. 1 plus 2 e to the power minus j omega plus 3 e to the power minus plus 4 e to the power minus j 3 omega. I hope you are doing with me. You are not looking at the screen. Now we need to sample it. 2 pi by n into k. 2 pi by n. In 2 pi window, I need to calculate 4 samples. So after every pi by 2k, I can calculate the sample. So what I am getting? X of k, that is 1 plus e to the power minus j pi by 2k plus 3 e to the power minus j pi k plus 4 e to the power minus j 3 pi by 2k. Okay. So x of k will be periodic. Let's calculate for 0, 1, 2, 3. So 10. If I put k equals to 0, I am getting 10 here. If I put k equals to 1, what you will get? 1 minus 2j minus 3 plus 4j. So I will get minus 2 plus 2j. Minus 2 plus 2j. Then what you will put? K equals to 2. So 1 minus 2 plus 3 minus 4. So what you are getting? 3 minus 2, 1, 2, minus 2. Okay, and next would come minus 2, minus 2j. If I put n equals to 3, so what I will get? 1 minus 2j, okay, sorry, plus 2j, minus 3, and minus 4j. So minus 2, minus 2j you will get. So this calculation we will do. Okay, so this is the answer you will get. Here for 4 point it was easy to calculate because it was giving the answers. Basically these points were giving the values, but they were not complex. Here the value would be a plus iota b. This will throw a plus iota b, right? But this was either throwing plus 1, but these values are throwing plus 1, minus 1, or plus j, minus j. So it was easy to calculate. So this is the answer we are getting. Now from here if I calculate, this particular process was your DFT. This particular process was your DFT. And from here if I go and calculate IDFT, what do I get? Sir, 1, 2, 3, 4, 1, 2, 3, 4 will keep on repeating. Okay, all good, all fine. Now we will calculate the DFT with twiddle factor. Basically now we are going to learn the method that how to calculate the DFT. This was not the method, this was the process, that this was actually happening. This was the process. Now we are going to learn the method, that what is the method of calculating the DFT, right? So you see the formula. What is your twiddle factor? Again and again you keep on writing down this in your notebook, because I know that in the examination surely you can forget this negative sign. So again and again 10 times you write down Wn. Twiddle factor is e to the power minus j 2 pi by n. So n goes from 0 to n minus 1. X of n Wn to the power kn x of k. Okay. What we need to calculate? We need to calculate this x of k. So what we will do? We will make the matrix like this. What we will do? We will make the matrix like this. So here I am now going to write down. I need to calculate x of k. So only those samples I will calculate which will be repeated. Basically here if I need to calculate x of k, so what I will calculate? X of 0, x of 1, x of 2 and x of 3, because I know that after it will be repeated only, right? So in the same manner here what I will calculate? X of 0, x of 1, x of 2 till x of n. Is that clear to you? Here it was 4 point DFT. So I calculate 0, 1, 2, 3. So actually this will be x of n minus 1 till x of n minus 1 I will calculate. Is that clear to you? Are you able to understand this point? If I needed to calculate a 4 point DFT, that means x of 0, x of 1, x of 2, x of 3 I will calculate, because after that it will be repeated. So similar thing, x of 0, x of 1, x of 2 till x of n minus 1. And what is the input? Input is also having n points. This is what I am assuming, that input is also having n points. So x of 0, x of 1, x of 2 till x of n minus 1. So whatever the input points are there, like input points were 1, 2, 3, 4. So here I would have written 1, 2, 3, 4. Now here what you need to write down, first step what you will do, in the row and in the column, I said opposite, in the first row and in the first column, in the first row and in the first column you will write down 1, 1, 1, 1, 1. What I am saying, in the first row and in the first column you will write down 1, 1, 1, 1, 1, 1, 1, 1, 1, 1 everywhere, right? But actually these are not 1. Actually what these are Wn to the power 0. These are Wn to the power 0. So as of now let's write down Wn to the power 0 only. In the complete first row you write down Wn to the power 0. In the complete first column as well you write down Wn to the power 0. Now this much space is left. Okay, you will not have to mug it up. Okay? I will tell you a trick as well. This much space is left, right? Now what you will start? Here you will write down Wn to the power 1. Now you will write down the table of 1. What is the table of 1? 1 1 ja 1, 1 2 ja 2, 1 2 ja 3 and so on. Here then you will write down the table of 2. 2 2 ja 1, 2 2 ja 4, 2 2 ja 6 and in that manner. Sorry, 2 3 ja 6, 2 2 ja 6 and in that manner you will keep on writing down. Okay, till the last column. Then you will write down the table of 3. Basically table of 1, 2, 3, table of 4, table of 5, in that manner you will keep on writing down. Wn to the power 6, Wn to the power 9. What you can understand, that either in the row or in the column I am writing down the table. If I am saying that I am writing down the table in row, then wn to the power 1, wn to the power 2, wn to the power 3, wn to the power 4 in that manner. Or I can say that I am writing another table in column, wn to the power 1, wn to the power 2, wn to the power 3. Then there is a table of 2, 2, 4, 6, 8, 10 in that manner. Then there is a table of 3. Basically, what would have come here? Here wn to the power 3 would have come. So 3, 6, 9 and so on. You don't need to remember this, okay? I am telling you, you don't need to remember this. In that manner, it will keep on going. So just this is the process. This is just the process, that this is how our DFT is calculated. So when they solve this particular thing, they got to know that we can solve it by matrix by this particular process. Is that clear to you or not? For 2-point DFT, for 3-point DFT and for 4-point DFT, we will directly remember the result. So you don't need to remember this particular thing. Maximum in the examination, they will ask 4-point DFT. Maximum 4-point DFT. They can ask 2-point DFT, they can ask 3-point DFT and they can ask 4-point DFT. And till 4-point DFT, you are calculating very easily by this method as well. By the matrix method as well, we will understand. So you don't need to remember this particular matrix. I am just telling that this is how the method was derived. This is what I am telling, okay? And similar thing we can do with IDFT as well. Similar thing we can do with IDFT as well. So in IDFT, what was the formula? 1 by n summation k goes from 0 to n minus 1 x of k wn to the power minus kn, right? Wn to the power minus kn. So here whatever the thing you were doing, whatever the positive points you were writing down, wn to the power 1, wn to the power 2, wn to the power 3, all these will become negative. Are you able to understand this point? I hope I will be able to copy. Yeah. So whatever the thing that you are writing down, in the similar way you need to write down table of 1, table of 2, table of 3, and in the similar way you need to write down. Just the point is that all these will become negative, 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 negative. What you need to calculate? You need to calculate x of n, x of 0, x of 1, x of 2 till x of n. And here what you will write down? X of 1, x of 2, x of 3 till this would be x of n minus 1, right? Till x of n minus 1. And here you will divide by 1 by, you will multiply with 1 by n as well. So this particular factor should also come here, which you should not be forgetting. There is very high chance that whenever they calculate IDFT, they forget this particular factor. Okay, so you should not be forgetting this particular factor. So I know that, sir, what kind of matrix is that, sir? This is very tough. No, nothing is tough. We will take the example now. With the example, it will be more clear. What you need to calculate? You need to calculate 2-point DFT. So what you need to do? Make the matrix. First, what I am calculating? Calculating the DFT. DFT. I am calculating the DFT. That means I am calculating x of k. Okay, guys. Here in the first page, I wrote down the formula wrong. Right? Here I forgot to divide by k. Right? Divide by n. This should have been divided by n. Are you able to understand this point? This is a big blunder from my side, right? X of n. In case of x a to the power j omega, when you write down x of n, what do? What will be the formula of x of n? The formula of x of n was 1 by 2 pi. Since x a to the power j omega is periodic, x a to the power j omega, a to the power j omega and d omega. And I told you DFT and DTFT are friends. Just the thing is that in the whole chapter, n will be just replaced with 2 pi. In the whole chapter, what will happen? N will be replaced with 2 pi, and surely this integration will be changed to summation. So integration has changed to summation, right? This has changed to summation, and limit will be, here the limit was from minus pi to pi, here the limit will be from 0 to n minus 1. This will happen in the whole chapter. So here I needed to divide by 1 by n, which was a very, very big blunder from my side. So 1 by n, right? It will be divided with 1 by n. So please improve it. I hope nowhere else I wrote it down. You can compare it here, no? 1 by 2 pi, so 1 by n, then integration, the summation, and then the same thing. X of k formula, and when you write down the x of n formula, here it will be divided by 1 by n. So 1 by n should come here. Okay. Yeah, so first I am calculating the DFT. So DFT. X of 0, x of 1 I need to calculate. So whenever you are doing the DFT you are doing, so nothing 1 by n would come. DFT means x e to the power j omega you are calculating. So when you calculate x e to the power j omega, nothing 1 by n, 1 by 2 pi, nothing will come, right? So that means here 1 by n will not be there. I need to make the matrix here, and here what I will write down, x of 0, x of 1. Is that clear to you? Right? Now, what did I tell you? What is this wn to the power 0? This is 1 1 1 1 only. This is also 1 1 1 1 1 only. So 1 1 1 1 you need to write down. Since they are 2 points, so this is also 2 cross 2 matrix. Basically, here it was n points, so this matrix will also be n cross n. This matrix will also be n cross n. And this matrix will be n cross 1. And this matrix will also be n cross 1. This matrix will also be n cross 1. And this matrix will also be n cross 1. So this will be also 2 cross 2 matrix. This is 2 cross 1 only. And this will be 2 cross 1. So 1 you need to write down in the row as well, in the column as well. This I have written. Here what will come? Here what will come? Wn to the power 1. You need to write on the table of 1, 2, 3, 4, but nothing else is left. Only one space is left. That is Wn to the power 1. What will come here? Wn to the power 1. But here what is Wn our? What is our Wn? Wn is equals to, what is the value of n? 2 point DFT. Value of n is 2. So that is W2. What is W2? e to the power j minus 2 pi by 2. Wn was, what was your Wn? e to the power minus j 2 pi by n. So what will be your W2? e to the power minus j 2 pi by 2. So e to the power minus j pi. That would be equals to minus 1. So this particular point is minus 1. So what is the matrix you are getting? Will you be able to remember this matrix? Yes, very easily, sir. I will be able to remember this matrix. 1, 1, 1, minus 1. There you go. X of 0, x of 1. Okay. So what you are getting? X of 0 as x of 0 plus x of 1, and x of 1 as x of 0 minus x of minus 1. So instead of writing x of 0, x of 1, here you would have written 1, 2. So 1 plus 2, that is equals to 3, and 1 minus 2, that is equals to minus 1. So x of k, 2 point x of k you are getting 1, 3 minus 1. So what I will write down? 2 point x of k. 2 point x of k you are getting 3 minus 1. This is your 2 point x of k. From here now, if you are having 2 point x of k, you need to calculate x of n, right? So now I am calculating IDFT. So what is the formula for IDFT? That means what you will be getting? You will be getting x of n. X of 0 you will get, x of 1 you will get. That would be equals to, here you will have the matrix. Here you will have capital X of 0, capital X of n, divided by 1 by n, right? In the first row, in the first row and in the first column, you will write down 1 1 1. Here what you need to write down? Wn to the power minus 1. So Wn to the power minus 1. W2 to the power minus 1. e to the power minus j 2 pi by n to the power minus 1. What you are getting? e to the power j pi. What is that value? Minus 1 only. So will you be able to remember the matrix? Very easy, no? For 2 point DFT it is very easy. 1 1 1, then other value will be minus 1. Here also the same thing is happening. 1 by 2 will be outside. One by 2 is outside. Final answer you are getting as, this is 1 1 1, this is minus 1. This is capital X 0, capital X 1. Small x 0, small x 1. So what is your small x 0 coming out to be? 1 by 2, x of 0 plus x of 1, and x of 1, 1 by 2, x of 0 minus x of n. That would be equals to 1 by 2, x of 0 plus x of n. What is that? X of 0 plus x of 1. So 3 minus 1, that is 2. 3 minus 1, that is 2. And 1 by 2, 3 minus minus 1. So this will be 3 plus 1. So you are getting 1 and 2. So what is your x of n? That is coming out to be 1, 2. But it is 2 point x of n, right? 2 point x of n. Otherwise, it should have been periodic. Actually, it should have been periodic, but it is 2 point x of n. Is that clear to you? Is this process clear to you? Right? So this is the process that we follow. So the point is, what is the point? That for 2 point DFT, you can remember the matrix. Very easily you can remember the matrix 1 1 1 then minus 1. Now for 3 point, okay, 3 point is not there, 3 point will come later on. Let's first calculate for 4 points. So 4 points DFT we need to calculate. First we are calculating that DFT. If we are calculating the DFT, that means we are calculating x e to the power j omega, that means x of k. So what will be our results? X of 0, x of 1, x of 2 and x of 3. And here what I will write down? X of 0, x of 1, x of 2 and x of 3, right? I told you 1 1 1 1 1 1 1. Now what did I tell you? Wn, what is the value of Wn here? 4 point DFT you need to calculate W4. So W4 to the power 1, W4 to the power 2, W4 to the power 3. So table of 1 I have written. Now I need to write down the table of 2. W4 to the power 2, W4 to the power 4, W4 to the power 6. Now I need to write down W4 to the power table of 3. W4 to the power 3, 6 and 9. There you go. Is that clear to you? Okay. I will have to add a page. So this is how we will make the matrix. Making the matrix is clear to you or not? DFT I need to calculate. I will think I need to calculate x e to the power j omega. That means nothing 1 by n will come here. If 1 by n is not coming, this will be the x0, x1, x2, x3 and x0, x1, x2, x3. So this will be the matrix. Is this matrix clear to you? We can simplify this matrix now. We will simplify this particular matrix. So just let me know what will be the value of W4 to the power 1. That would be equals to e to the power j. What is W4 to the power? What is W4? W4 is e to the power minus j 2 pi by n. That means W4 is e to the power minus j 2 pi by n, e to the power minus j pi by 2. So that is equals to minus j. So W4 is minus j. So minus j to the power 1. Minus j to the power 1. What that would be? Minus j only. What will be W4 2? That would be equals to minus j to the power 2. What that would be? Minus 1. What would be your W4 to the power 3? W4 to the power 3. That would be minus j to the power 3. What you will be getting? Plus j. Right? And what will be your W4 to the power 4? That would be equals to W4 to the power 0 and that would be equals to 1. Or minus j to the power 4, that would be equals to 1 only. Now these things, W4 to the power 6, what is that? That is equals to W4 to the power 2. W4 to the power 2 is equals to W4 to the power 6. Do you agree to this point? Because I told you one thing, W4 to the power 6 can be written as W4 to the power 4 plus 2. That would be equals to W4 to the power 4, W4 to the power 2. What is the answer you are getting? W4 to the power 2. Right? What this would be equals to? W4 to the power 8 plus 1. So W4 to the power 8, W4 to the power 1. What is W4 to the power 8? W4 to the power 8 can be written as W4 to the power 4, W4 to the power 4, W4 to the power 1. This would be 1, this would be 1. So this W4 to the power 9 is equals to W4 to the power 1. So where is W4 to the power 1? This is equals to W4 to the power 1. So in that manner, this will be equals to W4 to the power 2, W4 to the power 2, right? And this would be equals to W4 to the power 1. So what we can do now? We can simply copy it and we can write down the final results. So once we solve it, we will get the final results. So results we will get, but how will you write down in the examination? Are you going to solve everything? No, you are not going to solve everything. So in the examination, how will you write down? So you will make this matrix, then you will write down 1 1 1 1, right? For 4 point I am telling, for 4 point. You will make this matrix, you will write down 1 1 1 1. Now this much space is left, right? This much space is left. What is the middle of this space? This is the middle of this space. What is the space left? This is the space left. What is the middle of this space? This is the middle of this space, right? So right in the middle, what you will write down? 1. You wrote down 1, 1, 1, 1, 1. Right in the middle, you wrote down 1. And it should be surrounded by minus 1s. Okay. Now, you will build enough practice that here minus j would come. Even if you forget in the examination, you know that what should come here? Here, w4 to the power 1 should come. So, can you calculate? Surely, very easily, very fastly, I can calculate. It would be e to the power minus j pi by 2, that is equals to minus j. So, only confusion would be that, sir, this will be plus j or minus j. That you can forget in the examination hall. If you are forgetting it, very easily you can calculate this is minus j. But you will build enough practice, you will know that, sir, here minus j only will come. So, here minus j would come. Now, alternatively, you can write down, you need to write down minus j plus j, minus j plus j, plus j, minus j, minus j plus j. From here as well, I could have written. From where? Let's just say this is my minus j. So, alternatively, I need to write down. It's not that here we write down plus j. No, alternatively, what is the nearest to this minus j? Either this or this. So, anywhere you can write down plus j. Now, what is nearest to this plus j? That is this space. That would be minus j. And what is nearest to this minus j? This would be plus j. Is that clear to you? This is how you will write down this matrix. So, when you solve this matrix, the same results come. Is that clear to you? Again, let me write down what you will do. 1, 1, 1, 1, 1, 1. Then you will find the middle of the remaining portion. That would be 1 here. Then you will surround it by minus 1, minus 1, minus 1 and minus 1. Surrounded, right? Now, here you need to write down first, either it will be plus j or minus j. Even if you forget, very easily you can write down that, sir, here w4 to the power 1 should come, which would be equals to e to the power minus j 2 pi by 4, which would be equals to e to the power minus j pi by 2, and that would be equals to, sir, minus j. So, here minus j would come. Now, alternatively, I need to write down minus j, plus j, plus j, minus j, minus j, plus j. There you go. This is my matrix. Is that clear to you? So, without even thinking of anything like this, you should have the habit of writing down this particular matrix. Okay, all fine. Now, in place of x of 0, x of 1, x of 2, you write down the values. What all are the values? 1, 2, 3, 4. So, what is the x of k you are getting? So, 1 plus 2 plus 3 plus 4, what you are getting? 10. 4 point x of k I need to write down. 4 point x of k. Ten. 1 minus 2j minus 3 plus 4j. What you are getting? Minus 2 plus 2j. Next, 1 minus 2 plus 3 minus 4. What you are getting? Minus 2. And next, 1 plus, you need to solve the matrix. I know, I hope you know how to solve the matrix. 1 row multiply with the column, row multiply with column, row multiply with column, row multiply with column. So, 1 plus 2j minus 3 minus 4j. What you are getting? Minus 2 minus 2j. Minus 2 minus 2j. This is your 4 point x of k. Okay. Similarly, whatever that you have written here, the same thing you can write down for here as well, right? So, let's do it. One would come, and here I will write down the table of 1, 2, 3, but minus sign, 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 minus sign. What I am calculating? I am calculating IDFT. IDFT means what will be my final results? My final results will be x of 0, x of 1, x of 2, x of 3. And here I will write down x of 0, x of 1, x of 2, x of 3. But just as you saw that here there are small letters, that means you are calculating x of n. So, you need to divide by 1 by n. So, this you don't need to forget. Okay. Now, I will just tell you the method that how this matrix, whatever the matrix came into action, you can get these values. What will be the value of w4 to the power minus 1? You can get from here. But I will just tell you that how to remember the result, how to remember the final result, how to remember the final matrix. So, we are just going to write down the final matrix now. So, again the same process, 1, 1, 1, 1, everything you will write down. Then again the ditto same thing, right in the middle what you will write down? 1. Right in the middle you wrote down 1. Again it will be surrounded by minus 1, minus 1, minus 1, minus 1. Just opposite thing what you need to do. Here this was minus j, here it would come plus j. So here also you may get confused that sir plus j minus j I forgot. So you know that here what should come? W4 to the power minus 1 sir. Sir what should come? Here W4 to the power minus 1 should come sir. So a to the power minus j 2 pi by 4 to the power minus 1. So that would be equals to e to the power j pi by 2. So that would be equals to plus j. So here plus j would come. Now same thing. Alternatively plus j minus j plus j minus j. There you go. Okay, let's keep it here. Now here I need to write down the values of x of zeros that we have already got. So these are the values. Let's just say this x of k was given. So 10 minus 2 plus 2j minus 2 minus 2 minus 2j. Okay. Now I need to write down my x of n. So 1 by 4 outside. Now 10 plus minus 2 minus 2j minus 2 minus 2 minus 2j. Basically 10 minus 2 plus 2j minus 2 minus 2 minus 2j. So this and this get cancelled. What you are getting? क्या बात है भाई? 4, yeah, okay. Sorry, 4 only you are getting, right? 10 minus 6, that would be 4. Now you will follow this process. Basically you will keep on following this process. You will get 4, 8, 12, 16. Let's calculate for this row. What you will be getting? 1 will be multiplied with 10 plus j will be multiplied with minus 2j minus 2. Then minus 1 will be multiplied with minus 2. That would become plus 2. Then minus j will be multiplied with plus 2j minus 2. Right? So this and this got cancelled. This and this got cancelled. So you are getting 8. So for the second row as well, I have told that you are getting 8. Then you will get 12 and then you will get 16. And 1 by 4 is outside. So what is the value of x of n? That is coming out to be 1, 2, 3, 4. Again one mistake I am doing. I should write 4 point x of n. What is this? 4 point x of n. Is this clear to you? So this is the process. So will you be able to remember the matrix for 4 cross 4? Will you be able to remember the matrix for 4 point x of n? Yes. And will you be able to remember the matrix for 2 point x of n? That also you will be able to remember. So this is how matrix should be remembered by you. But it should also be clear that what should come here. Just for the sake of remembering the matrix, don't forget the fundamental concept. Fundamental concept was W4 to the power 0, W4 to the power 0, table of 1, table of 2, table of 3. Because here you will not get the standard results. In 3 point DFT, you don't get the standard results. What we need to calculate? We need to calculate the DFT. So here x of 0, x of 1, x of, wrong I am writing. I need to write down capital X of 0, capital X of 0, capital X of 1, capital X of 2. So 1, 1, 1 I can write down very easily. But here what will come? W3 to the power 1, W3 to the power 2, W3 to the power, table of 2 I need to write down now, W3 to the power 4. So what is W3? That is e to the power minus j 2 pi by 3. So now there is an issue because W3 to the power 1, what that would be? E to the power minus j 2 pi by 3. What will be W3 to the power 2? That would be equals to e to the power j minus 4 pi by 3, right? W3 to the power 1, what is that? E to the power minus j 2 pi by 3. What will be your W3 to the power 2? Can I write it down in this manner? W3 to the power 3 minus 1. So W3 to the power 3, W3 to the power minus 1. So it would be equals to W3 to the power minus 1. Is that clear to you? So this can be written as W3 to the power minus 1. What about this one? W3 to the power 4. It can be written as W3 to the power 3 plus 1, W3 to the power 3, W3 to the power 1. So this would be equals to W3 to the power 1. So this is equals to minus 1, this is equals to plus 1. So what we can do, we can reduce it, and here what will come? 1, 2, minus 1 will come. So solution, like you can solve it on your own. So that's the reason that they will rarely ask about 3 point DFT. They don't ask much about 3 point DFT because calculation would be a bit complex. right? So this is your e to the power j 2 pi by 3, e to the power j 2 pi by 3, and here what you will get, e to the power minus j 2 pi by 3. Here what you will get, w3 to the power 2, e to the power minus j 2 pi by 3, and here you will get e to the power j 2 pi by 3. So what will be your capital X of 0? That is coming out to be 1 plus 2 minus 1. 1 plus 2 minus 1, that is equals to 2. What is x of 1? So 1 plus 2 e to the power j 2 pi by 3 minus e to the power minus j 2 pi by 3. You can solve it. X of 2, 1 plus 2 e to the power minus j 2 pi by 3 minus e to the power minus j 2 pi by 3. Sorry, not minus j, plus j 2 pi by 3. So this also you can solve. Okay, solve this one, solve this one. This is already solved, solve this one. And in the same manner you can calculate IDFT as well. In the same manner you can write down this matrix, and you can get the IDFT. For IDFT what will happen? This negative sign, this negative sign, this negative sign, this negative sign, and here 1 by 3. This kind of matrix you will get. Okay, so IDFT also you can calculate. But the important part is, for 4-point DFT you should know what is the matrix, and for 2-point DFT as well you should know what is the matrix. We will solve a lot of problems, it will be clear to you. Now more points we are going to see. This time our x of n is periodic. Previously what we used to see, our x of n was 4-point x of n, 4-point x of n, 2-point x of n, 3-point x of n. Now x of n is periodic, and you need to calculate 4-point DFT of x of k, and then you need to calculate IDFT of x of k. What do you think? What will be your answer? Think about it. For thinking about it, I am giving you a hint. First you write down the basic formula of x of n, x of k. What is the basic formula? Summation n goes from 0 to n minus 1 x of n e to the power minus j 2 pi by n kn. This is the basic formula. Now when you write down the expression, let's just say I open the expression of x of k. So what I will do, first I will put n equals to 0. So I put n equals to 0. Then I put n equals to 0 here. What I will be getting, e to the power 0, that would be 1. Then I will put n equals to 1. Let's just, n minus 1 will be equals to 3, right? Because what is n? N is n-point DFT, or it would be the period. Or it would be the period, right? What you need to calculate, 4-point, sorry, what I said, period, that is wrong. N is not the period. N is this value, 4-point DFT. So what is the value of n? N is equals to 4. What is n? N is this value. I said period, that was wrong. Really sorry guys. 4-point DFT. So value of n is 4. So here what will come? 4 minus 1, 3, right? So what you are going to put? X of 0 plus e to the power minus j 2 pi by n k into 0. That would be 0 only. Then what you are going to put? X of 1 e to the power minus j 2 pi by n, value of n is 4, k, value of n is 1. Then x of 2 e to the power minus j 2 pi by n, k into 2. Then x of 3 e to the power minus j 2 pi by n, k into 3. This will be the answer, right? What will be the answer for this question? The same process can you do for this question? Yes. If my x of n was, if x of n was 1, 2, 3, 4 only, if it was only 1, 2, 3, 4, so what would have been your x of k? Same thing you would do here. X of 0 would come, then x of 1 would come. The same thing you will write down. Will the value of n will change? No. What I am finding? 4-point x of k, 4-point DFT. 4-point DFT I am finding, 4-point DFT x of k I am finding. So again 0 to 3 limit would go. Basically the point is, even if x of n is periodic, here it was aperiodic. So even if it is periodic or aperiodic, actually you are taking the samples from 0 to 3 only, no? Is that clear to you? You are taking samples from 0 to 3 only. That means you are taking 0, 1, 2, 3. And here as well 0, 1, 2, 3. So if I say I need to calculate 4-point DFT, that means x of n should be converted to 4-point x of n. Is that clear to you or not? What I am saying? Again, let me repeat the statement. If I want to calculate 4-point DFT of x of k, then x of n should be converted to 4 point x of n, and after that I should do my calculation. Because in the calculation of x of k, I need to know only x of 0, x of 1, x of 2 and x of 3. So my matter of concern are only x of 0, x of 1, x of 2 and x of 3. Is that clear to you? So when I say that I need to find 4 point x of k for periodic x of n, that means what should happen? What should happen? How will I solve it? So what I will do is that x of n, from x of n, what I will get? 4 point x of n. 4 point x of n. And I told you, and you already know that this from periodic x of n, what you will get? 4 point x of n, and you already know how to get 4 point x of n. Starting from the origin, you need to take 4 samples. So 4 point x of n would be equals to 4 point x of n would be equals to 1, 2, 3, 4. And if you have got this particular thing, you calculate the DFT of this particular thing and you will get your answer. You calculate the DFT of this particular thing and you will get the answer. So DFT of a periodic sequence and aperiodic sequence are same only. DFT of a periodic sequence and aperiodic sequence are same only, but not always same. What if I would have given this example that your x of n is 1, 2, 3, 1, 2, 3, 1, 2, 3 and it will keep on repeating. What if I have given this example and I ask you to calculate 4 point DFT of x of k? What I am asking? Calculate the 4 point DFT of x of n. 4 point DFT of x of n. So what you will do? Sir, first I need to get 4 point x of n. What would be my 4 point x of n? Because I know that in the formula x of 0, here also it is repeated, here also it is repeated. Because I know that in the formula x of 0, x of 1, x of 2 and x of 3 will be used. That means I need to calculate 4 point x of n starting from x of 0. So 1, 2, 3, 1. So you would have calculated the 4 point DFT of this particular sequence. Is that clear to you? Are you able to understand this point? So these examples will come. These examples later on will come in this lecture only. Okay, I think these are the next example only. This is 4 point DFT in sinusoid, 2 point DFT. Yeah, this particular question is coming. So yeah, these kind of example, whatever that I discussed, that x of n is periodic with 3 samples. Here it was, luckily it was periodic with 4 samples only. Periodic, what was the period? 4 samples only. So 1, 2, 3, 4, 1, 2, 3, 4 you took and you got your answer. What if it was periodic with 3 samples? Then the 4th sample would have been the 0th sample. Are you able to understand this point? The 4th sample would have been the initial sample only. What if it was 1, 2, 3, 1, 2, 3? So you would have taken 4 point x of n as 1, 2, 3, 1. Is that clear to you? And what if x of n was something like this? What if x of n was 1, 2, 3? This is your 3 point x of n. And now I ask you to calculate 4 point DFT. What I ask you to calculate? 4 point DFT. So what will be your 4 point x of n now? Because you know that for calculating 4 point DFT, you need to get 4 point x of n. What will be your 4 point x of n? 1, 2, 3. 3 points are there. What will be the 4th point? 1. No, it will be 0. Because x of n is having only 3 non-zero samples. The next samples are 0. 4th sample is 0, 5th sample is 0, 6th sample is 0, minus 1 sample is 0, minus 2th sample is 0. There is a difference between a periodic x of n and there is a difference between a 3 point x of n. I told you very beginning in the lecture of DTFS. Before studying DTFS, we studied these terms. What is the meaning of periodic x of n? What is the meaning of x of n modulo n? And what is the meaning of n point x of n? So this is your 3 point x of n. But from 3 point x of n, you need to get 4 point x of n. Because you need to calculate 4 point DFT. So you need to get 4 point x of n. So what will be your 4 point x of n? That would be 1, 2, 3, 0. But if it was periodic, if x of n was periodic, then what would have been your 4 point x of n? 1, 2, 3. Since it is periodic, that means 4th sample is 1. Very, very good difference. If this question is coming in the examination hall, 99.95% aspirants are going to fail. Okay, and very soon it is coming. I can write it on paper very soon, either in 2026, 2027 or in 2028. That x of n is there, which is periodic, and x of n is there, which is n point x of n. So both are different thing. Okay, and both will give you different 4 point x of n. So similar example we are going to see in this lecture only. Okay, here I have just given you the reference that how we are going to solve. So is that clear to you? Okay, all fine. So yeah, here if I calculate the DFT, what will be the answer I will be getting? So this is very rough work I have got. So answer I will get the same. What will be the final answer? If I say what will be my final answer? Final answer would be the same that I have got previously. That would be this answer. Tan minus 2 plus 2j minus 2. Tan minus 2 plus 2j minus 2 minus 2 minus 2j. This answer would be the same. Here luckily it was same. Because here also period was n point DFT only they asked. So that means I need to get n point x of n only. So when I got n point x of n, it was 1, 2, 3, 4 only. Which answer I have already calculated? This was tan minus 2 plus 2j minus 2 minus 2 minus 2j. Is that clear to you? All good? All fine? We will see this kind of question, but I need to take a break because it's been around 70 minutes I am speaking continuously. So I will take a break. You find out 4-point DFT of this particular sequence. And I told you one thing, whenever the question is coming from sinusoid or cosinusoid, what you will do? You will trust the formula of x of n, not x of k. Do you remember this thing? Whenever the question is coming from sinusoid or cosinusoid, whether it is DTFS or DFT, you will trust the formula of x of n, which is equals to 1 by n, k going from 0 to n minus 1, x of k e to the power j 2 pi by n kn. So 1 by 4, k going from 0 to 3, x of k e to the power j 2 pi by 4. 4-point DFT. What is the value of n? For value of n will depend on this? No. Value of n is 4. 4-point DFT. 4-point DFT. 4-point DFT. Right? Pi by 2 kn. Now you will be able to compare. Just expand your x of n. What you can do? Expand your x of n and then you compare with this particular expression. You will get your answer. Okay. I will take a break and then I will come back. Yeah, welcome back. So did you try this question? So x of n is given. Now we can break down our x of n since it is cosinusoid. So we can break it down in this manner, right? X of n is cos pi by 2n. So e to the power j theta n plus e to the power minus j theta n divided by 2. Okay. Right. Now you can see that here positive frequency is also there, negative frequency is also there. But if I put the values of k only positive, then I will not be able to get the negative frequencies. So since it is going from 0 to 3, can I take it from minus 2 to 1? Basically, I need to take 4 samples and I know that x of n is periodic. Sorry, x of k is periodic. I know that x of k is periodic. Right? Periodic. Periodic with 4. Periodic with 4. It will be periodic with 4. So if I am taking from 0 to 3, I can better take from minus 2 to 1, right? I can take from minus 2 to 1 as well. Basically, I need to take 4 samples. So from anywhere I can take, right? So what I would do is that I would interchange it from k going from, I can take from minus 1 to 2 as well. Anyway, whatever that I want to take, I will take from minus 2 to 1. So 4 samples will be minus 2, minus 1, 0 and 1. So these 4 samples would be there, right? X of k e to the power j pi by 2 kn, and it can be opened as 1 by 4 x of minus 2 e to the power minus j. If I put minus 2 here, what I am getting? Minus pi n. Am I getting something like this? No. X of minus 1. X of minus 1, if I put k equals to minus 1 if I am putting, so x of minus 1 e to the power minus j pi by 2n. Then I put x of 0. So e to the power j pi by 0, and then I put x of 1 e to the power j pi by 2n, right? So basically what you can see here is that x of minus 2 by 4 is coming out to be 0 because e to the power minus j pi n is not here. So x of minus 2 by 4 is coming out to be 0. That means x of minus 2 is equal to 0. What about x of minus 1 by 4, x of minus 1 by 4. So e to the power minus j pi by 2n, e to the power minus j 2 pi by 2n, that is coming out to be 1 by 2, right? X of 0 is also, x of 0 divided by 4 is also coming out to be 0, and x of 1 by 4 e to the power j pi by 2n, e to the power j pi by 2n is coming out to be 1 by 2. So what you are getting? X of k, 4 point x of k, if I write down 4 point x of k, if I write down 4 point x of k, so what I am getting? Minus 2 is, at minus 2 you are getting 0. Basically, if you are writing 4 point x of k, 4 point x of k, that means you need to start from k equals to 0 only, no? So what is the value at k equals to 0? What is the value of x of 0? So you go to know that x of 0 is equals to 0. X of 0 is equals to 0. What is the value of x of 1? X of 1 is coming out to be, from here you can see that x of 1 will be equals to 2. So x of 1 is coming out to be 2. What is the value of x of 2? So from here you could not get the value of x of 2. From here you could not get the value of x of 2, but you know one thing, that if x of minus 2 is 0, then x of minus 2 plus 4 will also be equals to 0 only, because it is periodic with 4. So x of 2 is 0. What about x of 3? What about x of 3? So x of 3. What is the value of x of minus 1? X of minus 1 is equals to 2, and that would be equals to x of minus 1 plus 4. So that would be equals to x of 3. So value of x of 3 is equals to 2. Similar kind of process we did in the DTFS as well. So this is simply DTFS only. For 4 point x of k, if I need to write down, so x of 1 is non-zero and x of 3 is non-zero. There you go. This is the answer. Is this clear to you? 0, 2, 0, 3. This is the answer you are getting. Ideally, here we go to know that x of 1 is non-zero and x of minus 1 is non-zero. Both are having the values of 2. Both are having the values of 2. But the point is, what is the point? That if we are writing down 4 point x of k, that means I am going to write down from 0 to 3, k equals to 0 to k equals to 3. That means 4 points I need to write down, right? Oh, the value is 2. Sorry guys, the value is 2. So k equals to 1 is non-zero and k equals to minus 1 was non-zero, or you can say k equals to 3 is non-zero. Is that clear to you? All good, right? Okay. So this is your x of k. This is the final answer you are getting. This is the final answer we are getting. Okay, very simple process, very straightforward. Whenever there is a sinusoid or cosinusoid, you will not go to the formula of x of k, but you will go to the formula of x of n, and then you will compare. 2 point x of n is given. You need to find its 4 point DFT. 2 point x of n is given. Find 4 point DFT and then find IDFT of x of k. Is that clear to you what I am asking? All fine. So 2 point x of n is given. 2 point x of n is given. That is 1, 2. What you need to find? You need to find 4 point DFT. So now you let me know what is the value of n. 4 point DFT x of k you need to find. What is the value of capital N here? 2 or 4? I told you 4 point DFT value is 4. Now you just let me know what will be your x of k. For x of k, n going from 0 to n minus 1, x of n e to the power minus j 2 pi by n kn. Say yes or no. So here if I put the values of n, what I would need? X of 0, x of 1, x of 2, x of 3. That means I need 4 point x of n. What do I need? 4 point x of n. I am given 2 point x of n. That means x of 0 is 1. X of 1 is 2. What is x of 3? Sorry, what is x of 2? What is the value of x of 2? X of 2 is 0. And what is the value of x of 3? That is also 0. So 1, 2, 0, 0 you are getting. This is your 4 point x of n. And from here you need to calculate x of k. But guys, wait a second, I will come back. Okay, just wait a second. Yeah, so 4 point x of n is this 1, 2, 0, 0. What we need to calculate now? We need to calculate 4 point x of k. 4 point DFT we need to calculate. So we got to know that x of 0 is 1, x of 1 is 2, x of 3 is 0, and x of 4 is x of 2 is 0 and x of 3 is 0. So this would be our 4 point x of n, because we would require the values from 0, 1, 2, 3. Right? So we know how to do this calculation. What we need to calculate? We need to calculate what we need to calculate? One, two, zero, zero, right? And we need to calculate the values of x of k, that would be x of 2, x of 3, right? You write down the matrix 1, 1, 1, 1, 1, 1, 1, right in the middle 1, surrounded by minus 1, minus 1, and starting with here, sir, plus j minus j, what would come? Minus j would come. Then plus j here, minus j here, and plus j here, right? So what would be your x of k? 4.xk. 4.xk. So what that would be? 1 plus 2, 3, right? 1 minus 2j, 1 minus 2j. Next, 1 minus 2, that would be minus 1, minus 1, and next would be 1 plus 2j, 1 plus 2j. So this would be your answer. Is that clear to you? Now from here you need to calculate IDFT. So what you can do is that either you can apply the matrix, but let me know what should be the answer. What would be the answer? If I calculate IDFT, of inverse discrete Fourier transform of x of k, what do you think what will be the answer? Here it is not 4.x of k, it is purely x of k. What is your x of k? What is your x of k? Your 4.x of k was this one. This was your 4.x of k. But what is your actual x of k? Your actual x of k is periodic. Your actual x of k is this 3, 1 minus 2j, minus 1, minus 1, 1 plus 2j, and so on. This is your actual x of k, where this is your k equals to 0. So what would be your IDFT? This will be periodic. IDFT, this will be periodic plus discrete. Periodic plus discrete. What would be your IDFT? It would be periodic plus discrete. So what would be the answer you will be getting? What do you think? Let's just say I am calling IDFT of inverse discrete Fourier transform of x of k as x bar n. So what is the answer of x bar n? What do you think? It will be periodic as well. It will be discrete as well. So what will be repeated? 1 2 1 2 will be repeated, or 1 2 0 0 will be repeated? 1 2 0 0 will be repeated, because you find out the Fourier transform of this particular function. Not Fourier transform, discrete Fourier transform. You find out that discrete Fourier transform of this particular function, and now you are taking the IDFT. That means this particular function will be periodic. It will not be 1 2 1 2 1 2. It will be 1 2 0 0 1 2 0 0 1 2 0 0. And we can apply the formula as well. From the formula as well we can get the answer. But conceptually you understood that what should be repeated? 1 2 0 0, 1 2 0 0, 1 2 0 0, 1 2 0 0. This will keep on repeating with the center being at 1. Is that clear to you or not? So we can check it. We can check it. How we can check it? By finding out the inverse Fourier transform. We know how to find out the inverse discrete Fourier transform. IDFT, how to find out the IDFT, that we already know, right? So you need the values of x of 0, x of 1, x of 2, x of 3, right? So 1 by 4, 1, 1, 1, 1, 1, 1, 1, right in the middle 1, then surrounded by minus 1, minus 1, minus 1. You are taking IDFT starting with j, minus j. In the longer run, it might be a problem that you would be forgetting, sir, it would be plus j or it would be, sir, minus j. So what you would do, you will check the values. How will you check? E to the power j, here it would be w4 to the power minus 1. So in that manner, you can check it. Now what is the answer? 3, 1 minus 2j, minus 1, 1 plus 2j. So when you check, what you will be getting? your x of n, 4 point x of n we will be getting here, right? Only 4 points we will be getting. So my 4 point x of n I will be getting, that would be coming as 3 1 minus 2j, 3 minus 1, 3 plus 1 minus 2j, minus 1 plus 1 plus 2j, 4, and 1 by 4 is also there. So 1 by 4 is already there. Here I am getting 4. In the next one, what I will get? 3 is already there, plus j plus 2 plus 1 minus j plus 2, right? 8. Next, 3 minus 1 plus 2j, minus 1 minus 1 minus 2j. So minus 1 minus 1 minus 1 minus 3, 0. And next one also you will get 0 only. So what is the answer you are getting? 1 2 0 0. Okay. So answer is 1 2 0 0. You can see that it was your 4 point x of n, and if you want to calculate your actual x of n, then you know that it will be periodic. So how it will be periodic? 1 2 0 0, 1 2 0 0, 1 2 0 0. This is how it will be periodic. This is your actual x of n. Is that clear to you? Is that all clear to you? So process is clear, no? That 2 point x of n was given, which was not periodic. Then you got to know that you need to find 4 point x of n. You need to find 4 point x of k. You need to find 4 point DFT. That means you need to pad up the zeros. This is known as zero padding. So I padded up 2 more zeros and I find out the final answer. And when I take the inverse DFT, that means this particular thing will be periodic. So without even doing this calculation, I could have told that answer would have been 1 2 0 0 1 2 0 0 without doing any kind of calculation. So if 4 point x of n is this, then I am writing down periodic one as bar. All good? All fine? Okay. 12 point DFT you need to calculate. What you will do? I told you one thing. Sinusoid, cosinusoid always go by the basic formula of x of n. So always I will go by this formula and I will compare. That's it. Nothing else. So what is the formula? X of n is equals to 1 by n. What is the value of n? 12. Summation k goes from 0 to 11, x of k e to the power minus j 2 pi by n kn, right? It can be written as 1 by 12 summation k goes from 0 to 11 x of k, sorry, not minus sign, because n is here to here, answer would be positive. If you remember the tricks, then there is no chance of minor mistake, right? Now what is my x of n? Now my x of n e to the power j pi by 2n plus e to the power minus j pi by 2n divided by 2 is equals to 1 by 12. Now will you write down all the functions? No. Just use your brain. How will you use your brain? That what do you want? You want pi by 2n. Here this particular thing should be equals to pi by 2n. That means what will be the value of k? What should be the value of k? So from here you can see that value of k would be equals to 3, right? One value of k you are getting as 3. What could be the other value of k? That would be minus 3 actually. The other value will be minus 3. Why is that so? Because you want minus pi by 2n should be equals to, you will be basically comparing these things, no? Exponentials to exponentials. So you will be comparing exponentials to exponential. So what you are getting? K is equals to minus 3. So you would need k plus 3 and minus 3, right? And 12 samples you need to take. So can I take the samples from minus 6 to 5? Here I was writing down 0 to 11. So can I make it from minus 6 to 5 as well? Because I know that x of k is periodic. X of k is periodic. Periodic with 12. Periodic with 12. Why periodic with 12? X of n is periodic with 4. x of n, what is the period here? That would be, period here is 4. So x of n is periodic with 4, but x of k will be periodic with 12, because you can see the formula, no? Are you able to understand? You are finding 12 point DFT, no? So this will be periodic with 12 only. This will surely be periodic with 12. X of n is periodic with 4, this will be periodic with 12. Right? So if the limit was going from 0 to 11, I can interchange the limit from -6 to +5 as well. -6 to 5. Right? Because 12 samples I need to take. -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Yes. This is how I can interchange the limit. Clear? Right? So here basically x of -3 e to the power, if you put -3 here, what you are getting? This particular thing you are getting, and if you put x of 3, you are getting e to the power j pi by 12. Other things will also be there, like x of -1 will also be there, but there is no meaning of that, no? X of -1 will also be there, x of +1 will also be there, x of +1 will also be there, and other things, x of 0 will also be there. All these things are having no meaning, because all these will be 0. All these will be 0, because only frequency components are pi by 2n, pi by 2n, minus pi by 2n, and minus pi by 2n. So all these will be equals to 0 only. So when you compare, what did you get to know is that your x of -3 is equals to, x of -3 divided by 12 is equals to 1 by 2. So from here, x of -3 is coming out to be 6, and x of 3 divided by 12 is also equals to 1 by 2. So from there, x of 3 is also coming out to be 6. Now it is periodic with 12. So x of -3 could be written as -3 plus 12. That would be x of 9. Right? And it is equals to 6. So what you are getting? What you are getting? So your x of k is 0, 1, 2, x of 3. X of 3 is 6. X of 3. This is your k equals to 0. What I am writing down? I am writing down 12 point x of k. So if I need to write down 12 point x of k, that means from k equals to 0 to 11 I need to write down. So 0, 1, 2, 3. X of 3 is 6. Then x of 3 is 6. X of 3 is 6. Then x of 4, x of 5, x of 6, x of 7, x of 8, x of 9 is 6. X of 9 is 6. X of 10, x of 11. There you go. This is the answer. Okay. So 12 point x of k is 0, 0, 0, 6, 0, 0, 0, 0, 0, 6, 0, 0. This is the final answer. Is that clear to you? Right? Very simple process. Whenever sinusoid, cosinusoid is coming, whether it is DTFS or DFT, always go by the basic formula of x of n. DTFS, DFT, or even if it is any kind of question, always sinusoid, cosinusoid should be converted to their complex exponentials, and then they should be solved. Right? Okay. Next question. 3 point x of n is given. Y of n is defined as x of n modulo 3. You need to find 4 point DFT of y of n, and then you need to find its inverse DFT. Is that clear to you? Okay, question is clear to you. 3 point x of n is given. First, you need to find y of n. So what would be your y of n? Y of n is x of n modulo n. That means this periodic with 3. Right? This I told you. X of n modulo n means whatever the x of n is given, that should be periodic with 3 now. So starting with n equals to 0, so 1, 2, 3, 1, 2, 3, 1, 2, 3, that will keep on repeating. 1, 2, 3, 1, 2, 3, 1, 2, 3. This will keep on repeating. This will be your n equals to 0. So this is your yn. What you need to find? 4 point yn you need to find. Sorry, 4 point DFT of yn, that means 4 point y of k you need to find. 4 point y of k you need to find. That means for that you would require 4 point y of n. Then only you can find 4 point y of k. Because you remember the formula. In the formula, what will happen? Y of 0 will be used, y of 1 will be used, y of 2 will be used, y of 3 will be used. That means you require 4 point y of n. What that would be? 1, 2, 3, 1. 1, 2, 3, 1. Now what you need to find? 4 point y of k. This is the task now. So can you find 4.5 of k from this? Yes, make the matrix and do the job. Matrix have been already made. I will just copy now, because again and again I have to write down the matrix. This is the matrix which have been already made. I will just copy this matrix. So this matrix you can write down on your own. What is the sequence? Sequence is 1 2 3 1. So 4 point, and also it is y of k, right? It is y of k. So 4 point y of k is equals to 7 1 minus 2j minus 3 plus j. So that would be minus 2 minus j, minus 2 minus j, right? 1 minus 2j minus 3 minus j. So minus 2 minus j. 1 minus 2 plus 3 minus 1. So it would be 1. And 1 plus 2j minus 3 minus j. So minus 2 plus j. This is your 4 point y of k you are getting. Is that clear to you? 4 point y of k. Now what they are asking? If 4 point DFT of y of n is y of k, then you need to find out I DFT y of k. Inverse discrete Fourier transform of y of k. So what that would be? Inverse discrete Fourier transform. This is your 4 point y of k. What would be your actual y of k? That would be repeated, right? 7 minus 2 minus j, 1 minus 2 plus j. 7 minus 2 minus j, 1 minus 2 plus j, right? Now if I find the IDFT, what I will get? 1 2 3 1 1 2 3 1, it will keep on repeating, right? If I find the IDFT, what I will be getting? Y of n, that would be 1 2 3 1 1 2 3 1 1 2 3 1 1 2 3 1, and will keep on repeating, where the center is this. And if someone asks you what is your 4 point y of n, look, every process is clear, every single line is clear to you, every kind of question is clear to you. Till now they have only asked a very simple question, that they will give you 4 point x of n, they will ask you 4 point x of k. But these kind of things, if they want to introduce that 3 point x of n is there, then they could have directly asked 4 point x of k. Then this kind of thing would have happened. This kind of thing, that they gave 2 point x of n, they asked 4 point x of k. That means you just need to pad up 2 zeros. But here we are not padding up the zeros. 3 point x of n is given, but the y of n that we created, that is actually periodic. And now we need to take 4 samples. We need to find 4 point y of n. That means we need to take 4 samples starting from n equals to 0. So 1, 2, 3, 1, these 4 samples we have taken, and with respect to that we have find out our y of k. So this particular question was there. Now if y of k is given, and if you want to calculate IDFT, so what you will get? You will get it periodic. IDFT will be periodic. So it came with respect to 1, 2, 3, 1. So 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1 will be repeated. Is this process clear to you? Okay. Now student would be thinking that, sir, why you are doing so? That after finding DFT, why you are calculating IDFT? It is pretty obvious that it will be repeated only. Yeah, I know that it is pretty obvious, but still, just for building up the concept, we are seeing this kind of question. Okay, because this kind of question can be coming in the examination. 3 point x of n is given, y of n is given. For creating x of n from y of n, now you will be able to understand that why we were seeing this question. Okay, x of n is given, y of n is given. For creating x of n from y of n, what process you will follow? So options will be there. That first I will calculate DFT of x of n, and then I will do this thing, then I will do this thing, then I will take IDFT. So these kind of 4 options can be mentioned, and one of the option would be correct. So what you need to make? 3 point x of n is given, that means it is aperiodic, right? Now here what is happening? It is periodic with 5. 1 2 minus 1 1 2, 1 2 minus 1 1 2, 1 2 minus 1 1 2. So your y of n is periodic with 5 points. If I ask you what is your 5 point y of n, will you be able to write down 5 point y of n? Yes, that would be, sir, 1 2, minus 1, 1, 2. Is that clear to you? Okay. How I can get this? If I get from 3 point x of n, if I calculate 3 point DFT, so I will get 3 point y of k, and from 3 point y of k, 3 point y of k, if I calculate I DFT, then things might not work for me. So here what I can do, first I need to make it periodic with 5. First I need to make it periodic with 5. How will I make it periodic with 5? I need to repeat it. I framed the question and now I am only forgetting it. That what should be the way? I only made the question, now I am forgetting it. If options were there, then it would be easy for me. But now you need to think that what you can do. From 3 point x of n, if you directly calculate 5 point DFT, then what you will get? Like from here only, from x of n, if I directly calculate 5 point DFT, so what I will be getting? 1, 2, minus 1, 0, 0. Like in the inverse DFT. Basically, this would be my 5 point x of n. But this is, I don't want. I want my 5 point x of n to be 1, 2, minus 1, 1, 2. So that when I calculate its DFT, and after that I calculate its inverse DFT, so I will get the same thing. Right? So anyhow, first I need to make it periodic. What I need to do? I need to make it periodic. Yeah, I understood. I understood what should be the process. So let's see what I will do. I am having x of n, 3 point x of n I am having. What I am having? 3 point x of n I am having, which is 1, 2, minus 1. Now what I will do? I will calculate 3 point DFT. What I am doing? 3 point DFT I will calculate. So what I will get? Something value I will get. 3 point DFT I calculated. Some value I will be getting, I don't know. Now from here, if I calculate IDFT, what I will get? Something I will get which will be periodic. Which will be periodic. Now from here, if I get IDFT, this is periodic plus discrete. Periodic plus discrete. Now from here, if I calculate IDFT, what answer I will be getting? The same thing but repeated, right? 1, 2, minus 1, 1, 2, minus 1, 1, 2, minus 1, and so on. Being center here. Is that clear to you? All fine? Till this process, everything is fine. 3 point x of n was there. You created 3 point DFT. You created 3 point DFT. Some answer you got, you don't care about that. But when you calculated the IDFT, that means it will be periodic with 3. This x of n will be periodic with 3, right? Now what you will do? Now you will calculate 5 point DFT. For this x of n, for this particular thing, what you are getting? X bar of n. Let's call it x bar of n. This is your x bar of n. This is your x bar of n. So x bar of n you are getting, and now with respect to this you calculate 5 point DFT. With respect to this you calculate 5 point DFT. So what will happen? You will take 5 samples. That means your 5 point x bar n would be what? 5 point x bar n would be 1, 2, minus 1, 1, 2. And with respect to that you will calculate 5 point DFT. So something you will be getting, I don't know which will be periodic with period 5. Periodic with period 5 plus discrete. And now what you can do? You can take IDFT. So if this is periodic with 5, so IDFT will also be periodic with 5. So basically these samples will be repeated. Is this process clear to you? 1, 2, minus 1, 1, 2. 1, 2, minus 1, 1, 2. 1, 2, minus 1, 1, 2, and so on. With this being the origin. Did you understand what we are doing? Now if you are following the lecture with good amount of patience, then you will be able to understand. 1, 2, minus 1 was there. I took 3 point DFT. DFT will always be periodic. X of k will always be periodic. Diagram should be there in your mind. The diagram that you saw on the first page, that diagram should be there in your mind. X of k will be periodic, right? Now if I take the inverse, DFT, so what I will get? I will get a periodic pattern only. 1, 2, minus 1, 1 2 minus 1 1 2 minus 1 1 2 minus 1. Now what I thought, if I take 5-point DFT for this particular pattern, for a periodic sequence as well I can take DFT, right? So for this particular pattern, if I take 5-point DFT, what I will get? I will be taking the DFT of 1 2 minus 1 1 2, because in the 5-point DFT x of 0 will be used, x of 1 will be used, x of 2 will be used, x of 3 will be used, and x of 4 will be used. And then what I will do, once I have taken the 5-point DFT, what I will do, I will take IDFT. So options could be mentioned in this manner, that there is some 3-point x of n, you will take 3-point DFT and then you will calculate IDFT. Whatever the sequence you get after calculating IDFT, you will again take 5-point DFT of that, and whatever the sequence you get, you will take IDFT of that particular sequence. Then you will get the desired pattern. Although these kind of questions are never asked in the GATE examination, but if they want to ask pretty good question from DFT, then this kind of thing they would ask. So is the signal processing clear to you, that what is actually we are doing? So I was having 1 2 minus 1, I was having only 3 samples. From these 3 samples, I made a periodic sequence which is 1 2 minus 1 1 2 1 2 minus 1 1 2 1 2 minus 1 1 2. Okay, so this is the process. All good, all fine. You are having 1 2 3, you need to make y of n x mod 2, x n modulo 2. Basically what you need to make, your y of n is equals to x of n modulo 2. So what it would be equals to, your x of n should be periodic with 2. But sir, here there are 3 samples, so what you need to do? You need to kill one sample, no? Starting with x of n, 1 2 1 2, it should be periodic with 2. So 1 2 1 2 and so on. This is what you require. Can you calculate the value of x of n mod 2? What will be x of 0? That will be, this is your y of n. What will be the value of y of 0? That would be equals to x of 0 only. Yes. What will be the value of y of 1? That would be equals to x of 1 only. What will be the value of y of 2? What will be the value of y of 2? So 2 mod 2. What is that? X of 0. So again x of 0. So y of 2 is x of 0. This is your n equals to 0. This was your n equals to 1. N equals to 2. What will be the value of y of 3? That will be x of 3 mod 2. So that would be equals to x of 1. So what is the value of x of 1? This is the value of x of 1. That means, what did I tell you? Modulo means it should be periodic with that. So periodic with 2. Periodic with the periodicity of 2. So period should be 2. 1 2 1 2 1 2 1 2, it will keep on repeating. There you. So this is your y of n. Now this is something you need to create. Y of n you need to create. 1 2 1 2 1 2. This is something you need to create. It is very simple. What you will do? 3-point x of n is there. 3-point x of n is there. What you will do? You will take 2-point DFT. What you will do? You will take 2-point DFT. So if I take 2-point DFT, that means what all things will come into action? X of 0 and x of 1 only will come into action. So 2-point DFT means I need to calculate 2-point x of n. What is my 2-point x of n? My 2-point x of n is 1 2. That's it. So only these two will come into action. So your DFT is calculated, some x of k you will get, which will be periodic with 2. This will be periodic with 2 plus discrete. So some x of k you will get, which is periodic with 2 plus discrete. So now if you calculate IDFT, what you will get? Something periodic with 2. So what all the samples would be there? So it started from here, started from 1 2. So 1 2 1 2 will be repeated with the periodicity of 2. So 1 2 1 2 will be repeated with the periodicity of 2. 1 2 1 2 will be repeated with the periodicity of 2. Is that clear to you? All good? All fine? Okay. Let's go to the next question. This is a question. 8-point DFT of x of n is given as x of k. You need to find the value of summation n goes from 0 to 3 x of 2n. If you have watched the lecture of DTFT, then you will be able to solve on your own. DTFT. In DTFT, we have seen this kind of concept. What you need to calculate? A is equals to summation n goes from 0 to 3 x of 2n. That means you need to calculate x of 0 plus x of 2 plus x of 4 plus x of 6. This is what you need to calculate. X of k is given. Do you know the formula of x of k? Yes. Summation n goes from 0 to 8-point DFT is given. That means 0 to 7. X of n e to the power minus j 2 pi by n kn. 2 pi by n kn. Right? Which is equals to summation n goes from 0 to 7 x of n e to the power minus j pi by 4 kn, right? In place of k, if I put 0, k equals to 0, if I put, what I am getting? This is what I am getting. So what I am getting? X of 0 plus x of 1 plus x of 2 plus x of 3 plus x of 4 x of 5 6 7. Now in place of k, if I put 4, why I am putting 4? Because I need to make e to the power minus j pi. This you need to think. Actually we are putting n by 2. In place of k, we are putting capital N by 2. 8 by 2 4. So I told you, whenever you need to calculate even sample or odd sample, so something will happen with e to the power minus j pi. So here you need to make e to the power minus j pi. So what I'm going to put? K equals to 4 I'm going to put. If I put k equals to 4, let's see what is happening. Pi by 4 into 4 n 0 to 7. Sorry guys. Zero to 7 x of n. So e to the power minus j pi, what this has become? E to the power minus j pi n, that can be equals to minus 1 to the power n, right? This is minus 1 to the power n. So how will you solve it? So if you put n equals to 0, x of 0, if you put n equals to 1, x of minus 1, x of 2, x of minus 3, x of 4, x of minus 5, x of 6, x of 7. And if I add both of them, what I will get? X of k. Why I am adding both of them? If I add both of them, what I will get? So this is a very standard pattern, right? In the discrete time Fourier transform, we derived this. And I told you not to remember any formula, just to have the basic idea that how to proceed in this kind of question. If there was odd sample 1, 3, 5, 7, what I would have done? I would have subtracted them, because there what would have happened? X of 0 would have been cancelled to x of 0. X of 1 would have been added to x of 1. X of 2 would have been cancelled to x of 2. X of 3 would have been added to x of 3. So this would have happened. But here I am adding up. So what is happening? X of 1 will get cancelled out to x of minus 1. X of 3 will get cancelled out to x of minus 3. So what you are getting? 2 x of 0 plus x of 2 plus x of 4 plus x of 6, right? 2x of 0 plus x of 2 plus x of 4 plus x of 6, and this is what we need to calculate, divided by 2. So this was our a, which we need to calculate. So a is coming out to be x of k at k equals to 0 plus x of k at k equals to pi divided by 2. So a is equals to k equals to 0. If you put, answer would be 1. If you put k equals to pi plus 1 divided by 2. So pi by 2 plus 1. So pi plus 2 divided by 2. What we are getting? Pi plus 2. Basically here what I put, k equals to 0 I need to put. So x of 0 would be, what is the value of x of 0? X of 0 is 1. What is the value of x of, अरे यार क्या कर रहा हूँ मैं? X of 4, no? Really sorry guys, this is x of 4. Really sorry. This is a big blunder. This was 4. This was 4. So what is the value of capital X of 0? Capital X of 0 is 1. What is the value of capital X of 4? That is 5. So these questions should be solved in the examination. Okay, if these questions are coming, then they will lie in the category of easy questions. So you have spent so much time on studying a signal system, and if you are missing out on these questions, then it is tough, right? Tough means like things are tough for you. So you should not be missing out in these kind of questions. So 1 plus 5 divided by 2. So 6 by 2, that would be equals to 3. So answer would be 3. That's the answer. Well and good. Okay, fine. Let's go to the next concept. So similar kind of property we saw in DTFS, right? You remember in DTFS we saw similar kind of property. So let's see what will happen here. If this is x of n is n point, you are having discrete Fourier transform of x of k, that will also be n point. Basically, I am calculating n point DFT. What I am doing, I am calculating n point DFT. So if I am calculating n point DFT, what I am getting? X of k n point. Now here, how many points would be there? 3 n points would be there. Basically, let's just say x of n was, it is given only 3, 2, 3, 4. So what would be your x of n by 3? That would be 3, 0, 0, 2, 0, 0, 3, 0, 0, 4, 0, 0. This was your 4 point x of n. This will be your 12 point x of n by 3. So 4 point DFT was this thing. Now if you have expanded it, so what will be your 12 point DFT? So in case of DTFS, what was happening? CK by 3, right? CK by 3. Periodicity, if this was 12, so here also it was 12 only, but minimum period was 4. But here what will happen? Nothing will be divided, the same x of k as it is. Are you able to understand this point? If I am inserting some zeros, then nothing will happen. X of k remains there as it is, ditto as it is. No divided by anything. So x of k will be as it is, but it will be periodic with, since you are calculating 3n point DFT, 3n point DFT, so it will be periodic with 3n points, right? So what would be the answer? If this is your x1 n, what I am saying, 4 point x of n was this thing, 4 point DFT for this was x of k, which was 12 to 2j 0 minus 2j. Now what will be your 12 point xn? This will be your 12 point xn, that is equals to x1n. So with respect to that, what will be your 12 point DFT? That is your x1k. So nothing will change, ditto the same thing will come, 12, 2j, 0, minus 2j. But it is supposed to be periodic with 12. So I will repeat the samples. 2j, 0, minus 2j. There you go. What is this? This is your 12 point. This is your 12 point x1k. Is that clear to you? This is the answer of this question. Did you understand this point? So whatever that happened in DTFS, exactly the opposite thing will happen here. There was another property in DTFS. In DTFS, what was the scenario? This was one of the property that x of n was having ck. So x of n was having ck by 3, ck by 3. And another property was, if it is ck by 3, if it is ck by 3, then it was not changing. But here what happened? If it is x of n by 3, this is not changing. We will write down the conclusion and we will compare both of them. Okay, so you will be able to remember it. So don't worry about that. This question, 2 point x of n, with respect to that 2 point x of k have been defined. Now 4 point y of k is given as this. What will be your 4 point y of n? So it will be same. No, it will not be same. This is the next question. No, y of k is defined as x of k by 2. Y of k is defined as x of k by 2. 3, 0, minus 1, 0. What you need to find? You need to find y of n. 4 point y of n. So you know we have the matrices. What we can do? We can make the matrix or we can copy the matrix. Let's make the matrix. So from here what I need to find? I need to find y of n. So I will do the calculation now. So basically what I am finding? I am finding IDFT, y of n I am finding. So this is y of 0, y of 1, y of 2, y of 3. That is equals to what? 1 by n. You know how to write down this matrix. 1, 1, 1, 1, 1, 1, 1. Right in the middle 1, upper side minus 1, minus 1, minus 1, minus 1. Since it is IDFT, so here plus j, minus j, plus j, minus j. 3, 0, minus 1, 0. So what is the y of n you are getting? So 1 by 4 is already outside. 3 minus 1, that would be 2, right? 3 minus 1, that would be 2. This would be 4, 2, and this would come out to be 4. So can I write it down in this manner? Y of n is coming out to be 1 by 2. 1 by 2 goes inside. What you will get? 1, 2, 1, 2. There you go. 4 point y of n. What it is? 4 point y of n. 4 point y of n. This is the answer you are getting. So what do you think? What will the property say? The property has been written on the next page, right? So what the property will say? X of n is having x of k. If you do x of k by 3, in case of our DTFS, what was happening? Ck by 3. So here what was happening? Nothing remains as it is, right? Nothing remains as it is, just it will be, if here 3 endpoints are there, so here also 3 endpoints will be there. But here what will happen? Nothing will happen but divided by 3. But the point is here 3 endpoints would be there. Is that clear to you? 3 endpoints would be there. So now what is happening? X of n is having x of k. Now x of k is being expanded. X of k is being expanded. So what will happen to x of n? If you take the IDFT, what you will get? 12 point y of n you will get. So what will be your 12 point y of n? What will happen is that if x of k is being expanded, so nothing will happen to x of n, but it will be divided with, since y of k is equals to x of k by 3, y of k is equals to x of k by 3. So x of n will also be divided with 3. And it should be a 12 point, that means 3, 2, 3, 4, 3, 2, 3, 4 and 3, 2, 3, 4. There you go. Did you understand this point? Are you able to compare what we studied in DTFS and what we are studying in DFT? Look, that's why I taught DTFS first, so that you can compare these properties of DTFS and DFT together. Are you able to understand this point? Right? X of n, 4 point DFT was there. This time DFT is being expanded. If DFT is expanded, nothing will happen to x of n. Nothing will happen to x of n, but the amplitude will be divided. This is how we need to remember. We need to remember something. Okay? We need to remember these properties anyhow. I will tell you a trick as well how to remember. So let's write down both of them parallelly. So here I am writing down DTFS and here I am writing down DFT. So x of n was periodic, there it was period. So x of n was periodic with n, Ck was also periodic with n only. Now if you did x of n by 3, so let's remember the continuous time. In continuous time what used to happen? X of t was having Cn. If I used to do x of alpha t, nothing would happen to Cn, right? So in continuous time nothing was happening, so in the discrete time something will happen. This is how you can remember it. Will you be able to remember it? In continuous time if nothing is happening, so in discrete time something will happen. So here Ck by 3. Just the point is, here period will be, if this is having period 3n, so here also period is supposed to be 3n, but you remember one thing, the minimum period will be n only. And if you do Ck by 3, if you do Ck by 3, that means if your frequency response, if your frequency spectrum is being expanded, so nothing will happen to the time domain. Just the period, here the period will be 3n, so this will be also computed over period 3n only. Is that clear to you? If C of k was expanded, then nothing will happen. So this is how you need to remember the property, that you will start from here. In the first one nothing, here in the continuous time nothing happens. So if you do the scaling in discrete time, then something will happen. So here if something is happening, so in the other one nothing will happen. Okay. Anyway, it should be there in your mind, guys. I cannot tell you any other trick. Now here, if in DFT, if you expand your time domain signal, in DFT, if you expand your time domain signal, then in the like here you are having 3 endpoint, here you are having n point, so you would have calculated n point DFT. Now you are having 3n points, so you would calculate 3n point DFT. 3n point DFT. So if you calculate 3n point DFT, what you will get? Nothing will happen, x of k only, but this will be computed over 3n points. Basically x of k, x of k, x of k. This example. Which example? This example. X of k, x of k, x of k. And what about this one? Here nothing happened. So here something will happen. X of k by 3. So 1 by 3 x of n. Anyhow, you need to keep them in mind. So what was this? This was having 3n points. So if this is having 3n points, you have calculated 3n points IDFT, and this will also have 3n points only. This will also have 3n points. One thing you noticed here, that even if I am adding up zeros, what I mean to say is that if I am expanding it, if I expand it, that means I am adding up zeros, no? 0, 0, then some sample would come, then again 0, 0. So in the frequency spectrum, what is happening? Actually, you are not adding up 0. The CK is being repeated. What I am saying, if I am expanding it, so in the frequency spectrum, although amplitude is divided by 3, but CK is not being expanded. CK, CK, CK. Basically, CK, CK is being repeated. CK, CK, CK divided by 3. This is what is happening. So if you are adding up zeros in time domain, in the frequency domain, zeros are not being added up. In the frequency domain, what is happening? The same thing is being repeated, although here it is divided by 3. And similar thing, if you are adding up zeros in the frequency domain, what I am saying, if you are adding up zeros in the frequency domain, that means here you are adding up zeros. That means if you are expanding your frequency domain, then this x of n is not changing. That means this x of n is not adding any zeros. Are you able to understand what I am saying? X of n by 3, Ck by 3. Ck by 3. It's not that if in time domain I am adding up zeros. If I am adding up my function, then it doesn't mean that in the frequency domain it will also expand. No, it is the same divided by 3. So zeros will not be added. And here if I am adding 0, it doesn't mean that in the frequency domain zeros will be added. And the similar thing is happening in DFT as well. If here I am adding zeros, then it doesn't mean that here also zeros are added. And if I am adding zeros here, it doesn't mean that zeros are added here. So anyway, you need to remember the property. How will you remember? That depends on you. Usually how I remember is that I go with the continuous time. X of t is having C of n. So x of alpha t will have C of n only. So x of n by alpha will have Cn by alpha. So if your x of n by alpha is having Cn by alpha, so nothing will happen to x of k. This is how I remember. Is that clear to you what I am saying? X of n is having C of k. So x of n by 3 is having C of k by 3. But x of n by 3 will have x of k only. Is that clear to you? X of n by 3 will have x of k only. Right? And here the opposite thing. C of k by 3, then here you will get x of n. Here x of k by 3, you will get x of n only, but amplitude divided by 3. Here also amplitude was being divided by 3. Here also amplitude being divided by 3. Is that clear to you? Okay. So anyway, you need to remember it. Other properties, if x of n is having x of k, x of minus n will have x of minus k, x conjugate n will have x conjugate minus k. And how will you predict the nature of x of n? With the help of x of k. Similar way that we studied in DTFS, CTFS, DTFT, CTFT, everywhere the ditto same thing is there. Okay. So what I am going to write down? Same as exponential Fourier series coefficient, DTFT and CTFT. And in exponential Fourier series coefficient, I am talking about discrete as well and continuous as well. So whatever the method was there, what was the method? First you check the magnitude spectrum. In the magnitude spectrum, if it is even, then it could be real, imaginary or complex. Then you go to the angle. Addition of angle is even. If addition of angle is even multiple of pi, then it is real. If addition of angle is odd multiple of pi, then it is imaginary, right? Otherwise it is complex. Then you, for finding out even and odd, what you do? First you will see the magnitude spectrum. In the magnitude spectrum, if it is even, then it could be even, odd, neither even nor odd. Then what you will do? You will subtract the positive frequency to the negative frequency. If it is coming out to be even multiple of pi, then it will be even. If it is coming out to be odd multiple of pi, then it will be odd. Otherwise it will be neither even nor odd. So examples also we have seen, complete concept also we have seen, right? The complete process we have seen it. So similar process is happening with respect to x of k as well. So any frequency spectrum is coming, whether it is Cn, whether it is x of omega, whether it is Ck, whether it is x e to the power j omega, or it is x of k, it will happen the same. The same thing will be happening. Is that clear to you? Okay. And do remember this slide. This slide is very, very important. Do remember this slide. X of n is a real valued sequence. 8-point DFT is x of k, which is periodically extended. So here I am not writing down 8 x of k. I have written down x of k, which is periodically extended. X of 1 is 1 plus 2j. X of 2 is 1. Sorry, x of 1 is 2 plus 3j. X of 2 is 1 plus 2j. X of 3 is 10. You need to find out the value of x of 7 plus x of minus 18 plus x of 27. Do it on your own. I will take a break because my head is aching. Okay, I need to take a break now. You do it on your own. It is a very simple question. You will be able to do it. Yeah, welcome back. So did you try this question? Actually, there was a long break in between because I overslept actually. Okay, because my head was aching. So now I am back. So did you try this one? What you need to find? X of 7 plus x of minus 18 plus x of 27. So x of 7 plus x of minus 18 plus x of 27. It is periodic with 8. It is a 8-point DFT. And x of n is a real valued sequence. This real word is very important. It is a 8-point DFT which is periodically extended. So it is periodic with time period of 8, right? So it will be periodic with time period of 8. So what would be your x of 7 equals to? Like I would not want to do x of 7 plus 8 because it would be x of 15. And values are given x of 1, x of 2, x of 3. That means I want to go back. So what I would do? X of 7 minus 8, that would be equals to x of minus 1. So x of 7 is equals to x of minus 1. What I would have wanted to do, I would want to go ahead because minus 18. So I would want to go ahead to the positive values. So what I will do, I can add up a plus 16 here. X of minus 18. What I will do, I am adding up plus 16. So that would be equals to x of minus 2. And what about x of 27? Here also I would want to go back. So what I will do, I will subtract 24, right? 8 3 are 24 because it is periodic with 8. So you can add 8, 16, 24, 32 in that manner you can add, and you can subtract 8, 16, 32, 24 in that manner you can subtract as well. So I am subtracting 24 because I want to go back. I have come near to 3. So what is my answer? My answer is actually x of minus 1 plus x of minus 2 plus x of 3. So I know the value of x of 3, but I don't know the value of x of minus 2 and x of minus 1. But I know one thing, that x of n is a real valued sequence. So whenever real valued sequence are given, always you write down this particular thing. Always you write down this particular thing. If it is real, then x of n would be equals to x conjugate n. That means x of k would be equals to x conjugate of minus k. So what would be your x of minus 1 equals to? In place of k I am putting minus 1. So x conjugate 1. And what would be your x of minus 2 equals to? That would be x conjugate 2. So what is the value of x of minus 1? X of minus 1 will be equals to x of 1 conjugate. That means 2 minus 3j. And what is your x of minus 2? That is x conjugate 2, 1 minus 2j. These kind of questions are very, very famous in ISRO, in BRC examination, in these examination, or in some PSU examination. These kind of questions are very famous. They will give you real valued sequence. From there you can derive this expression and they will ask you to calculate particular things. So you need to know one thing, that x of k is periodic. That's it. Okay. Yeah. So just you need to put down these values now. So what will be the answer? X of minus 1 is 2 minus 3j. X of minus 2 is 1 minus 2j. And x of 3 is 10. 13 minus 5j. That's it. This is the answer. Okay, well and good. Let's go to the duality property. So till this point, what we have seen this kind of very important property. Then we saw these very simple properties, you can say, or very simple. Yeah, these are properties only. So x of n will have x of k, x of minus n will have x of minus k, and then x conjugate n will have x conjugate minus k. And predicting the nature, it goes like the same way that we have already studied. And then we went on to this particular problem, and now we are going to study about duality property. Okay, duality theorem, you can say duality property, whatever you want to call it. We are going to study about duality. So if x of n is having n point DFT of x of k, n point DFT of x of k. Now if your x of k becomes your time domain signal, then what will be its n point DFT? So its n point DFT would be, this guy will come here, x of minus I. What did I tell you? That DFT is a friend of Fourier transform. So in Fourier transform, what you used to do? X of t was having x of omega. Now if this x of omega comes here, that means if it becomes a time domain signal, then what you will do? This x of t will come here, multiply with 2 pi, and surely there will be an inversion. So in all the duality properties, surely there will be an inversion. Just confusion would be that, sir, I need to multiply by 2 pi, I need to divide by 2 pi. So you need to remember, here you multiply by 2 pi. So if you are multiplying by 2 pi here, then you will multiply by n here. So we have seen 4 kind of duality property. This is one of the duality property which we have seen in DFT. Another property we have seen in CTFT only, the same property, that if your Fourier transform of x of t is x of omega. Now if x of omega becomes your time domain signal, then what would be its Fourier transform? That would be 2 pi x of minus omega. This we have seen, right? Now if x of t is having exponential Fourier series coefficient of Cn, now Cn becomes your discrete time signal, then what would be its DTFT? That would be x of minus omega. Because what is this? Cn is a discrete plus periodic. Sorry, discrete plus aperiodic. Really sorry guys. Discrete plus aperiodic. What this is? Discrete plus aperiodic. What it was? If you are finding exponential Fourier series coefficient, that means it was continuous plus periodic, right? And what this would become? This would become continuous plus periodic, right? Always your discrete time Fourier transform, always your discrete time Fourier transform is periodic, right? What about this one? What is this? If you are finding continuous time Fourier transform, that means it is continuous plus aperiodic. So what would be your x of omega? That would also be continuous plus aperiodic. Now again you are finding Fourier transform only, so again the same thing is there. This is also continuous plus aperiodic. This will also be continuous plus aperiodic. Is that clear to you? What about this one? X of n, was it periodic? What I am asking, x of n was periodic or not? What about x of k? You know one thing, that it is discrete plus periodic. But whenever you are finding x of k, this could be aperiodic as well, no? This could be aperiodic as well, x of n. But whenever you find out IDFT, like from x of k, if you go back to x of n, then it becomes periodic. So let's not write anything about this x of n. Let's not write anything about this x of n. Okay, I am not writing anything about this x of n. Just I know that always the discrete Fourier transform, the result of discrete Fourier transform will always be periodic. Because x of k is always periodic. The result of discrete Fourier transform will always be periodic. So this will be periodic plus discrete as well. So what is the duality property in a discrete Fourier transform? X of n is having x of k. If x of k becomes your n domain signal, then its discrete Fourier transform will be this multiplied with n and the inversion. Whatever the same thing that was happening in CTFT, the same thing is happening here as well. In place of 2 pi, you need to write down n. And what was the duality property in DTFS? If x of n is having exponential Fourier series coefficient of c of k. Now if your c of k becomes your time domain signal, then what would be its discrete time Fourier transform? That would be equals to x of minus omega. Sorry guys, sorry. This x of minus omega was different. Really sorry guys. Look, what is this? Discrete plus periodic. What is this? Discrete plus periodic. So if your time domain signal is discrete plus periodic, so will you find out its DTFT or you will find out its DTFS? You will find out its DTFS, right? If your time domain signal is, what I am saying, if your time domain signal is discrete plus periodic, oh, if it is periodic, then that means I need to find Fourier series. So you will find out its discrete time Fourier series. So what will be its exponential Fourier series coefficient? Its exponential Fourier series coefficient would be, here you are multiplying with n, here what will happen? Divided with n, and surely there will be an inversion. So 4 duality properties are there, all are written on this page. So this would be a revision page for you. Very, very important. X of n, x of k comes here. Usually we study this duality property and this duality property only. In 100% of the notes, you will find only these 2 duality property. But duality properties are there in case of CTFS, DTFT, everywhere duality properties are there. So all the duality properties are written here. X of n is having x of k comes here. So you need to find n point DFT, that would be n of x of minus n. x of t, x of omega becomes your time domain signal, that would be 2 pi x of minus omega. X of t exponential Fourier series coefficient is Cn. Now Cn becomes your time domain signal, then its DTFT will be x of minus omega. What was the example here? And another important thing was x of t should be having a time period of 2 pi. Right, here there was another thing, that it should be having a time period of 2 pi. If it is not 2 pi, then how we will apply the property, that also we have seen. Now x of n is having an exponential Fourier series coefficient of ck. Ck becomes your time domain signal, then exponential Fourier series coefficient would be 1 by n x of minus n. Is that clear to you? Let's go to this question. These kind of questions are very famous, which have been asked in GATE examination. So 4 point x of n is given. You need to find DFT is a function which is showing 4 point DFT. Basically, this DFT is showing 4 point DFT. So they are not writing down 4 point DFT. Instead of writing 4 point DFT, they have just written down DFT only. Are you able to understand this point? This particular DFT means 4 point DFT. This particular DFT means 4 point DFT, right? So let's find out the first one. The similar kind of questions we saw in DTFS as well, where we were finding exponential Fourier series coefficient. So ditto same thing will happen here, just that properties are a bit different. अरे यार DTFS लिख रहा हूँ. So I am saying that 4 point DFT of x of n, 4 point DFT of x of n, I am assuming as x of k, right? So what we have seen, x of n is having x of k, x of n is having x of k. Now this x of k comes here. If this x of k comes here, then it will become n of x of minus n, right? So DFT of x of n is x of k. DFT of x of n is x of k. And what is the DFT of x of k? That is equals to n x of minus n, right? DFT of x of k is n x of minus n. Is that clear to you? So this is the answer of first one. Now some people will be having the doubt that, sir, what will be the answer? Sir, this is my 4 point x of n. That means, sir, it is not periodic. 4 point x of n means it is not periodic. What is the meaning of 4 point x of n? 4 point x of n. That means starting from n equals to 0, till 4 samples I need to count. If I ask you what is the value of x of minus 1, what you will say? Sir, 0. It is not periodic. So as per you, sir, n of x of minus n, what it should be? Sir, first sample as it is, rest all 0. This should be the answer according to you. Are you able to understand what I am saying? 4 point x of n is not periodic. 4 point x of n is not periodic. Now you are saying that, sir, my answer is n into x of minus n. If I ask you what will be the value of x of minus n for this one, what will be your answer? Do you remember one thing? We have seen this kind of question. There what we did, I gave you 4 point x of n, and I asked you what is the value of 4 point x of minus n. So what you did? First you find out the modulo n, and from the modulo n you got the value of x of minus n, and from here you picked 4 point. Do you remember this process? In the lecture of circular convolution, if you need from 4 point x of n, if you need to find 4 point x of minus n, then directly you are not going to do this thing. What is given? 1 2 minus 1 4, 1 2 minus 1 4. You will say that, sir, here everything is 0 0 0 only. After that as well everything is 0 0 0 only, and this is my n equals to 0. So sir, if I need to do the inversion, so 1 remains as it is, and here everything is 0 0. So sir, this should be the answer. No, this is wrong. What should happen? 1 2 minus 1 4. So first you make it periodic. 1 2 minus 1 4, 1 2 minus 1 4, and so on. It will be periodic, right? You consider this as n equals to 0. Consider this as n equals to 0 because starting point is n equals to 0. Now you need to take the inversion. So what will happen? This 4 will go here, minus 1 will go here, and 2 will go here. So what will happen? 1 remains as it is, 4 going ahead, minus 1 going ahead, and 2 going ahead. This would be the answer. This would be your 4 point x of minus n. This is your 4 point x of minus n. Although this 2 will come here, but I don't care about that. No, I need only 4 point x of n. I need only 4 point x of minus n. If you need 4 point x of minus n, that means you need n equals to 0, and after that you need 3 more samples. N equals to 0, n equals to 1, n equals to 2, n equals to 3. So I only care about n equals to 0, 1, 2, 3. So 1 as it is, 4, minus 1, minus 2. So this is the answer. Are you able to understand this point? So you will not say, sir, it is 1 0 0 0. Okay, so this was just a revision. We will write down in a good manner. And more points. When you calculated DFT of x of n, what you got? X of k, right? Now you are calculating DFT of x of k. What you got here? What you are doing? 4 point DFT of x of n. So you got 4 point x of k. Now you are calculating again DFT. Then what is the answer you should expect? You should expect a periodic answer. Answer should be periodic, no? Whenever I calculate DFT, what answer I expect? Answer of DFT is periodic. What did I tell you? That it could be aperiodic, but this will be periodic only. But what I am writing down, 4 point DFT, no? 4 point DFT. So here this x of k will also have 4 points only. If I am calculating 4 point DFT, that means this x of k will also have 4 points. I only consider 4 points only. What is the difference between 4 point x of k and purely x of k? Here x of k is written, but actually it is 4 point x of k because you are calculating 4 point DFT. So if you calculated 4 point DFT of 4 point x of n, then your answer is 4 point x of k. Now for 4 point x of k, you are again calculating 4 point DFT. So this answer is also 4 point x of minus n multiplied with n. Is that clear to you? All good? So you need to find first, your task is to find x of minus n. So how will you find x of minus n? So 4 point x of n is 1, 2, minus 1, 4. With this being the origin. So next task would be that I find x of n modulo 4, which will be 1, 2, minus 1, 4. 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 This is my 4 point modulo n. Now I need to find x of minus n modulo 4. So what that would be? Sir, 1 remains here. Now they will interchange the place. So 4 goes here, minus 1 goes here, 2 goes here, then 1 goes here, and so on. Similarly, this 2 goes here, minus 1 goes backward, 4 goes backward, 1 goes backward, and so on. Okay. And where is the origin? Origin being at the same place only. What you need to find? Now I need to find 4 point x of minus n. So 1 here only, 4 minus 1, 2. This is the answer. 1, 4 minus 1, 2. 1, 4 minus 1, 2. This is the answer. But here what you need? DFT of x of k. So answer of first one would be what? N into this x of minus n. And what is the value of n? N is 4. 4x of minus n. So for the first one, answer would be 4, 16 minus 4, 8. This would be the answer. And you can try calculating on your own as well. It is 4 point DFT only, no? So you can calculate. First you calculate 4 point DFT of this one, then whatever the answer you get, again calculate the 4 point DFT. You will get the same answer only. Is that clear to you? All good? All fine? Right? You are understanding everything? So it was an important point. Like I could have directly tell you that you get x of minus n, that means just put this 2 here and minus 1 here and 4 here, and then you make the inversion. But actual concept, what is the actual concept? What is actually happening? You got x of minus n, you need 4 point x of minus n. That means first you need to get x of minus n modulo 4. So modulo 4 you got, then that was periodic. So actual answer would be 1, 4, minus 1, 2. This was the answer we were getting. So this is the process if you follow in the examination, then it will be very good for you. You will never get the answer wrong. N x of minus n. So what is the meaning of 4 point x of minus n? So you are having 4 point x of n. From there what you will calculate? X of n modulo 4. From there you will calculate x of minus n modulo 4. And from there you will get 4 point x of minus n. So this is actually the process. But how do we actually learn it? That we make a circle. This is how actually it is taught. That you make a circle. X of n is given. You write down x of n in any order. What is the x of n order? 1, 2, minus 1, 4. So in any order I can write down 1, 2, minus 1, 4. So I wrote down x of n in this manner. So my x of minus n is this. So answer would be 1, 4, minus 1, 2. 1, 4, minus 1, 2. So just for the sake of writing down the answer, you can understand by this process as well. That x of n I wrote down in this manner. So x of minus n will be this 1, 4, minus 1, 2. So just for writing the answer, you can follow this process as well. But actual concept, what is the actual concept that you have already seen, right? Next, what we need to do? We need to find a DFT of DFT of DFT of DFT of x of n. So 4 times DFT. DFT of DFT of DFT of DFT of x of n. This is something that we need to find. So what is the answer of this one? So 2 times DFT. What answer it will give you? 2 times DFT. That will give you 4x of minus n, or you can say nx of minus n. Right? This is the answer. 2 times DFT will give you. Now another 2 times DFT, what answer it will give you? First 2 times DFT, what it did? Multiplied with n and then inversion. So basically 2 times of DFT, what it will do? Multiply with n, whatever the function is written here, multiply with n and then inversion. Multiply with n and then inversion of this one, what it would be? X of n. So what is the answer you will get? N square x of n. Or if you don't want to follow this process, then simply go by the basic concept. No, look, n will become constant, so n can come outside. N will become constant, n can come outside. What will be the DFT of x of minus n? That will be equals to x of minus k. So DFT of x of minus n will be equals to x of minus k. Is that clear to you? X of n is having a DFT of x of k. So x of minus n will have a DFT of x of minus k. Now if x of minus k comes here, then what will be its DFT? N into this will come here, but with the inversion. So DFT of x of minus k, what that would be? N square x of n. This is the answer. This is the answer. This is the answer of 4 DFT, 4-point DFT. And you can see in this manner as well that when you calculated DFT twice, what you were getting? Multiplied with n and then the inversion of xn. Multiplied with n, inversion of xn. Now what you will get here? 2 times what it will give you? Multiplied with n, inversion of xn. Again 2 times what it will give you? Multiplied with n, inversion of x of minus n. What will be the inversion of x of minus n? That will be x of plus n. So multiplied with n, that means n square it will become, because n is already there, n into n will be n square, and inversion of this one, what that would be? X of n. Or you go by the basic concept only. DFT of x of n is x of k, DFT of x of k is x of n, x of minus n, then DFT of x of minus n will be x of minus k, n is already outside, and DFT of x of minus k would be n into plus x of n. So this is the answer you will be getting, n square x of n. So what will be the answer? I need to add a page. 34, 35, 35th page it is. So 35th. So your answer is n square. What is the value of n square? 16. X of n is 1, 2, minus 1, 4. 16, 32, minus 16, 64. This would be the answer. Okay. Let's see the third question. What the third question is saying. If DFT of y of n is equals to y of k, then you find the value of capital Y of 0. Okay, what they are saying? I guess this was y of n, no? This was y of n. This was your y of n. What I am saying is that DFT of 4 times DFT of x of n is equals to y of n. So this is your y of n. This is your y of n. Now what they are expecting, that you need to calculate the DFT of this particular thing. What you need to calculate, whatever the answer you got, you need to calculate the DFT of this particular answer, and that is equals to y of k. Then whatever the answer that you get, in that answer what value you will be getting at k equals to 0. This is what they are asking. What they are asking here, y of k at k equals to 0. This is what they are asking. So will you calculate DFT of this y of n? No. What you will do is that, what is the formula of y of k? What you need to calculate, my target is y of k at k equals to 0. This is my target. So what is the formula of y of k? N going from 0 to n minus 1, 4 point, everything is going with respect to 4 point only. Y of n e to the power j, e to the power minus j 2 pi by n kn. This is the formula of y of k. What you need to find? K equals to 0 you put. So if I put k equals to 0, what I am getting? Array yaar. Summation 0 to n minus 1 y of n. So what is the answer you will get? Y of 0 plus y of n plus y of 2 plus y of 3. That means you need to sum all these things. 16 plus 32 minus 16 plus 64, 96. Right? Because 16 and minus 16 will get cancelled out. 6 and 9. This is the answer. Well and good. All good, all fine. Okay. So these kind of questions are very famous in the examination. Any kind of question can be coming. 4-point sequence is given. 4-point DFT of y of n is 4-point y of k. Function IDFT is defined over 4-point sequence only. You need to find IDFT, IDFT, IDFT. That means now you need to find inverse discrete Fourier transform. So y of n was having y of k. Y of n was having a Fourier transform of y of k. Sorry, discrete Fourier transform of capital Y of k. And then when the y of k came here, it became n y of minus n. So if I ask you, what is the inverse discrete Fourier transform of y of n? Inverse discrete Fourier transform of y of n. So discrete Fourier transform of y of n is y of k. Inverse discrete Fourier transform of y of minus n is y of k. Are you able to understand this point? What I am saying? Inverse, if I say that discrete Fourier transform of y of k is equals to n y of minus n. And now if I ask you, what is the inverse discrete Fourier transform of y of minus n? N y of minus n. N y of minus n. What will be your answer? That would be y of k. Now n is a constant. So what can happen? I DFT of y of minus n will be equals to y of k divided by n. And if I put a minus sign here, that means if I make it plus n, so what it will become? Minus k. So answer would be y of minus k divided by n. So I DFT of y of n if discrete Fourier transform is y of k, then here y of k should have been written, no? You cannot find I DFT of y of n. Like this question is also fine, but better y of k should have been written here. Like first discrete Fourier transform is y of k. So you cannot write y of n here. I should have written y of k, right? Not y of n. Even if I write y of k, then also it is, even if I write y of n, then also it is not wrong. Because y of n is given, but better way would have been that I find I DFT of y of k first, right? So this should be written as y of k. Like yn is my n point sequence, no? So how will you find out its inverse DFT? You will find out the inverse DFT of a discrete Fourier transform, right? This is a discrete Fourier transform. You are finding out its inverse DFT. So this is already a discrete Fourier transform, and whose I DFT you will find out. Then you will say that I DFT of y of k, sir, will be y of n, which is a n domain signal. Yeah, it is a n domain signal, but if it was a k domain signal, then what would be the answer? This is what they are asking. Are you able to understand this point? Like first one, I DFT of y of k, inverse discrete Fourier transform of y of k, it will give you y of n. Now sir, next thing they are asking, what is the I DFT of y of n? Because I DFT of y of k is y of n, then I DFT of y of n. This would be my next target to finding out I DFT of y of n. You will say, sir, it is an n domain signal. No, it is not an n domain signal. If they are asking I DFT of y of n, that means they are already considering that it is your discrete Fourier transform only, because you can find out the I DFT of a discrete Fourier transform only, no? You can find out I DFT only when you have got this y of k, and then you can find out its I DFT. So this is your k domain signal only, but here k is replaced with n. So I DFT of y of n is actually y of minus k divided by n, right? So two steps are done. What is the next step? Next step would be I DFT of y of minus k divided by n. What that would be? I DFT of yk is y of n. So I DFT of y of minus k would be y of minus n. N is already there. Now what is the next task? Next task is finding out the I DFT of y of minus n divided by n. So 1 by n is already there. I DFT of y of minus n. I DFT of y of minus n. I DFT of y of n is y of minus k divided by n. So I DFT of y of minus n would be I DFT of y of minus n is y of k divided by n. Directly from here you can see. So what is the answer we are getting? Y of k divided by n square. So this is the answer of this particular thing. Y of k divided by n square. And in place of y of k, if y of n was written, then what would have been the answer? In place of y of k, if y of n was written, so what would have been the answer? That you can calculate on your own, right? So things are different, right? Y of k is different, y of n is different. Y of k could also have been there. There is no doubt about that. Here in place of y of k, y of n could have been also written. But here we have written capital Y of k. Capital Y of k we have written. That means we are finding, first we are finding the IDFT of y of k, which is y of n. Then we are finding IDFT of y of n, which is coming out to be y of minus k divided by n. Then we are finding IDFT of y of minus k divided by n, that would be y of minus n divided by n. And then we are finding IDFT of y of minus n divided by n, that means 1 by n goes outward. IDFT of y of minus n, IDFT of y of minus n is coming out to be y of k divided by n, y of k divided by n. So answer would be y of k divided by n square. So for this particular thing, answer is y of k divided by n square. If y of n was there, then answer would have been, in place of y of k, if y of n was there, then answer would have been y of n divided by n square. Is that clear to you? So now for this question, what you need to do? This is the answer you are getting, right? Y of k divided by n square. So first you need to find out y of k, and after that you need to divide by 1 by n square. That means my answer is y of k divided by 16. So y of k I am not having. So first I need to find out y of k, and then I will replace my y of k with y of k here, and I will get my answer. So let's just say this I am calling as, this particular thing is z of k. Okay, so my z of k is coming out to be, again add a page. I hope guys this is clear to you. IDFT we are finding out. IDFT of y of k would be equals to y of n. IDFT of y of n would be equals to y of k, y of minus k divided by n. From here, from the duality property, y of n is having y of k comes n y of minus n. So IDFT of y of n would be y of minus k divided by n. Then IDFT of y of minus k would be y of minus n. Then IDFT of y of minus n divided by n would be 1 by n y of k divided by n. So 1 by n y of k n square. This is the answer we are getting. So z of k is y of k divided by 16. Right? So what we need to find? We need to find y of k, because y of n is already given. 1, 2, minus 1, 3. So you can do it on your own. I will try to do it without making the matrix, because I remember the matrix in my mind. 1, 1, 1, 1. So 1, 1, 1, 1, 1 will be multiplied with 1, 1 will be multiplied with 2, 1 will be multiplied with minus 1, 1 will be multiplied with 3. So here my y of 0 will be addition of all these things. So that would be 5. You can do it making the matrix. Okay, no need to worry about that. Without making the matrix, even I would not have done it without making the matrix in the examination hall. Okay, so let's make the matrix, but let's make it roughly. So we will make it roughly only. Minus 1, 1, minus 1, minus 1, minus 1, minus j, j, minus j, j. So 1, 2, minus 1, 3. So 5. Then 1 minus 2j plus 1 plus 3j. So 2 plus j. Then 1 minus 2 minus 1. Arey yaar. Minus 3. 1 minus 2 minus 1 minus 3. So what you are getting? Minus 5. And here 1 plus 2j plus 1 minus 3j. So you are getting 2 minus j. There you go. Okay. Again let me check. 5, 1 minus 2j plus 1, 3j. So 2 plus j, 1 minus 2 minus 1 minus 3. 1 minus 2 minus 1 minus 3. So that would be minus 5. 1 plus 2j plus 1, 2 plus 2j minus 3j. So 2 minus j. This is the answer y of k you are getting. And what is your z of k? What is the final answer? Final answer is y of k divided by 16. So your final answer would have been 5 by 16, 2 plus j divided by 16, minus 5 by 16, 2 minus j divided by 16. This would have been the final answer. Is that clear to you? Well and good. So very simple process, just touch on the duality property that you have studied and you will be able to answer all these things. Here DFT, DFT was happening, so answer was n x of minus n. If 4 times it was there, so n square x of minus n. If it was there 6 times, then what would have happened? N cube x of minus n. If it was there for 8 times, then answer would have been n to the power 4 x of n. If it was there 10 times, the answer would have been n to the power 5 x of minus n, right? And here you got to know, in this question, if you calculated 2 times IDFT, when you calculated 2 times IDFT, your answer was y of minus k divided by n. So whatever the function that was here, inversion of it divided by n. Then what you need to do, 2 times IDFT of this particular function. So whatever the function that is there inside, inversion of that, whatever the function that is there inside, inversion of that divided by n. So answer would have been y of k divided by n square. Is this the same answer we are getting? Yes. So if you just solve it 2 times, then you can tell the answer very easily. If you just solve it 2 times, answer will be very easy. For next 2 times, you can tell the answer very easily, right? But process should also be clear to you. So process is also clear, everything is clear to us. This was a GATE question in 2014, a very good question, try it on your own. The endpoint DFT of a sequence x of n is given. What people will do, sir, directly I will see here, okay, DFT of x of n, then answer would be, sir, n x of minus n. So what they are saying, sir, n x of minus n should be equals to x of n. So sir, this should be the answer, and then I will match the options. But did you see how they have defined the DFT? DFT they have defined 1 by under root n goes from 0 to n minus 1, x of n e to the power minus j k 2 pi by n. Is this the formula that we know? Which formula we know? There this 1 by under root n was not there. Are you able to understand this point? Whatever the formula we know, there 1 by under root n was not there. They have defined DFT function. This is not a question based on DFT. This is a random question. They have defined a function named DFT. What they have done? They have defined a function named DFT whose definition goes like this. So it is a different function. What we studied, that is a different function. Are you able to understand this point? Right? So they have defined a function called endpoint DFT, which is given by this. And they asked you to find endpoint DFT, then again endpoint DFT. So 2 methods we will go. So if I had been a student like who is preparing first time or second time, then what would click to me? That, sir, I know this particular calculation. What would click to me is that, first I will tell you the rigorous method. Rigorous method means you have to do a lot of calculation. So what would click to me? Sir, I need to find some relation, so I will assume my 4 point x of n as a, b, c, d. This is what I will assume, sir. Okay, this is my 4 point x of n. I have assumed it. This will click to me, okay. Then what I will say, sir, DFT they have defined. That means DFT of x of n, DFT of this particular function, they have defined in this manner. 1 by under root n, summation n goes from 0 to n minus 1, x of n e to the power 1 by under root n actually. Value of n is 1 by under root n, value of n is 4, right? E to the power minus j 2 pi by n, that would be 2 pi by 4 kn. Sir, I don't know what will be the answer I will be getting, but I know the result of this calculation. Can you solve this calculation? Can you solve this particular calculation? Do you know the result of this particular calculation? Surely I know. What is the result of this particular calculation? Sir, the result of this particular calculation is a matrix multiplied with x of n. So I will make a matrix which will be multiplied with x of n. So this particular calculation, this particular box, I know how to solve. I know how to solve this particular box. So this particular box I am solving. There is surely another method as well. This is just the method 1. Okay. So I know how to solve this particular box, sir. It would be, sir, a, b, c, d. I will write down 1, 1, 1, 1, then 1, then 1, 1. Right in the middle 1, minus 1, minus 1, minus 1, minus 1, minus j, j, minus j, minus j. And this will be divided by 1 by 2. This would be my DFT of x of n. And let's just say it gives me some value, alpha, beta, gamma, neta. This is the value it is giving me. This is my DFT of x of n. I am not solving it. I am not solving it. This is my DFT of x of n. So next what I need to calculate? This DFT of this particular thing. Let's just call DFT of x of n as y of n. DFT of x of n is given y of n. So what I need to calculate? I need to find DFT of x of n. Just by the very basics we are going. Okay, in the examination hall it will not take that much of time. You will just see the definition and you will calculate this particular matrix. So what I would do, sir? DFT of y of n I need to calculate. DFT of y of n I need to calculate. So this is what I need to calculate. So how my DFT of y of n will be defined? Sir, DFT of x of n is defined in this manner. DFT of x of n is defined in this manner. Then sir, how your DFT of y of n will be defined? So DFT of y of n will be defined 1 by under root n. Again, point is 4 only. Summation n goes from 0 to n minus 1. Y of n e to the power minus j 2 pi by n kn. Do I know how to solve this calculation? Yes. How to solve this calculation? 1 by 2. Make a matrix. What kind of matrix? This kind of matrix you make. Make this kind of matrix, right? 1 by 2, make this kind of matrix. And then here what you will write down? Here what you will write down? Here you will write down y of 0, y of 1, y of 2, y of 3. This is what you will write down here. What you will write down? Y of 0, y of 1, y of 2, y of 3. Can you let me know what is this matrix? Isn't it this matrix only? DFT of x of n is what? Y of n. DFT of x of n is what? Y of n. Isn't it y of 0, y of 1, y of 2, y of 3? Say yes or no. DFT of x of n is y of n. And here you are writing y of n. So what is your y of n? What it was? 4 cross 4 matrix. What it was? 4 cross 1 matrix. So this was your actually y of 0, y of 1, y of 2, y of 3. Now in place of this particular matrix, you need to put this particular matrix. This is a very rigorous method. In the examination hall, this may click to you. I will tell you a shorter method as well. So this particular thing you can keep. This is simply a mathematics question I am solving, right? A maths question I am solving, nothing else. So 1 by 2, and then this matrix would come. This matrix would come. Arey yaar. So maths we are solving, nothing else. And then then this matrix would come. This particular matrix would come. So here 1 by 2 is already multiplied. So this is a constant. Can I take 1 by 2 here? Surely I can take. Because 1 by 2 is a constant, no? So 1 by 2 I am taking outside. And then purely this particular matrix would come. So what this will be equivalent to? DFT of y of n. And what is y of n? DFT of x of n. And this is what you are supposed to find. So can you solve it? And what this will be equivalent to? DFT of x of n. DFT of x of n should be equivalent to x of n. So as per the question, अरे यार 2-3 पेज ऐड करने पड़ेंगे, मेरे ख्याल से इतने पेज ही नहीं है. I have to इतने तो पेज ही नहीं है भाई, क्या करें? Like in one slide I can only insert 50 pages. This is the constraint here. So I will have to kill those last slides, that Parseval's theorem and this exponential Fourier series coefficient from DFT. This I will have to kill. Okay, we will study it in the next lecture. Because okay, fine. Yeah, so where I was, yeah. So DFT of x of n, this I need to calculate. So as per the question, what is given? DFT of x of n is equals to x of n. What is this? This is given, right? So can I calculate this particular thing? Yes. For that, what I need to do? Multiply these two matrix and then multiply with this one. So this multiplication you can do on your own. 1 plus 1, 1, this row will be multiplied with this row. What you will get? 1 into 1 is 1. 1 into 1 is 1. So I will just copy the matrix, paste it here. So I'm just writing down the final result. What I will get? Row multiply with column. So 1 into 1, 1 into 1, 1 into 1, 4. You are getting 4. And 1 by 4 is already outside. Then this row will multiply with column. What you are getting? 1 minus j minus 1 plus j, 0. Then this row multiply here. 1 minus 1 plus 1 minus 1, again 0. And next also you will get 0 only. So you will get a pattern actually. Okay, when you try to solve, you will get a pattern. Now this row will be multiplied with this column. So 1 minus j minus 1 plus j. What you are getting? 0. Calculation will not be difficult. 1 now minus j, 1 minus 1 plus 1 plus j. क्या कर रहा हूँ भाई? Minus 1, sorry. So this is also coming out to be 0 only. Next part is also 0. And third part will come out to be non-zero, I guess. So this row will be multiplied with this column. So 1 plus j plus 1 minus j. 1 plus j minus 1 minus j. क्या बात है भाई? क्या गड़बड़ हो रही है? Minus j actually. Yeah, 1 plus j minus 1. This is actually minus 1. So again this is also coming out to be 0. So last number will come out to be 4. So last number you can check. This will come out to be 4. 1. This would also be 1. This would also be plus 1. This would also be plus 1. So last number is coming out to be 4. So in that manner you can solve actually. Okay. You have surely seen a pattern, right? Now 1 minus 1, 1 minus 1, 0. 1 plus j minus 1 minus j, 0. 1 plus 1 plus 1 plus 1. So here in the third column you are getting. Here I am explaining, that's why it is taking time. Otherwise solving the matrix is not a difficult task. And here what will come? This will be the scenario. And then this matrix is multiplied with this matrix is being multiplied with A, B, C, D. A, B, C, D. So what is the answer you will get? 4A, 4B, 4C, 4D. So what answer you will be getting? And 1 by 4 is already outside. So 1 by 4, 4A, 4A, and then this row is multiplied with this column. What you will get? 4D. This row multiplied with this column. What you are getting? 4C. Then this row multiplied with this column. What you are getting? 4B. Should be equals to x of n. Should be equals to x of n. What was your x of n? X of n was A, B, C, D. Where was your x of n? X of n was A, B, C, D. A, B, C, D. So from here what you are getting finally? A, D, C, B is equals to A, B, C, D. So here you can see that A is equals to A, C is equals to C, D is equals to B, and B is equals to D. So what is the conclusion you are getting? That D should be equals to B. What is the conclusion you have got? D should be equals to B. So your x of n should be equals to, where D should be equals to B. That means second element and fourth element should be same. First and third could be anything. Second and fourth should be same. Where? Option B. So 1, 2, 3, 2. What is the answer? 1, 2, 3, 2. Second and fourth are same. Second and fourth are same. So this is a rigorous analysis. It will take 5 minutes in the examination. Okay. Surely it will take 5 minutes, but you will be able to get the answer for sure. Now let's be a bit smart. Let's be a bit smart. What is the definition that they have given and what is the definition that we know, that we are going to see. So what we know, first let's see that. What we know and what is the definition that they have given. Method 2. what we know. We know the actual DFT, that what is the actual formula of DFT. So actual DFT I am calling as DF, because they have already defined a function of DFT, you know. They have already defined DFT of x of n. So I am defining a function which is DF. So actual DFT of x of n, actual DFT of x of n can be given as DF of x of n. And what is the formula of that? That is summation n goes from 0 to n minus 1 x of n e to the power minus j k 2 pi by n, right? So what do you think, what will be the answer of df of x of n? So that I know it would be equals to n of x of minus n. This we have already seen. First df of x of n will be x of k, then df of x of k would be n x of minus n. This we have already seen, right? So sir, this answer I already know, but I know it with respect to df of x of n. But what they have defined? They have defined dft of x of n in this manner. This is their x of k, this is their x of k, and they are calling it dft. So this is the dft of x of n. So their defined function is dft of x of n, and our defined function is df of x of n. But they did not ask df of x of n, they asked dft of x of n. So what is the relation between dft of x of n and df of x of n? What is the relation? Here, if this under root n goes here, what I am saying, if this under root n goes here, so dft of x of n multiplied with under root n will be equals to df of x of n. Say yes or no. Are you able to understand this point? So basically, what did you understand? That under root dft of anything is equals to df of anything. Under root n dft of anything is equals to df of anything. So here in place of df, if I need to replace dft, so what I will do? Df will be replaced with under root n dft of anything. Df will be replaced with under root n dft of anything. X of n will be equals to n x of minus n. Did you understand this process? Again, this is mathematics only, but here we have seen something that we already know. Are you able to understand this point? Right? Are you able to understand? What we did, df of x of n we already know. Actually, we write it dft only, but actual dft they have already given some different name. So I have to give a different name. I gave it a name of df. So df of x of n and then df, again df. So df of x of n I already know n x of minus n. Now df of x of n is equals to under root n dft of something, because from this expression I go to know that if I take under root n this side, then I will get the expression that I already know. I already know this expression. I don't know this particular expression, but I already know this particular expression. So who was creating the problem? Under root n was creating the problem. So if dft of x of n is being multiplied with under root n, then I will get my df of x of n. That means under root n dft function is equals to df of under root n dft function is equals to function d of f. So d of f is replaced with under root n dft, under root n dft. Now under root n multiply with under root n. So n dft of x of n is equals to n x of minus n. So n will get cancelled. So what is the answer you are getting? dft of x of n is equals to x of minus n. Luckily, this particular method worked for you because only there are 2 DFT. If they have asked you to calculate 4 DFTs here, if they have asked you to calculate 4 DFTs here, then this method would be difficult for you, right? Are you able to understand this point? This particular method worked for you. This particular method worked for you because they asked you to calculate only 2 DFT. If they have asked 4 DFT, then this particular method would be difficult for you. So there you would have used your brain. And how would I use the brain? Let's just say here in the question they asked me 4 DFT. How would I use my brain? Let's just say I am following this method only. So when I followed this method, what is the answer I am getting? That ADCB is equals to ABCD. Can you understand what actually happened here? What if this is my x of n? If I say my x of n is which I have already said that it is a, b, c, d. If my 4 point x of n is a, b, c, d, then just let me know what will be your 4 point x of minus n. Make the circle. A, B, C, D. So x of n reads here. So where x of minus n will read? That would be A, D, C, B. So it was actually coming out to be x of minus n. So when you calculated 2 DFT, so what did you understand? That DFT of x of n was actually coming out to be x of minus n. So 2 times DFT is doing one inversion. So 4 times DFT will do another inversion. So what would be the answer of DFT of x of n? What would have been the answer? That would have been x of n, right? Based on the function that they have defined. If actual function is there, then this would have been the answer. If actual function is there, then this would have been the answer, n square x of n. But they have defined a different function. They have defined a different function, which is this. So with respect to this, even if they have given 4 DFT, still you would have got the answer. So no matter whatever that they do in the examination, if you are confident enough, if you have enough confidence on yourself and you have studied from this particular platform, if you have studied from PrepFusion, then there is no doubt that you will be struggling in any question that they ask, right? You will never struggle in any question, right? So this is how you need to perform. So even from this method you would have got the answer, and from this method very easily you would have got the answer. So what is the answer we are getting? DFT of x of n is equals to x of minus n. But given what is given? Given that DFT of x of n is given as x of n only. This is given. But what we actually got? We actually got x of minus n. So basically what you need, x of minus n should be equals to x of n. So you need to find that kind of x of n from the options. You need to find that kind of x of n where you get x of minus n equals to x of plus n. So for this particular function, what would have been your x of minus n? For this particular function, my x of minus n would have been 1, 4, 3, 2. For this particular function, what would have been your x of minus n? We are talking about 4 point x of minus n. That would have been 1, 2, 3, 2. For this particular function, what would have been my x of minus n? That would have been 1, 2, 2, 3. And for this particular function, what would have been my x of minus n? That would have been 1, 3, 2, 2. So what would be the answer? Option B would be the answer. Because here both are same. X of n is equals to x of minus n. 1, 2, 3, 2, 1, 2, 3, 2. So yes, option B is correct. So this was a good thing. This was a pretty good brain that we used. So you already know a lot of things. You just need to understand that how I'm going to use it. So DFT kind of function they have defined. So I find out the relation between under root and DFT that they have defined and whatever that I know. And based on that, I compared it and I got the answer very easily. Within 1 minute, I will be able to solve. But this might take me 5 minutes. So don't worry. Even if a question is taking 5 minutes, then also it is fine. In the examination, you will never be short of the time. What I am saying, GATE examination is never the exam of speed. You ask the top rankers, they never took more than 2 hours 20 minutes. It is never the examination of speed. It is the examination of accuracy. So even if it is taking 5 minutes, then also it is fine. Okay, don't worry. This method is also good, right? And if you have good enough brain, like to click this particular thing, it will take 4 minutes. What I am saying, let's just say if I had solved this particular question by this method, so this will click to me immediately. This particular method may click to me immediately, right? I will start solving it and then I will do the answer. So calculation will take 5 minutes, but it will click to me immediately. But to think in this direction, it will take 3 to 4 minutes and 1 minute to solve. So eventually you are taking 5 minutes only. Is that clear to you? I am just kidding. Okay, if someone is too smart, then it will click to him as well. If someone is too smart, or if someone has studied in a very good manner from this particular platform. So always do the marketing. Whenever you are teaching something good, always we should do the marketing. So just doing the marketing. Yeah, multiplication convolution property. So we have already seen the circular convolution. Here we just need to write down the property and solve some question, right? So yeah, do you remember in continuous time, what was the scenario? X of t multiply with h of t. What it would give you? X of omega convolution with h of omega. But whenever you are doing the convolution, 1 by 2 pi we divide, right? And if there was convolution, then here there was direct multiplication. So similar thing will happen here. Here if there is circular convolution, n point circular convolution between x of n convolution with h of n, then directly you will multiply. But if there is multiplication, here what you will do? Surely you will do the circular convolution, but you will divide by n, because 2 pi is replaced with n. So you will divide by n. Solve this question. So this is the first year. You can read DFT of ABCD is given as alpha, beta, gamma, neta. Then this particular matrix is defined, and then they have asked here the DFT of PQRS is scaled version of what? Are you able to understand this point? This particular information is given, this particular information is given, and they have asked this question. So where is PQRS? This is your PQRS. Can you let me know what is happening here? What this matrix is showing? Can you let me know what this matrix is showing? If I call this as x of n, what I am saying? My ABCD is x of n. I am saying that my ABCD is x of n. Okay. So what do you think what is happening here? And I am saying my y of n is PQRS. Y of n is PQRS. So your y of n is equals to some matrix. So here what you are doing the circular convolution, isn't it? The circular convolution of x of n with x of n. What you will do? Sir, there are two methods, row method and column method. If I go by the row method, what I will write down? A, B, C, D. Then here as well I will write down A, B, C, D only. Then sir, this D comes here, then A, B, C. Then sir, C comes here, then D, A, B. Then sir, B comes here, and then C, D, A. So everything same is happening. D comes here, then starting from the beginning. C comes here, starting from the beginning. B comes here, starting from the beginning. So this is how it is written. So PQRS is actually equals to x of n circular convolution with x of n. So what did you understand? Y of n is actually equals to x of n circular convolution with x of n. What you need to find? DFT of PQRS. That means you actually need to find y of k. So y of k would be equals to x of k multiply with x of k. That means xk square, right? Y of k will be xk square. So what will be your y of k? Y of k would be equals to xk square. What is your x of k? DFT of this is x of k, that is alpha square, beta square, gamma square, and neta square. So what you understood here is that DFT of PQRS, DFT of y of k is DFT of PQR, DFT of y of n, and y of n is PQRS. DFT of PQRS is equals to alpha square, beta square, gamma square, and neta square. So this is the answer. There you. So DFT of PQRS is scaled version of alpha square, beta square, gamma square, and neta square. What do they mean by scaled version? Scaled version. How they are calling it a scaled version? It is not the scaled version, it is just the DFT directly. DFT of PQRS is alpha square, beta square, gamma square, neta square. It is scaled by 1, scaled by a factor of 1. So they can write down scaled version. This is just to confuse you. If I say DFT, if I say Ram has 100 rupees and Sham has, I am writing down in Hindi, Ram has 100 rupees and Ramesh has 200 rupees. So Ramesh has the rupees which is scaled version of the rupees that Ram is having. Ramesh has the rupees which is the scaled version of rupees that Ram is having, scaled by a factor of 2. Scaled by a factor of 2. If he was having 100 rupees, then also I can say that Ramesh is having some rupees which is a scaled version of Ram is having which is a scaled version of the rupees which Ram is having. What I am saying, if it was having 100 rupees, then I could have said that Ramesh is having some rupees which is a scaled version of the rupees that Ram is having. So scaled by a factor of 1. So scaling means you need to multiply with something. So here it will be multiplied with 1 and you will get this answer. So DFT of PQRS is a scaled version of alpha square, beta square, gamma square, eta square. Okay, scaled version of alpha square, beta square, gamma square, eta square. Actually, this is the DFT. No scaling is there. Scaling factor is 1. Right? I don't know. I'm not sure why they wrote down scaled version. Am I doing any mistake? This is already circular convolution. अरे ये क्या कर रहा हूँ मैं यहाँ पे? Here I should have written x of k h of k. No, sorry guys. Convolution in time domain, multiplication in frequency domain, right? And multiplication in time domain, convolution in. अरे यार क्या कर रहा है भाई ये? Sorry guys, here x of k should have been written. No. DFT of x of n circular convolution h of n. What that would be? X of k h of k. DFT of x of n dot h of n, that would be 1 by n point 1 by n x of k circular convolution h of k. This is correct. That was just a brain fade. Here you will write down the DFT, no? So here convolution, then multiplication. Here multiplication, then convolution. Right? So here it was convolving. So you are getting the multiplication only. No issue there. So scaled version is not there. It is the direct answer. No scaled version. Okay. Some more properties are there. Linearity property. So n point DFT if you calculate, what you will get? This linearity property everywhere we have seen. Alpha of x1k plus beta of x2k. If n point DFT of x of n is n point x of k, then n point DFT of x n plus n naught will be what? So if x of t was having x of omega, then x t plus t naught was having e to the power j omega t naught x of omega. Here in place of j, what do we put? In place of j, what do we put? 2 pi by n k, right? So e to the power j 2 pi by n k n naught x of k. Is that clear to you? So you don't need to remember this property. You need to remember this property only. With respect to that, you can write down this particular property. So can I write it down in this manner as well? In what manner? In this manner as well, can I write down this property? Wn to the power k n naught x of k. Can I write down in this manner as well? Surely. What about this one? This particular thing is given. E to the power j k naught 2 pi by n. So let's compare. X of t was there, x of omega. E to the power j omega naught t, x of t would be x of omega minus omega naught. If I need to make the property in place of omega naught, what I will write down? 2 pi by n k naught n. 2 pi by n k naught n. Omega naught will be replaced with 2 pi by n k naught. If omega is replaced with 2 pi by n k, then omega naught will be replaced with 2 pi by n k naught x of n. So what answer I will get? X of k minus k naught. Yes, what you will get? X of k minus k naught. Here this could have been written as Wn to the power k naught n. So this is also how in some textbook you will find out the property written in this manner. So if it is written in this manner, then you will be able to understand what do they mean, right? Wn to the power k naught n. So x of k minus k naught. Is that clear to you? Okay, so how the properties could be written? Properties could be written in different ways that we have seen, and this is how you can remember the properties. Let's see some question. Do I have the page for this question? How many pages I am having? Only one. Yeah, so let's see this question. ABCD, this particular thing is given. You need to look. ABC is defined in this manner. PQR is defined in this manner, right? Small ABC is there, capital ABC is there, small PQR is there. You need to find the relation between PQR and ABC. Options are also given. So what I will do is that I will take the options in the previous page only, so that I can manage some space. Hopefully I will be able to manage the space. Yeah, sorry for the interruption. So let's solve this question. The options are here. Okay. Yeah. So you can try it on your own. Important part, a very important point which you might miss out, that is this particular point. Usually, how do we define our omega 3? This is what we define, e to the power minus j 2 pi by 3. This is how we define, but what is given? Actually, your actual omega 3 is, this is what we define, whatever that we define, power minus 1. This is what is given. So just let me know if this matrix is there for DFT or IDFT. What I want to ask is that this particular matrix is there for DFT or IDFT. This matrix will show DFT or IDFT. It will show DFT only, right? Because W3 to the power minus 1, what that would be? E to the power minus j 2 pi by 3. That means whatever the W3 that we define, that is written here. Are you able to understand this point? So if you see the matrix carefully, what you can see? That DFT of ABC is given as capital ABC. Are you able to understand this point? What I mean to say is that if my x of n is, ABC, 3 point x of n I should write. What I am defining? I am defining 3 point x of n. If my 3 point x of n is ABC, then what would be my 3 point x of k? That would be capital A, B, C. Do you agree to this point? Surely you agree to this point. Very surely you agree to this point. Say yes or no, right? Okay, so it looks minus 1, but it is actually plus 1. So if you are having this information, can you make another matrix where small abc is on the left hand side and capital ABC is on the right hand side? What I am saying, since you know this information, can you make a matrix where small abc is in the left hand side and capital ABC is in the right hand side? Why I want to do so? Because you need to compare ABC with PQR, and in this particular matrix, PQR is written in the left hand side. So what I would try to do is that if I am having this information, I will try to make a matrix similarly like this only. I will try to make a matrix where small ABC is there in the left hand side, small ABC is there in the left hand side, and capital ABC is there in the right hand side. So what I am doing, I am finding IDFT, right? So I am making the table for IDFT. So I am finding IDFT. If DFT of x of n is x of k, then IDFT of x of k will be x of n. So here I am writing ABC. So here what I will get? Capital ABC. But one thing I told you, whenever you find out IDFT, never ever forget to divide by capital N. But when you write down IDFT, will there be minus 1 or plus 1? Actually, we write down omega 3 to the power minus 1. But omega 3 is defined as e to the power j 2 pi by 3. So that's why we need to write down as omega 3 to the power plus 1, right? Because in IDFT, e to the power j 2 pi by 3 would come, and what I am saying? Yeah, in IDFT, e to the power j 2 pi by 3 would come, and omega 3 is given as e to the power j 2 pi by 3 only. That means in place of minus, we will write down plus, right? It is a very simple thing, very easy to relate. Basically, in DFT table, in DFT matrix, if you are getting power minus 1, so here you will get power plus 1. It is very simple. Now what I would do is that I would take this 1 by 3 inside. So can I do this thing that all these are divided by 3? Why I am doing so? Because basically I want to compare this guy with this particular guy. This is what I want to do. I want to do the comparison. That's why I am doing all these things. Now this particular matrix is given. This particular matrix is given. Now I need to compare, right? My job is to compare. So one matrix I am already having. Another matrix is there, which is this one. So in the matrix which I am having, which matrix I am having? This particular matrix I am having. So let me copy this particular matrix on the next page. So the matrix that I am having, which is somewhat like this. Matrix that I am having, it is somewhat like this. So who is creating the problem? Who is creating the problem? This particular guy is creating the problem. If you want to compare, then A by 3, B by 3, C by 3, A by 3, B by 3, C by 3, A, B, C, P, Q, R. One matrix is here, but here there are two matrices. So what you will do? You will reduce it to one matrix. So how will you solve it? 1 multiply with 1 0 0, so it would be 1 only. 1 multiply with 0 omega 3 to the power 2 0, so it would be omega 3 to the power 2. 1 multiply omega 3 to the power 4. 1 multiply here, 1 would come. Multiplication you can do on your own, right? Omega 3 to the power 3, then what would come? Omega 3 to the power 6. Then 1 omega 3 to the power 4, and then omega 3 to the power 8. Now this particular row and this particular row are same, right? What about omega 3 to the power 3? It will be 1. Omega 3 to the power 6, that will also be 1. Why I am writing down them as 1? Because I know that this particular row and this particular row will be same. What about this one? This particular row and this particular row have been captured. Which row is left? This row is left. So here power 1 2 is there. Can you make them power 1 2? Yes. Omega 3 to the power 4, it can be written as omega 3 to the power 1. Omega 3 to the power 8 can be written as omega 3 to the power 2. There you go. Now you can compare very easily. What will be your P equals to? P will be equals to 1 into a by 3 plus omega 3 to the power 2 into b by 3 plus omega 3 to the power 4 into c by 3. What kind of relation you are getting? P will be equals to c. What will be c? 1 into a by 3 omega 3 to the power b by 3. Basically this row and this row is same. That means P will be equals to c. P will be equals to c. Then you can see that this row and this row is same. That means Q will be equals to a. Q will be equals to a. And then this row and this row is same. That means R will be equals to B. R will be equals to B. So if you compare PQR, that will be equals to CAB. PQR will be equals to CAB. So PQR will be equals to CAB. So this is how it can click in your examination. This thing may click in your examination to you, right? This is how you will be solving. But there is another method as well. Surely, in most of the questions, we try to build two methods. So this is a method where you did not need to apply any property. You just had the pure concept. Just by the basics, you solved this particular question. That, sir, I need to compare. So I did the comparison making the matrices. So only by the basics you have solved this question. But what if I want to apply some property? I need to think in the direction of property. So let's try doing it. So this particular matrix was given. Now what if some guy says that, sir, I will multiply this particular thing here. Why he will do so? Why he will do so? Because he knows that if I multiply this particular thing here, so what kind of things I will be getting? A by 3 W3 to the power 2, B by 3 W3 to the power C, 3 by C by 3, right? And what kind of matrix is that? What kind of matrix is that? Basically, if I take this 1 by 3 outside, if I take 1 by 3 outside, it will be tough to click in the examination, but still I am telling. If I take this 1 by 3 outside, so can you tell me that if I say my y of n is PQR, then my y of k would be 3 point. Surely we are talking about 3 point. Then my 3 point y of k would be A W3 to the power 2, B W3 to the power 4, C. Do you agree to this point? Yes, sir. Isn't it inverse DFT? Okay. Yeah, it is inverse DFT only. Inverse DFT, it is inverse DFT, then this would be your y of k. From y of k, you are getting y of n. Basically, in the inverse DFT, what do? We have the value of y of k and we get the value of y of n. So we are having this y of k and we are getting this y of n. But sir, in the inverse DFT, you use power minus 1. But here minus 1 has been converted to minus plus 1. Your minus 2 has been converted to plus 2. Your minus 4 has been converted to plus 4, right? Here opposite thing is happening. Whatever that is plus, that has become minus. Whatever that was minus, that has become plus. So in the mind, you will think that it is omega 3 to the power minus 1 only. So this was the matrix for inverse DFT. That means if your DFT is this, then your signal would have been this. That means 3 point y of n is PQR, then its DFT would be A omega 3 to the power B and these things, right? Okay. Now another point, if I see this particular matrix, which particular matrix? The given matrix. If I see this particular matrix, so what is this? This particular table is of a DFT. That means if this is my x of n, this would be my x of k. Here you need to think negative power is actually positive power. So if this is your x of n, then this will be your x of k. So my 3 point x of n is capital ABC, sorry, small abc. 3 point x of n is small abc, and my 3 point capital X of k is a omega 3b, sorry, not omega 3b, from the first matrix I am getting. So if 3 point, this is ABC, so 3 point DFT would be capital ABC, simply capital ABC. Are you able to understand this point? Is that clear to you? Now you have studied some property. What is that property? That, sir, if x of n have x of k, if I do x of n plus n naught, what I will get? Even if you forget this property, what you will think? You would have got e to the power j omega t naught. So e to the power j 2 pi by n into k n naught x of k. This is what you will get, right? Just let me know one thing. What is your y of k? What is your x of k and what is your y of k? X of k is simply ABC. Where this is your k equals to 0. This is your k equals to 1. This is your k equals to 2. And what is your y of k? Y of k is simply a omega 3 to the power b omega 3 to the power 4 c, right? And can I write it down in this manner? Omega 3 to the power 0. This would be your y of k. So can I write it down in this manner? Omega n to the power k n naught x of k. Is that clear to you? So what do you think? What is the value of n naught? N naught value is 2. What I mean to say is that if I, in this x of k, if I do this particular thing, that I need to find W3 to k x of k. If I need to find this particular thing, what will be the answer? A into k equals to 0 you put, what will be the answer? You will be getting W3 to the power 0, that would be 0 only. Then k equals to 1 you put, what you will be getting? W3 to the power 1 b. Sorry, 2 into 1. K value is 1. So 2 into 1, W3 to the power 2 b. And if you put k equals to 2 here, W3 to the power 4 c. So what actually happened here? N naught value was 2. So x of n plus 2 will throw e to the power j. So simply I will write down Wn 2k x of k. So what did you understand? Your y of k was actually W3 to the power 2k x of k. So from here what you can understand? From this would have come from y of n, and this would have come from x of n plus 2, right? 3 points. So surely we are talking about 3 point only. So what is your 3 point x, 3 point yn? Your 3 point yn is PQR. What is your 3 point xn? Your 3 point xn is ABC. What you need to find? You need to find 3 point xn plus 2. So what did I tell you? First you find out x of n, and this is the origin. So first you find out x of n, that would be ABC, 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 and so on. Where is the origin? Here is the origin. X of n plus 2. What will be your x of n plus 2? The origin will move here. So what will be your 3 point x of n plus 2? That would be CAB. So this process we have already seen, right? Are you able to understand this point? This process we have already seen, no? This example we took. 3 point x of n is given. Then you need to find 3 point x of n plus 2. That means first you need to find out x of n. Then what you need to do? You need to find out x of n plus 2. What will be your x of n plus 2? So x of n plus 2 will be this ABC will keep on repeating. But what will happen? This center will move ahead, x of n plus 2, or you can see that samples are moving backward, but this arrow will move ahead. So arrow will come to C. And next what is written? A, B, and so on. Whatever that is written, I don't care. I just need to find 3 point x of n plus 2. That means I need to write down these 3 points. That would be CAB. CAB. So what did you understand? That your 3 point xn is coming out, 3 point yn is coming out to be PQR, and 3 point x of n plus 2 is coming out to be CAB. So both are equal. So PQR is equal to CAB. So what is the answer? PQR is equal to CAB. So the guy who framed the question, the professor who framed the question, he would have thought in this manner. Okay, he would have thought in this manner, but when he framed the question, we found out a very easy solution for this. But surely he would have thought in this manner, because why I am telling this thing? Because here the question paper setter should be appreciated. For this particular question, the question paper setter should be appreciated. He did not think in this manner. This is just a problem solving, but this is the pure concept. This is the concept behind framing the question. So if you study in this direction as well, then there is very high chance that you will be able to solve very tough question as well. Like in this manner, every student would have solved. Like those who have studied DFT in a very good manner, I would say like 50% of the students would be able to solve this kind of question. 50% if they have studied DFT in a good manner. Those who have studied, those who did not study, they will not solving it. They will not be solving it. Those who have studied, out of those 50% would be able to solve this one. Okay. But only 1% would be able to think in this direction. Not even 1% will not be able to think in this direction. That there is some property as well. So did you understand the importance of this kind of matrix? This kind of matrix is simply telling you about the shifting operation. So whenever you get this kind of matrix in the examination, you may think in the direction of properties as well. Is that clear to you? So this is very simple. Firstly, we multiplied these two matrices and our calculation became very easy and we got the answer. But what if we multiply these two matrices? Then we get to know that okay, something is being shifted. Our time domain sequence would have been shifted. If it is shifted, then this is the answer we are getting. So there you go. This was a very good question. Now we need to study more things, but slides are over actually. Okay, in one slide in one PPT I can only take 50 slides. So 50 slides have been already taken. So I need to change the slide. I will change the slide and then we will start. We need to study Parseval's theorem. Only small topics are left. Parseval theorems, and then we will find the relation between exponential Fourier series coefficient and DFT. There is a relation between EFs like DTFS and DFT. There is that relation that we will find out, and then we will see some miscellaneous concepts. Like we will go back to circular convolution again, and we will see cross correlation as well. So these points we are going to see. Okay, very simple thing, very straightforward. So in this lecture only we are going to see it. So let me change the slide and then we will get started. Yeah, welcome back. So what we are going to do now, we are going to find exponential Fourier series coefficient Ck using that discrete Fourier transform. Okay, if this question was given that x of n is periodic with the time period of 4 and 1 2 3 4 1 2 3 4 is being repeated. So what is the time period here? Time period is 4, and I asked you what is the value of Ck. So what you will do for finding out Ck, what you used to do is that first I will find out x e to the power j omega. So x e to the power j omega, that means I will find the Fourier transform. So the Fourier transform would be 1 plus 2 e to the power minus j omega plus 3 e to the power minus j 2 omega plus 4 e to the power minus j 3 omega. Then in place of omega, what I will put? K omega naught. In place of omega, I will put k omega naught and then divide by t naught. Divide by, not t naught, divide by n naught. Divide by n naught. So here value of n naught is equals to 4. Value of omega naught will be equals to 2 pi by 4, that is equals to pi by 2. So you will put the value and you will get the value of Ck. So 1 plus 2 e to the power minus j k pi by 2 plus 3 e to the power minus j k pi, right? Because in place of omega, k pi by 2 you need to put, plus 4 e to the power minus j 3 k pi by 2 and divided by 4. So this is the process you would have done, and with that putting the values of k, you could have find out the value of Ck completely, right? You would put k equals to 0, k equals to 1, k equals to 2, k equals to 3. In that manner you would have find out the value of Ck. Hectic process, right? Longer process. Just can you let me know one thing? In x of k, were not we doing the same thing? What I am saying, in x of k, were we doing the same thing till this point? What we used to do, we find x e to the power j omega, then in place of omega what we put? In place of omega what we put? Just a second, yeah. In place of omega, what we put? That in 2 pi window, I need n samples. So 2 pi by n k. So in place of omega, what I was putting? K 2 pi by n. What was the value of omega? K. What is the value of n? 4. So in place of omega, what I was putting? K pi by 2. Am I putting the same thing? Yes. The only difference is here divided by 4 is there, and in x of k divided by 4 was not there. So what did you get to know here? That your Ck is actually x of k divided by 4. Or what you can see, can you write down the formula of Ck? Yes. Sir, it would be 1 by n naught. Summation n goes from 0 to n minus 1 x of n e to the power minus j k omega naught n. Can you let me know what is this? If I am calling it n naught, so let's call it n only. Okay, what I am saying, this is n. N is the period. What is the n? N is period. N is period of x of n. N is the period. So can you let me know what is this? This is your 4-point DFT, right? Isn't it your 4-point x of k? This is your 4-point DFT of x of n, no? 4-point DFT of x of n. So what do you understand from here? It should be small x of n. It should be small x of n. So what do you understand from here? What do I understand? That let's just say x of n is having a period of 4, having a period of n. Then Ck could be given as n point DFT of x of n divided by n. There you go. So if this question was given where your x of n was 1 2 3 4 1 2 3 4 being repeated, 1 2 3 4 1 2 3 4 1 2 3 4 being repeated, in this question what I could have done, what I need to find? I need to find Ck. So what would be my Ck? So x of n is having a period of 4. So what I would do? 4-point DFT of x of n divided by n, that would be 4. So do you know 4-point DFT of x of n? What would be your 4-point DFT of x of n? 4-point DFT of x of n. So your 4-point DFT of x of n for 1 2 3 4, the answer was 10 minus 2 minus 2j. You can solve it, okay? You can solve it making the matrix. Basically you will make the matrix. You will write down 1 2 3 4 here, and here you will write down the matrix 1 1 1 1 1 1 1 1 1 in the middle, minus 1 minus 1 minus 1 minus 1 minus j plus j minus j plus j, and then you will solve it. So what you will see? Now what was the next number? I don't remember. 1 minus 2 plus 3 minus 4. I guess this was the number, right? So 4 minus 4 minus 2, and the next number was 1 2 3 4. Next number would have been 1 plus 2j minus 3 minus 4j. So minus 2 plus 2j. So next number was minus 2 plus 2j. Okay, I don't remember it, like I just tried to write down without the calculation. So you can make the matrix and you will get this value, right? You can make the matrix and you will get this value. Although it should be written for 4 points only, because you are calculating 4-point DFT of x of n, that means it should be written for 4 points only. But I know that Ck will be periodic, no? There is nothing 4 point, 3 point, 2 point, nothing like that in case of Ck. In case of x of n, in case of x of k, we can define it for 4 point as well, we can define it for 3 point as well. But in case of Ck, what is the scenario? In case of Ck, whatever the period of x of n is there, the same kind of DFT, the same kind of exponential Fourier series coefficient I will get. So what would be my Ck? My Ck would have been this tan divided by 4, minus 2 minus 2j divided by 4, minus 2 by 4, minus 2 plus 2j divided by 4, then again 10 by 4, then minus 2 minus 2j by 4, then minus 2 by 4, minus 2 plus 2j by 4. Okay, and where will be the origin? Origin will be here. Basically, this will be your k equals to 0. This will be your k equals to 0. Then k equals to 1, k equals to 2, k equals to 3, k equals to minus 1, k equals to minus 2, k equals to minus 3, k equals to minus, in that manner you can check. So what is the point? Like if you feel like that, sir, my calculation is going tough with this particular method, then you can go with this particular method as well. Or in one mark, this can be asked as well. That what would be your CK? If your x of n is periodic with the time period of n, and you are calculating 4 point DFT of x of n, so or you can say you are calculating n point DFT of x of n, then what would be the value of your exponential Fourier series coefficient? So that would be equals to n point DFT of x of n divided by n. So in one mark directly this statement could be asked, but it is very rare that you will be using this particular thing. You will get most of the answer using this particular method only. But if you are stuck somewhere, or somewhere who knows DFT of x of n is mentioned, if DFT of x of n is mentioned, then you can directly calculate the value of CK. Although till this date in any examination this kind of question was not asked. Okay, they never asked this kind of question, but who knows, it may be coming. All good. Let's see the Parsevals. So do you remember the Parseval for DTFT? Or let's write down the Parseval for CTFT, for continuous time Fourier transform. So what was the Parsevals? Minus infinity to infinity, x of t, h of t. So that would be equals to, I told you one thing, whenever x to the power omega comes, 1 by 2 pi also comes. So minus infinity to infinity, x of omega, second one inverted. This was the answer, right? So here also the same thing will be happening. The same thing will be happening. X of k, the other one inverted. What about the limit? Here the limit goes for n points, right? Limit goes for n points. What I am considering, x of n and h of n are n points sequences. So they are n point sequence. So this is how it will go. And they are also n point DFT. They are also n point DFT. Very rare that they will ask any question on this particular topic. Like from Parseval's, yeah, one more blunder. If I am doing 1 by 2 pi, here 1 by n should come, no? So this is the thing that will happen, right? With a lot of students, this will happen, that they will forget to divide by 1 by n. In case of DTFS, what was the, let's write down the Parseval for DTFS as well. So what was the scenario in DTFS? In discrete time Fourier series, what was the scenario? That n was going from 0 to n minus 1, because this will also be periodic, x of n, h of n, here ck, h of minus k, and here k will go from, अरे यार यहाँ पे n क्यों लिख रहा हूँ मैं? Why you are writing n? Because this is the function of k only, no? So here k will go from 0 to n minus 1. But here nothing was divided with n. Nothing was divided with n. But here it will be divided with n, right? 1 by n would be there. Here 1 by n was not there, right? In case of continuous time, what was the equation? So in that manner you need to relate. How do I remember? Like usually I remember that for sinusoid, c of 1 was 1 by 2j and c of minus 1 was 1 by 2j. So if I do the square and then I add them, so I know that I will get the power, right? What power I will get? 1 by 4 plus 1 by 4, that would be equals to 1 by 2. That means I don't need to divide anything here. I remember the example of sinusoid. Sin t, what is the power of sin t? What is the power of sin t? And here it was power actually. Okay, it was power. So again blunder from my side. Here it was 1 by n. So look, I remembered it because when you find out the power, what formula do you apply? Mod of x of n square for one period divided by n. So then I got to know that here 1 by n was there, right? In case of DFT. So here 1 by n was there. This was the Parseval's theorem in case of DTFS, right? So I remember the power of sinusoid. What was the power of sinusoid? 1 by 2, right? And I know that C1 value is 1 by 2, C of minus 1 value is 1 by 2j. These values I remember. If you do the square, if you directly do the square along with the magnitude and you add them up, what's the answer you will be getting? 1 by 4 plus 1 by 4. What is the answer you are getting? 1 by 2. That's it. That means you just need to do C of n square, nothing else, and for one period. If it is periodic, and if it is not periodic, that means you need to take from minus infinity to infinity. So this is how I remember it. So by the example, you can keep this in your mind. I'm just telling that how will you remember the things. Okay, here also I was messing up. I was forgetting this 1 by n, right? But since from DTFS is like exponential Fourier series, you calculate for periodic signal only, and for periodic signal you don't find the energy, you find the power. Here what we are finding now, here what this will represent, n goes from 0 to n minus 1. This is also n point, and this will surely be n point only. So this will represent the energy of n point x of n. This will be energy of n point x of n, right? Because I am only taking consideration n points only. So this will show the energy of n point x of n, right? So what I will be getting, 1 by n summation k goes from 0 to n minus 1. Okay, forget about it. First let's solve it. What this will represent? This will represent summation n going from 0 to n minus 1 x of n whole square, and that would be equals to 1 by n. You know how whole square came into action? A dot a conjugate, that would be mod of a whole square. So x of n dot x of n conjugate, that would be mod of x of n whole square. N goes from 0 to n minus 1. First one as it is. अरे यार भाई कुछ तो हो रहा है आज मेरे दिमाग में. So what will be the Fourier transform of x of, what will be the discrete Fourier transform of x of n? That would be x of k. And what would be the DFT of x conjugate n? That would be x conjugate minus k. But here you need the inversion, so here also we will get the inversion. So what we are getting, x of k multiplied with x of k conjugate, what that would be? So 1 by n summation n goes from 0 to n minus 1 mod of x of k square. There you go, this is the answer. Okay, and here this is the answer. So duality property and everything, like do you remember the duality for CTFT as well? For CTFT, right? I hope you remember all these kind of things. So these are important actually. The questions, there is very high chance that like if you see the PYQs, you will see there are a lot of questions from duality and all these kind of things. So in a continuous time, okay, for CTFT I have written already. Let's write down for DTFT. So in DTFT, x of n multiply with h of n, right? Where n goes from minus infinity to infinity because they are aperiodic. So what you will get, 1 by n, not 1 by n. Why not 1 by n? Because x e to the power j omega will be continuous. So 1 by 2 pi, it will be continuous and periodic. Since it is periodic, that's why minus pi to pi, x e to the power j omega, h e to the power minus j omega d omega. So DTFT we have written, CTFT here only we have written, right? DTFS we have written. What is left? CTFS is left. What is left? CTFS is left. So let's write down for CTFS as well. So in one page only we have written all the Parseval's theorem. So for CTFS as well, everything goes same. But in CTFS, this kind like x of t will be continuous, right? In the left hand side, you are having continuous signals. Basically, in case of continuous time Fourier series, here you are having continuous signals, no? So x of t multiply with h of t dot dt, right? Going from where to where? Minus t by 2 to plus t by 2 divided by 1 by t. That means you are saying that xt and ht are periodic within the time period of t. That would be equals to what? Summation Cn h of minus n. But Cn and h of n are not periodic, they are aperiodic. So n goes from minus infinity to infinity. If you are following everything from the beginning, right from where I told you to follow, then you will be able to write down all the expression and everything. Like you will never be getting confused. Otherwise, in these expression, everyone will be getting confused. They will feel like their signal system is completed, but once the things are compiled up, these things happen, right? So here in this page only, we have wrote down all the Parseval's theorem, right? All the possible Parseval's theorem. So this is a very good revision page for you. This page is good for revision. Yeah, that's it. That's it about DFT. But let's discuss one important point as well. One more important point we need to discuss. So we have studied circular convolution, right? So there I told you the method, that how you can calculate the circular convolution. There is row method, there is column method. But I did not give the definition, no. Like there is a definition as well, no. There is basic fundamental definition, and that basic fundamental definition I forgot there, which is absolutely wrong. Like in signal system, I tell you that you learn the method, how to solve the problem, you learn everything, but never ever forget your fundamental formula. Fundamental formula means from where the things came into action, the first formula. So that you should not be forgetting. So I did not give you the actual definition, that what is the actual definition of circular convolution. So some of my students asked me, so that's why I thought that I should have given the definition as well, that how the circular convolution came into action. So what was the definition of linear convolution? The linear convolution definition was that first one remains as it is, second one inverted and then shifted, and whose limit you will put? Limit of k you will put, right? Minus infinity to infinity. First one as it is, second one inverted and then shifted. We saw the complete derivation, what is the meaning of linear convolution in basics of signal. But when we started studying DFT, when we started studying DTFS, we studied about circular convolution. So we got to know that it is defined for periodic sequence. In periodic sequence, what we do is that we take out some n point x of n, we take out some n point h of n as well. So x of n was periodic with something, h of n was periodic with something. From there we got out n point sequence x of n, and from there we got out n point sequence h of n as well. And then we defined the circular convolution x of n circular convolution with h of n. So how the definition goes? Definition goes, first one as it is, second one inverted and shifted. Then sir, what is the difference? Difference is the limit will go from 0 to n minus 1. But another difference is there. Here you need to write down mod n. This is another difference. What do you mean by this mod n, sir? Let's check out. Let's understand the meaning. Okay. So let 4 point x of n and h of n are given. You are defining 4 point circular convolution. 4 point circular convolution. X of n circular convolution with h of n is given by y of n, and that I am saying that it would be equals to summation k goes from, forget about k, first one as it is, second one shifted and then, sorry, inverted and then shifted, but mod of n I am writing down. But here what is the value of n? 4. Okay, and k goes from 0 to 3. Now let's just say I need to find the value of y of 1. What I need to find? Let's calculate y of 1. So in the examination, if they are asking me y of 1, will I use this definition? No, I will go by my matrix method. No, I will make the matrix, and I know that first row multiply with first column will give me y of 0. Second row multiply with this column will give me y of 1. So I will do this, right? But I am explaining you the meaning of this. What I am doing, I am just explaining you the meaning. So what would be your y of 1 equals to? Y of 1 would be equals to summation k goes from 0 to 3. In place of n you need to put 1. So x of k, in place of n you need to put 1, mod 4. Now start putting the values. Put k equals to 0, what you are getting? X of 0, h of 1 mod 4. What is the value of h of 1 mod 4? That is h of 1 only. So here, even if the mode was not there, it would still work. What I am saying, if I did not put the mode, so what answer I would get? 1 mod 4. Still it was okay for me. If I did not put the mode, so what I would have got here? H of minus k plus 1, and value of k I am putting 0. So h of 1 I would have got, same thing I would have got. So no issue here, right? No need to worry. Or let's write down 1 mod 4. 1 mod 4. We will solve it later on. Okay. Let's write down 1 mod 4 plus x of 1, that would be equals to h of, what I am doing, basically I am putting the values of k. Now first I put k equals to 0. What I am getting? X of 0, h of k mod 4. Then I put k equals to 1. So x of 1, h of 0 mod 4. Then I put k equals to 2. Now here the things will be different. What I am getting? If you put 2 here, what you are getting? Minus 1 mod 4. Now let's just say if this was not there. If this mode 4 was not there, what you would have got here? H of minus 1. Now, how your H of n is defined? Your H of n is defined as 4 point x of n. That means it is defined as H of 0, H of 1, H of 2 and H of 3. So, from this 4 point H of n, if I ask you what is the value of H of minus 1, what you will say? 0. But this does not happen, right? In the matrix, it doesn't happen that H of minus 1 is 0. So, actually what happens is that you take the mode minus 1 mode 4, minus 1 mode 4, and what is the value of minus 1 mode 4? You will add 4 here, what you will be getting? 3. So, it is H of 3 actually. Are you able to understand this point? Right? So, this is how we define it. X of 3, what you will be getting? H of minus 2 mode 4. So, what you are getting? X of 0, H of 1 plus X of 1, H of 0 plus X of 2, H of 3. Right? How I am writing down H of 3, you should be knowing it, right? Because I have spent more than enough time here. Plus X of 3, then I will add 4 here, so what I will be getting? H of 2. So, this is your Y of 1, and you solve by the matrix method, you will get the same thing only. So, did you understand the meaning that why this mode was important? So that you could understand that this mode was important, so that you could get everything in this range only. Here you would have got H of minus 1, but if you have written down mode of 4, that means it is periodic with 4. So what will happen is that H of minus 1 will actually be equals to H of 3 only. What I mean to say is that if my 4 point H of n is this, 4 point H of n is this, which is H of 0, H of 1, H of 2 and H of 3. So what would have been my actual H of n? What would have been my H of n, which is periodic with 4, periodic with 4 samples. So that would have been H of n, which is periodic with 4 samples. That would have been, it is periodic. So what would happen? H of 0, H of 1, H of 2, H of 3, then again H of 0, H of 1, H of 2, H of 3 and so on. So this would have been my origin, because what you have written down 4 point H of n, that means you have written down these 4 samples, H of 0, H of 1, H of 2, H of 3. Now if I ask you what is the value of H of minus 1, it is equals to H of 3 only. What is this? This is your n equals to 0, so this is your n equals to minus 1. This is your n equals to minus 2. So what is the value of H of minus 2? That is equals to H of 2 only. What is the value of H of 1? It's 1 only. So if 4 point something is defined, 4 point x of n, 4 point y of n, 4 point h of n, that means it would have come from a periodic sequence, no? H of n was a periodic sequence. From there you got 4 point h of n. So when you are calculating the circular convolution, that means what you need to consider, you need to be bounded by these 4 points only. But if you are getting n equals to negative, if you are getting negative, that means you need to take the mode. So this is how your circular convolution is defined. In a lot of textbook as well, you will see this is missing, which is absolutely wrong. So mode of n should be written there, and why it should be written, that region I have given here, that this minus is coming, minus is coming. But if I say that my x of n and h of n are periodic with period n, and now I am calculating n point circular convolution, so how my y of n should be defined? What I am saying, there is difference between this statement and then there is difference between this statement. Here your x of n and h of 1 were 4 points. What I am saying, x of n and h of 1 were 4 points. But now your x of n and h of n are periodic. They are periodic and here they were 4 points. So for this case, what would have been the value of h of minus 1? What would have been the value of h of minus 1? So for this case, you would have said that, sir, it is 0. But since I have put the mode, then it is non-zero. H of minus 1 mode 4 is non-zero, but h of minus 1 would have been 0. But for this case, what you will say? If x of n and h of n are periodic, then what would be the value of h of minus 1? So that would be equals to h of 3. That means this mode is not required. So basically the conclusion is, in the question, in the gate question, if they have written that x of n and h of n are periodic, then they can define it in this manner. That directly they will write x of n, sorry, first one as it is, second one shifted, second one inverted and then shifted, and limit will go for k 0 to n minus 1. So this is also how it can be defined. They will not write mode of n here, but they will not write mode of n here only when both are periodic. Why is that so? Because if you don't write mode of n, then at some point you are getting h of minus 1. If you don't write mode of n, that means at some point you will get h of minus 1. But for 4 point h of n, h of minus 1 is a problem. But for h of n being periodic, h of minus 1 is not a problem. H of minus 1 is equals to h of 3 only. So same answer you will get. In this particular problem and in this particular problem, you are getting the same answer, but the definition is different. Are you able to understand this point? Right? The bottom line is, if the question is coming that one sequence they have given, another sequence they have given, and they asked you to calculate n point circular convolution, you will just make the matrix and your question will be solved. Right? But in the examination, what may happen? They can just write down the definition. They will only write down the definition and they will ask you to calculate y of n. So there you would be thinking that, sir, what it is? Sir, it is your, sir, what it is? Basically what they are defining. Sir, it is your circular convolution, sir, it is what? So the definition you should be knowing. Otherwise you will be thinking, sir, what is this new thing? So if definition is clear, then directly you will write down the, sir, y of n is equals to x of n circular convolution with h of n. Now they can ask you the DFT, so DFT will be x of k dot h of k. There you go, this is the answer. Are you able to understand this point? Right? Well and good. So these kind of things can be asked in the examination. So that's why always the definition is very important. Method is also important, but definition is also important, because in the statement they can write down the definition. If you just remember the method, if you don't remember the definition, then you will not be able to solve the problems. So is the definition of circular convolution clear? This is the actual definition of circular convolution. This is the actual definition of a circular convolution. But if they are periodic, they can drop this mode of n. If it is periodic, if x of n and h of n are periodic, then this mode of n could be dropped. Because even if inside the bracket negative is coming, then periodic sequence has no problem. But n point sequence has some problem. That's why mode 4 should be written. All good? All fine? So remember the definition. It is same as linear convolution only. It is same as linear convolution only. Just remember the limit will be going for one period only, 0 to n minus 1. All good? All fine? Let's study something called autocorrelation and cross correlation. Autocorrelation and cross correlation. So let's just say there are two signals, xt and yt. So if you are calculating correlation between xt and yt, then it is known as cross correlation. What I mean to say is that cross correlation means it should be calculated between xt and yt, and autocorrelation means it should be calculated between xt and xt. Now in this particular chapter, I will only tell you the formula of this. What I am saying, I will only tell you what is the formula of autocorrelation. I will only tell you what is the formula of cross correlation. I will not tell you the meaning of all this. Meaning of all these will be cleared in communication system. Meaning of all these will be cleared in communication system. Okay. And one thing I can say, that electrical guys can leave now. It is not in their syllabus. Autocorrelation and cross correlation is not in your syllabus. It is not mentioned. You guys can leave. But don't leave. One more topic would be there, no? Some miscellaneous. For this video, for this particular video, you can leave. Go to the next video. In the next video, I am teaching some miscellaneous concept. So those miscellaneous concept you need to watch. Okay. So for this particular video, you guys can leave now. Electrical guys, this is not in your syllabus. Cross correlation and autocorrelation is not in your syllabus. Instrumentation guys and EC guys will be staying. The same topic we will be studying in communication as well. The same topic, but more in depth. There I will tell you the meaning of autocorrelation and cross correlation. But as of now, just for the signal system purpose, because it is mentioned in the syllabus of signal system. In the syllabus of signal system, they have written the word autocorrelation and cross correlation. That's why I need to teach it here. Otherwise, I would have directly taught in the communication system. So actual meaning of autocorrelation, actual meaning of cross correlation, what does it represent what was the basic intuition behind all these things. So that will be covered in communication system. As of now, we will just see the definition. So what I have written, so electrical guys will be leaving this lecture. So what I have written now, cross correlation of x of t with y of t, cross correlation of x of t with y of t will be defined as r x y tau. How it will be defined? Cross correlation of x of t with y of t. Again, let me write it down. Cross correlation of x of t with y of t is defined as r x y tau. What is the definition? In a lot of textbook, you will find its definition wrong. So what is the definition? Definition is, what was the definition of your convolution? This was the definition of your convolution, right? Here, what will be the definition? Here, in place of t, in place of tau, what you will say? X of t will come as it is. Y of t also thought that I will come as it is. Y of t also thought that, sir, I will come also as it is. But conjugate also happened and minus tau also took place. And limit will be with respect to t, going from minus infinity to infinity, because final answer you need in terms of tau. Again, let me repeat, how will you remember? This you remember, right? One as it is, another one inverted and then shifted. This is how we remember it. In case of cross correlation, what happens? In case of correlation, what happens? The first one as it is, the first one as it is, second one wanted to come as it is only, but what happened with this guy? Conjugation and then shifted as well with the tau, and negative sign is there. In a lot of textbook you will find positive sign, which is wrong. Okay, negative sign should be there. Are you able to understand this point? T minus tau. Fine. Is that clear? Will you be able to remember the definition? X of t wanted to come as it is, y of t also wanted to come as it is, but what happened? Conjugation along with the shifting as well, but minus tau. Now just let me know one thing, and sorry guys, the limit will be with respect to t. Why with respect to t? Because final answer you need in terms of tau. So limit will be of t only. Now just let me know one thing, can I replace t minus tau with alpha? So what will be your d tau? Sorry, what will be your dt? dt will be equals to d alpha. And what will be your t equals to? T will be equals to alpha plus tau. So what I will be getting? Minus infinity. And where the limit will go? If t is tending to infinity, then alpha will also tend to minus infinity. And if t is tending to plus infinity, then also alpha will tend to plus infinity only. So limit will go from minus infinity to infinity. X of, in place of t, what you need to put? Alpha plus tau. Alpha plus tau. Y conjugate. In place of t minus tau, what you need to put? Alpha. And in place of dt, what you will put? D alpha. Now again what I am doing? I am again replacing alpha with t. So what you will be getting? Minus infinity to infinity. X of t plus tau y conjugate t dt. So one definition was this. This was the one definition. This is just the derivation. यार क्या करें इसका derivation का, ठीक है? Okay, fine. T minus tau is replaced with alpha, so this is what you are getting. So this was the one definition, and this is the other definition. Here only I am writing down that I will replace alpha with t now. So if I replace alpha with t now, this is what I am getting. So this is the other definition. This is the other definition. But always remember what is written here. xy. What is the meaning of xy? Correlation of xt with yt. Correlation of xt with yt. xy. If I had to find correlation of yt with xt, then it would have been different, right? So rxy and ryx both are different thing here. So two definition we have given, and both of the definition should be there in your mind. Okay, x of t wanted to come as it is. Something happened with y of t. Y of t also wanted to come as it is. So y conjugate t minus tau dt. Now here what you will say? X of t wanted to come as it is, but y of t said that I am having a lot of pressure. I am having conjugate as well. I am having the shifting as well. So what yt will say? that at least shifting you take. What YT will say is that, sir, I am already having a lot of pressure, conjugation as well and shifting as well. So YT will say, sir, XT, please take some pressure. So XT will say, I will not take the conjugate because you are afterward. You are already late. So I will not take the conjugate, but I will take the shift. But here you are taking the negative shift, I will take the positive shift. So just a way to remember, in this manner you will be able to remember. Just talk to XT and YT. Correlation of X with Y. That means Y is coming late. Correlation of X with Y. So whatever that wrong happens, that happens with Y. Nothing wrong happens with X. But after that, after some time, Y started crying and he says that, sir, I cannot take a lot of pressure. I am having conjugate as well. I am having a shift as well. So what you do is that, sir, you take the shift. But X will say that if you are taking the negative shift, I will not do the same work that you have done. I will do something different. I will take the shift of toe only, but I will take the positive shift. So these are the two answers. Okay. Correlation of XT with YT. So shall we write down it again? So correlation of XT with YT. So let me write it down again for you. So how will you remember it? Correlation of X with Y. Okay. So what you will do? Limit will go from minus infinity to infinity only. XT will come as it is. Y will say that, sir, I also want to come as it is only, but there will be some shift in me. Okay. Now YT will say that, sir, enough of shifting. I am having shifting as well. Along with that, I am having conjugate as well. So please, sir, X, you take some responsibility and let me be this. So this X is taking the responsibility of shifting and Y is taking the responsibility of conjugate. So this is the definition, correlation of XT with YT. Similarly, correlation of YT with XT. So here who is coming late? XT is coming late. So whatever wrong happens, that will happen with X. So what will happen? Let's check. Correlation of YT with X. So Y is coming first. So Y will say, I will come as it is and all the pressure on X. You will say X will take the conjugate as well. Along with that, it will take the shift as well. But now what will happen is that this X will say, sir, a lot of pressure is there. I will only take the conjugate, you take the shift. So Y will say that I will take the shift, but positive shift. This mistake I again and again do. Okay, it would be dt, no? It is very obvious. If the function is of tau, then it should be dt here. So this is the definition of correlation of YT with XT. Let's not keep it in the box. If you can write down the correlation of XT with YT, then you can write down the correlation of YT with XT as well. Very simple it is. Right? Okay. Now next question is there. Try doing it on your own. ZT is defined as XT convolution Y conjugate T. You need to find ZT and then you need to replace T with tau. Let's see what you get. XT convolution Y conjugate minus T. Okay, so let's do it. Minus infinity to infinity. First one as it is. Let's call it HT. What I am saying? I am calling HT equals to Y conjugate minus T. So here what I would have done? Minus tau plus T. Inverted and then shifted. So that means what would have been your H of so HT is Y conjugate T, right? Now you need to calculate H of minus tau plus T. What that would be? Sorry, it would be Y conjugate. In place of T, you need to put minus tau plus T. So what you will get? Tau minus T, right? HT is Y conjugate minus T. Basically, what I am saying is that this convolution is XT convolution HT. So XT convolution HT would have been defined like this, right? Now what I would do is that minus infinity to infinity, x of t will be x of tau only. Now in place of h of minus tau plus t, what I can put? Y conjugate tau minus t. Y conjugate tau minus t dot d tau. Dot d tau. So this is my zt is coming out to be, right? Zt is coming out to be minus infinity to infinity x of tau y conjugate tau minus t d tau. What I am doing? I am replacing t with tau and tau with t. Just I am interchanging t and tau. Here whatever the t was there, what I am doing? T and tau I am interchanging. T and tau. Basically this particular function will be there in terms of t, right? What will be the final result? The final result will be coming in terms of t. It will be a function of t, which is equals to zt. I want to make it a function of tau. So I will put the limit of t and I will make it a function of tau. So just I am replacing t with tau, nothing else I am doing, right? Both are the limit of time only. So with respect to t I can put tau. So what you will get? Z of tau would be equals to minus infinity to infinity. In place of tau you need to put t, x of t, y conjugate. In place of tau you need to put t. In place of t you need to put tau. In place of tau you need to put t. What is this? Z of tau. What is this? R x y. Correlation of x with y. So for correlation this is the definition. But what if I ask you find the correlation between xt and yt? Will you apply this definition? No. What you will do? If I ask you find the relation of xt with yt, correlation of xt with yt. So who is coming first? Xt is coming first. So xt as it is, convolution with y conjugate and then shifted. There you go. This is what you will calculate. The final answer will be coming in terms of t, but you know that final answer of correlation comes in terms of tau. So in place of t you will put tau. Whatever the answer that you get here, in place of t you will put tau. But it is not certain that final answer of correlation should be in terms of tau only. No, nothing certain is there. It can be in terms of t as well. This year there was a question in communication based on this concept only. The final answer of correlation could be in terms of t as well. The final answer of convolution could be in terms of tau as well. So tau is just a unit, right? Tau is just a axis. It could be anything. So if I am asking you the correlation of xt with yt, what you will do? Xt convolution with what I am asking? Correlation. But you will calculate it using the convolution. So xt convolution with y conjugate minus t, right? And then whatever the final answer you get, that you will replace. Final answer you will get in terms of t, but in place of t you will put tau. There you go. So can we write down the conclusion? What is the conclusion? Cross correlation of xt with yt is given as rxy tau. This definition we have seen. Oh, let's write down everything, okay? Because I don't know why I have written all this before, just to save the time, but forget about saving the time. Let's write down again. Correlation of x with y. X with y. Minus infinity to infinity. What is the basic definition? Because I told you, I can always tell you the technique to solve the problem. This is just a technique to solve the problem, no? This is just a technique to solve the problem. I can always tell you the technique to solve the problem, but definitions are very important. Always remember the fundamental concept. Fundamental concept and trick, best combination. No matter whichever the subject you are studying, if your fundamentals are clear and you have the problem solving skills, there is no one who can beat you, okay? So first one as it is, second one also wanted to come as it is, but it was shifted. Along with that it was made conjugate as well. If yt is real, then this conjugate will have no impact, right? If yt is real, then conjugate will have no impact. Second, this yt said that, sir, I am having a lot of pressure, so you take the pressure and I will just have the conjugate. Again I am writing tau. I don't know when I will improve it. It will be t, right? All good, all fine. So x of t convolved with y of conjugate, since it is coming late, so y conjugate minus t. Can you remember this particular thing? And then t will be replaced with tau. Can you remember this particular thing? If I am asking you the correlation of xt with yt, then what you will do? x of t convolution with y conjugate minus t. The one which is coming second, that will take all the pressure. It will take the pressure of inversion as well, it will take the pressure of conjugate as well. Similarly, can you write down the cross correlation of yt with xt, and similarly can you write down the auto correlation of xt with xt. Actually this should not be written xt with xt, it would be auto correlation of xt, auto correlation of xt. So by default that means you are calculating cross correlation between xt and xt only. So auto correlation of xt would be what? So that is written as rxx2. So which is coming first? xt is coming first. So xt will say that I will come as it is. Who is coming second? xt is only coming second. xt only is coming second. So xt was also saying that I wanted to come as it is, but there was a shift. Now the second xt is saying that sir, I am having a lot of pressure, so you take the shift. So then you said that, then first xt said that okay, I can take the shift, but I will take it in positive, right? And then it can be written as first one as it is convolution with the second one conjugate and shifted, and whatever the answer you get, this thing you need to do. Correlation of y with x, y with x. So now y is coming first. So now y will say that I will take my revenge, I will come first as it is. Here x also wanted to come as it is, but there was a shift, along with that there was conjugate as well. Now x started crying, he said that I cannot take all the pressure, so please y take some pressure. Y said that I will take the shift but in the positive direction, x conjugate t dt. And how will you write down in this term? That first one as it is yt convolution of yt with xt. So yt as it is, sorry, cross correlation of yt with xt. So yt convolution with x conjugate minus t, then t should be replaced with tau. So here we are not going to see an example, but these definitions are important. This slide is important for you. Only this slide is important for you. So here we did not even just write down the results, we saw the relation as well, that what was the actual relation. So did you understand? You did not understand the meaning of cross correlation, but you actually understood the formula of cross correlation. Meaning I will tell in communication system. Okay. Meaning of cross correlation is not clear to you. Meaning of auto correlation is also not clear to you. What does it represent? All these things are not clear to you. But actually the formula is clear to you, right? So cross correlation is nothing but convolution only. Convolution of what? If you are calculating between xt and yt, from xt to yt, xt with yt, that means xt as it is convolution with y conjugate minus t, and then yt with xt, so yt as it is convolution with x conjugate minus t. Okay. Similar thing you can write down in terms of discrete as well. So do it on your own. Similar thing you need to write down in terms of discrete. So all these slides should be filled by you, and then the similar thing you need to write down as circular cross correlation, circular cross correlation and circular autocorrelation. And then what will happen? Okay, if it is periodic, then periodic thing I did not write. So you fill these two slides. This slide also you need to fill, and this slide also you need to fill on your own. I will take a break now. Okay, so fill the slide and then you solve this question, which was solved by a lot of educators wrong. Okay, everywhere I saw the solution of this particular question, they did it wrong, like, which is very sad. FT and GT represent continuous time real valued signal. HT denotes the cross correlation between FT and G of minus t. Then you need to find the Fourier transform. So try doing it on your own, you will be able to do it. No need to worry about it. Okay, and then we will solve this question, and with that we will be able to complete our DFT, and then we will move to our miscellaneous concepts. Okay, so just do it, just do this one, then write down this one, try solving this question, and you try solving this question as well. Okay, yeah. So let me take a break and then I will come back. Yeah, so did you write down the expressions? So you need to find the cross correlation of xn with yn. So first xn will come. So xn will say that sir, I will come as it is, all the pressure on yn. So yn wanted to come as it is, but conjugate and then shift as well. And the limit will go from minus infinity to infinity. Limit of n or k? Limit of n. Why limit of n? Because final answer you need in terms of k. Right? What could be the other way? Y will say that sir, I am having a lot of pressure. So x will say that I will take one pressure, but you need to take the conjugate with yourself. And this would be equal to what? X of n convolution of x of n convolution with y conjugate minus n, right? And in the end, n will be replaced with k. Is that clear to you? Now cross correlation of yn with xn, y with x. Again limit will be going from minus infinity to infinity. What this will say? Yn will say I am the first, all the pressure on x. X will start crying and x will say that you take the pressure, y will take the pressure, and this will be as it is. So all these things you can do on your own, right? I should not be, I don't think I need to be there. Like you can do it on your own. Y of n convolution with x conjugate minus n, right? So all this expression you can write down on your own. So x of n, and the other guy is taking the pressure, right? Or it could be written as right, x of n convolution with x conjugate minus n, where n is replaced with k. Well and good. Okay. Now the same thing will be happening with circular convolution as well. Like not circular, yeah. Same thing will be happening with circular convolution as well. But what will change? Let's copy the same for circular. What I am doing, I am just copying this slide. Just a second. Yeah. So the slide is copied. Circular cross correlation of n point x of n with n point phi of n. This is what we are doing. N point. Both are n point. Circular cross correlation of n point, and this is also n point. N point. All good? All fine? So what will happen? The limit will go from 0 to n minus 1. 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 Here also the things will change. What will change here? That you guys already know. 0 to n minus 1. 0 to n minus 1. But what will change here? Mode. Mode n would come, right? N minus k mode of n. Why mode of n? Because here negative things may come, right? Negative things may come, so mode should be there. And here y conjugate n is there, no issue with this one, but here mode should come. You understand the meaning of mode, right? Whenever you do anything with the periodic one, like whenever you define n point x of n, n point y of n, that means it would have come from a periodic x of n, periodic y of n. So if they are coming from that, and here if you write down n plus k, then it could go beyond the n point. It can be n plus 1, it can be n plus 2 as well, or it can be minus n plus 1 as well. So if it is going beyond the limit, that's why you need to use the mode. And here what you will use? You will use the circular convolution. Circular convolution. But we will be using the mode. Along with that, we will be changing the limit as well. Changing the limit, using the mode, changing the limit. Limit goes from 0 to n minus 1. Here, mode n. Limit goes from 0 to n minus 1. Here, mode n. This is y n plus k mode n. X conjugate n minus k mode n. Y conjugate n minus k mode n. X of n plus k mode n. Right? And they are the circular convolution. All good? All fine? Here also mode n. Here also mode n. Right? Limit goes from 0 to n minus 1. All good? All fine? You understood the definition? Ditto same definition is there. Just the limit will be changing, and circular convolution you will do. Along with that, mode of n will also come into action. And what if x of n and y of n are periodic? What if x of n and y n are periodic? If they are periodic, that means this mode is not required. Right? All good? All fine? Like if you know the linear one, linear cross correlation, linear cross correlation, linear autocorrelation. If you know the linear, then you can define cross correlation, then you can define the circular cross correlation as well. All good? Okay, this slide is already covered. So detailed and deep discussion on correlation will be done in communication system. From signal system point of view, the discussion is enough. Okay. So if this question is from signal system, which was asked in instrumentation question paper, so how would you solve it? What they are asking? H of t denotes, what it denotes? Cross correlation between FT and GT. Cross correlation between FT and GT. G of minus t, sorry. So how will I define HT? I can define it with respect to convolution. So first one as it is, second one got the conjugate and then inverted. So if this was GT, this would become G of minus t. Inverted and conjugate. Are you able to understand this point? What really happened here? FT as it is, second one. What was happening with the second one? Second one was conjugate and then inverted. Conjugate and then inverted. We used to replace t with tau, but final answer is in the term of t only. So we don't need to replace it. So what would be your h of omega? It's Fourier transform. H of omega will be equals to multiplication will be resulting in convolution, right? But before that, you can, sorry, this was convolution. Convolution will be resulting in multiplication. But before that, you can see one thing, that they are the real valued sequence. What they are? Real valued signal. So if they are real valued signal, then G of, since GT is real, if GT is real, then GT would be equals to G conjugate T. That means what is your HT coming out to be? HT is actually coming out to be FT convolution with GT. That means it is equals to F of omega, or you can write down H of, in place of omega you can put j omega as well, I told you. So H of j omega is coming out to be F of j omega dot G of j omega. Okay, and you see the previous year solution, like answers on YouTube, they have given, all have given different answers, whatever they were doing. Like, but in our channel, on the next day only, we gave this answer only. So this was correct. Okay, F of j omega into G of j omega. Cross correlation FT and G, FT and G of minus t. Previously we were doing xt and yt, xn and yn, but now this thing is that it is already negative. So if it is already negative, what you will do? Conjugate and then inverted, conjugate inverted. And since this is real, so this will become GT. So F of j omega, G of j omega. There you go. Now, x of n is a real valued periodic sequence with period n. N point DFT is defined as x of k. Now, y of n is given in this term, then you need to define the DFT of y of n. That means this I am calling as y of k. This I am calling as y of k. So you need to define y of k in terms of x of k. What do you think? What is this? If I talk about this particular thing, have you seen something like this? So 0 to n minus 1, x of r plus n. Something like this somewhere have you seen? Yes. That if x of n is convolved with x of n, sorry, not convolved, really sorry, cross correlation function of x of n with x of n. How it is given? Sir, summation. Now I am saying that this is periodic, this is also periodic. So if it is periodic, then what will happen? The limit will go from 0 to n minus 1 only. The limit will go from 0 to n minus 1, right? Along with that, mode will also not come. That this mode and thing will also not come. So what I will say, the first one as it is, second one said that, what second one said? Second one will be conjugated. Along with that, it will be shifted as well. This was the definition, and limit will go from 0 to n minus 1. Is that clear to you? Then there was another definition. What was another definition? That, sir, I am having a lot of pressure. So you take the shift. Shift I am treating as R this time. Okay. Shift I am treating this as R. And sir, I will just take the conjugate. But what they are saying? Again, very important thing. Real valued. That means, since it is real valued, so x of n is equals to x conjugate n. So what you are getting? Summation n goes from 0 to n minus 1 x of n plus r x of n. And if you do this particular thing, your final answer will be in terms of r, right? Here you are putting the limit of n. So final answer will be there in terms of r. So this I am calling as z of r. This would be your z of r. Are you able to understand? Cross correlation of x of n with x of n. What I am doing? Cross correlation of x of n with x of n in terms of r. This is what I have calculated. X of n with x of n, it is not cross correlation, it is auto correlation. So auto correlation of x of n with x of n in terms of r. We were calculating it in terms of k, but here we can calculate in terms of r as well. So what we used to do, first one as it is, second one will get the shift, along with that it will get the conjugate. So here there is no meaning of conjugate. Why there is no meaning of conjugate? Because they are real. Then he was saying that I am having a lot of pressure, so this shift is given to this guy in the positive sense. So this is what you are getting. But in terms of r you are getting it. If I need to write down in terms of n, then can I write down? What is this? This is cross correlation. Are you able to understand this point? That this was cross correlation. This particular thing was cross correlation. Are you able to understand this particular thing? And they are given periodic sequence. That means this mode of n will not come. Right? Mode of n will not come since they are given periodic sequence. So what you are able to understand here, that my z of r came out to be summation n goes from 0 to n minus 1 x of n plus r x of n. Now I need it in terms of n, because this particular function is given in terms of n, right? And here you are putting the limit of n. I need to put the limit of r. That means n is replaced with r is replaced with n. So what I will get? Z of n is given as n equals to 0 to n minus 1 x of r plus n, or let's just do it x of, in place of n you put r, and in place of r you put n, in place of n you put r, and here also in place of n you put r. R goes from 0 to n minus 1. Isn't it the same which was given? R goes from 0 to n minus 1 x of r x of n plus r. This was given only. This particular thing was given. You notice this particular thing, x of r x of n plus r 0 to n minus 1. So what was actually given? Cross correlation of x with x in terms of n. And what this would be equals to? X of n convolution with x conjugate minus n. So what was your y of n actually? Your y of n was 1 by n outside x of n convolution with x conjugate minus n. This was your y of n. Did you understand this point or not? A very good point, a very good decision. This kind of thing was there. I kind of thought that it could be related to cross correlation. Why I thought in this manner? Because positive shift is there, something, this kind of thing we have studied in cross correlation only. Since x of n and x of n is there, that means it is auto correlation. So it is something related with correlation. So I wrote down the formula of correlation. First one x of n came, other one shifted with the conjugate. There is no meaning of conjugate because they are real. Now other one was negatively shifted, so I can make it positively shifted as well, right? Since they are periodic, so there is no meaning of mode of n, so this mode of n will also not come into action. Are you able to understand this point? But they are periodic. Here what did I write down? Convolution, which is wrong. It would be circular convolution, right? Because they are periodic, so circular convolution will come into action. Are you able to understand this point? So this was the thing, that this was there in terms of n. This particular thing was there in terms of n, but I got it in terms of r, so I needed to make it in terms of n, right? And I know one thing, that what is this? This is actually equals to x of n circular convolution with x of minus n conjugate, right? But n should be replaced with r. This is what we do. But if I need the final answer in terms of n only, then I will not replace n with r. I will not replace n with r. I will keep n as it is, because I need the final answer in terms of n. Is that clear to you? What you are getting? y of k. 1 by n is a constant. Convolution in time domain will result in multiplication in frequency domain. So x of k multiply with x conjugate plus k, right? Because if x of n is having a discrete Fourier transform of x of k, then x of x conjugate n will have discrete Fourier transform of x conjugate n will have discrete Fourier transform of x conjugate minus k. And here if you use the negative sign, here if I use the negative sign, so here also it will become negative. So this is what you are getting. What you are getting now, 1 by n mod of x of k whole square. This is equals to yk. There you go. A very good question, which was asked in GATE EC. A very good question, and you can see the solution everywhere. You will find it very complex. So this is the best possible solution of this particular question. So for this particular question only, I taught you cross correlation in this chapter. Otherwise, I would have taught in communication system only. But in this particular chapter, I taught you cross correlation just because of this question, and because of this question as well, because it was asked last year only. This came in 2025. So did you understand the meaning of cross correlation? When you calculate the cross correlation, you never actually calculate the cross correlation, you actually calculate the convolution only. So what is the convolution thing? In the convolution, first one as it is, other one conjugated and then shifted. But remembering the definition is also important because of these kind of questions. If you don't even remember the definition, and if they have written this expression, you will never be able to understand that they are actually talking about cross correlation. Are you able to understand this point? What I am saying, if you don't remember the definition, then you will not be able to understand that they are talking about cross correlation. You will think what they are talking about. So you got to know that yes, they are talking about cross correlation. So this was your x of n cross correlation with, autocorrelation with x of n only. So x of n autocorrelation with x of n. How did we get this expression? We wrote down this expression. We got to know that yes, it is coming out to be in terms of r, but we need in terms of z. So in place of r we put z. Okay, in place of r we put z. In place of r we put n, and in place of n we put r. So this was the expression we were getting. If this is the expression, then if this is the expression we are getting, then this is how we can replace it. So basically, this was your autocorrelation of x of n with x of n in terms of n. So this was the scene. And if you know these things, that means convolution in time domain. Convolution in time domain will be resulting in multiplication in frequency domain. So multiplication in frequency domain 1 by n is already there. So this is the answer. Mod of x of k whole square divided by n. Well and good. So this is the end of your DFT. Okay. DFT has ended, and the next video will be the last video. In the next video, we are going to study about what we are going to study. We are going to study some miscellaneous concept. We are going to study about phase delay and group delay. A very simple concept which you already know. So distortion in LTI system we are going to discuss, a very simple point that you already know, and then we will start studying about FFT. What we will study about? A lot of question we will solve, and then we will study about FFT, which is only there in the syllabus of instrumentation. Okay, it is not in the syllabus of EC, it is not there in the syllabus of electrical as well. It has been removed from there. So 2 points we are going to discuss in the next video. Okay then, yeah. Thank you very much. Let's meet in the next video where we discuss about distortion, phase delay and group delay. Thank you. Yeah, hi everyone. So welcome to the final lecture of signals and system. So this will be the final lecture. It's been roughly around 130 hours since you have been seeing my face. So if you have come to the end, that means you have been doing pretty good. Okay, so this would be the final video of signals and systems. So this topic we need to see because it has been mentioned in your syllabus. So they have mentioned phase delay and time delay. So we will understand about phase delay and time delay, but first let's understand the meaning of distortion. Have you heard this word distortion? Distortion means, let's just say I design a system. I design some particular system. Okay, and I apply some input x of t, and what I will get? I will get some output. Let's just say the shape of this signal was something like this. If I don't get the same kind of shape in the output, if I don't get the same kind of shape, that means there is distortion. Okay, like basically I am saying something in this amplifier. This is a system only, no? So in this system I am saying something. But what if you heard some noise or something different? Like whatever that I am saying, that has been amplified. That has been amplified by a particular factor, and that you are hearing. So I am fine with that. If it is being amplified, let's just say if it is being amplified, then I am fine. But the shape should not change. the shape should be as it is. If it is sinusoid, that means it would be sinusoid only. If it is square, it should be square only. So this is the meaning of distortion. If this is happening, that shape is not changing, that means it is distortion less. And if shape is changing, that means it is having some distortion. Okay, so two kind of distortions are there: magnitude distortion and phase distortion. Okay, magnitude distortion and phase distortion. So magnitude means system will provide unequal magnitude or unequal amount of amplification to the different frequency component present in the signal. What do you mean by that? Unequal amount of amplification to the different frequency components. So let's understand it by an example. So let's just say there is a LTI system. At the input of the LTI system, I have applied this particular signal, cos f1t plus cos f2t. So this particular input is having a frequency component of f1 and it is having a frequency component of f2. So signal related to frequency component of f1 is getting a gain of 3 and the signal related to frequency component of f2 is getting a gain of 4. f1 is getting a gain of 3, f2 is getting a gain of 4. So they are getting unequal amount of gain, right? Unequal amount of gain, or you can say amplification. So one is being amplified with 3, one is being amplified with 4. That means there is magnitude distortion present. Magnitude distortion is there. Okay, this I'm gonna write down as managing director, magnitude distortion. PD, physical design, phase distortion. Okay, this is phase distortion and this is magnitude distortion. Now what about phase distortion? So here what is the word? Phase. But it has nothing to do with the phase, it has something to do with the time delay. Again, very important. What is the name? Name is phase distortion. What is the name? Name is phase distortion. But it has something to do with the time delay. What do you mean by that? You applied this particular input. Now this particular component cos 2 pi f1t is getting a time delay of 2. And this is also getting a time delay of 2. Right? The first component, this particular component is getting a time delay of 2 seconds. And this is also getting a time delay of 2 seconds. That means both f1 and f2 are getting the same time delay. That means there is no phase distortion. But in this particular question, what do you see? Again the same input is there. In this particular system, again the same input is there. But f1 component is getting a delay of 2, but it is getting a delay of 3. This is getting a delay of 2, this is getting a delay of 3. So yes, there is phase distortion. But there is no magnitude distortion. Why is that so? Because cos 2 pi f1t is also getting a gain of 3 and cos 2 pi f2t is also getting a gain of 3. So different frequency components are getting the same gain, but they are getting that different shift. So if they are getting the different shift, that means phase distortion would be there, and if they are getting the same gain, that means magnitude distortion is not there. Is that okay for you? Okay. So phase distortion is having the word phase, but it has something to do with the time delay. So if system is providing you unequal amount of time delays to the different frequency components present in the given signal, then you will have the phase distortion. So it has something to do with the phase, not with the, it has something to do with the time delay, not with the phase. Okay, a very important thing. What about this third example? So here you are having this frequency component and another frequency component is pi by 6. So two frequency components are having. So this particular cos pi by 3t, cos pi by 3t is being amplified by a factor of 2. From 2 you have become 4. That means it is being amplified by a factor of 2. And what about this one? Sin pi by 60. From 3 sin pi by 60 it has become 4 sin pi by 60. That means it has been multiplied by a factor of 4 by 3. So 2 cos pi by 3t is getting a gain of 2, but 3 sin pi by 60 is getting a gain of 4 by 3. That means different gains are there. What does that mean? That means there is magnitude distortion present. Different amplification are there, not phase, different amplification are there, different magnitude are there, right? This is getting a gain of 2, other one is getting a gain of 4 by 3. So magnitude distortion is present. Here what do you see? This was cos pi by 3t. So here you are getting a phase of pi by 3 and here also you are getting a phase of pi by 3. So what do you feel like? That phase distortion is not present? No. If you say that, sir, phase are same. Basically this is also phase shifted by pi by 3. This is also phase shifted by pi by 3 and this is also phase shifted by pi by 3. Here what was the phase? 0 degree. Here what was the phase? 0 degree. But now what is the phase? Pi by 3 and pi by 3. So what you will feel? That phase distortion is not there. Absolutely wrong. Because what did I tell you? That phase distortion has something to do with the time delay. It has nothing to do with the phase. So what is the time delay here? In place of t, you have put t plus 1. If I take pi by 3 t, pi by 3 common, because here what was there? 2 cos pi by 3 t. So what I have done, I have taken pi by 3 common. So if I take pi by 3 common, that means t has been replaced with t plus 1. T has been replaced with t plus 1. So it is getting a shift of 1. And what about this one? This is getting a shift of t has been replaced with t plus 2. So this is getting a shift of 1. Cos component is getting a shift of 1 and sine component is getting a shift of 2. That means yes, phase distortion is also present. So for finding out the phase distortion, you will never look at only the phase. You need to look at the shift. Okay. And for checking the magnitude distortion, you need to see at the gain. So here 2 was there, here 4 was there. That means it was getting a gain of 2. Here 3 was there, here 4 was there. That means it was getting a gain of 4 by 3. So gain of 2, gain of 4 by 3, different gains. That means magnitude distortion is also present and phase distortion is also present. What about this particular example? What really happened here? From 2 to 4 you are going. What does that mean? This pi by 3 component, it is getting a gain from 2 to 4. That means it is being multiplied with 2. And this is getting a gain from 3 to 6. That means it is also being multiplied with the 2. So same gain both of the components are getting. That means pi by 3 component and pi by 6 component, both of the components are getting the same gain. If they are getting the same gain, what does that mean? That means there is no magnitude distortion. What about the phase distortion? Both are having the different phase, sir. That means there is phase distortion. No. For phase distortion, what we need to do? We need to care about the time shift. We need to care about the, here pi by 6 was there, no? So t minus 2. So here also it is getting a shift of 2. Here also it is getting a shift of 2 only. So that means phase distortion is also not present. So can I write it down? Can I write down my yt as something like this? That sir, I can take 2 common, 2 cos pi by 3t minus 2 pi by 3 plus, or let's write down in a better manner. So 2 cos pi by 3 t minus 2 plus 3 sin pi by 6 t minus 2, right? So what you are getting? 2. If this was your xt, can I write it down as x of t minus 2? So what is your yt? 2x of t minus 2. So if there is a distortion-less system, what is the meaning of distortion-less system? That means there should not be any magnitude distortion and there should not be any phase distortion as well. So what is the meaning of distortion-less system? That means there should not be any magnitude distortion, there should not be any phase distortion. That means every component of xt, every frequency component of xt should be getting a gain of a. That means should be getting the same gain, and every component of xt should be getting the same shift as well. Every component of xt will be getting the same gain and they will be getting the same shift as well. Here two are equal, but a and t naught could be unequal as well, right? Shift should be same and gain should be same. This is the criteria. So for a distortionless LTI system, yt would be given as axt minus t naught. So can I find out its transfer function? What I am finding out? Transfer function for distortionless LTI system. My yt is given as x of yt is given as a into x of t minus t naught. So my y of omega will be given as e to the power minus j omega t naught x of omega. So my h of omega is given as, because h of omega is y of omega divided by x of omega. This is known as transfer function, and that is given as e to the power minus j omega t naught. So what will be your mode of h of omega? That would be equals to a. And what will be your angle of h of omega? Angle of h of, why I am writing down e to the power j omega? If we are talking about a continuous time function, then why do you write down e to the power j omega, right? Yeah. So what is the angle of h of omega? This is the magnitude. And what is the angle? This is the angle. So angle is omega minus omega t naught. Minus omega t naught. क्या कर रहा हूँ भाई? Minus omega t naught. Do you know one thing, right? This is the magnitude and angle is written as e to the power j angle of h of omega. So if you compare, mode of h of omega is a and angle of h of omega is minus omega t naught. So these are the two things that we are getting. Now this is your mode of h of omega. So mode of h of omega is a. Here I should write down mode of a actually, because a could be negative as well, no? So mode of a I am writing down. Are you able to understand this point? If a is negative, let's just say the gain is minus 3. Still the magnitude will always be positive, no? So here I should write down mode of a. So this value will be your mode of a. And what about the angle? Angle versus omega. What about the angle versus omega? It is minus omega t naught. That means it will be passing through the origin, but slope could be positive or negative, anything. Here it feels like that the slope is negative. Basically, h of omega is equals to minus t naught into omega. So y equals to mx plus c. So from here what do you see? Value of c is equals to 0, value of m is equals to minus t naught. So you feel like that the slope is minus t naught. Slope is equals to minus t naught. But what if the value of t naught is negative? If value of t naught is negative, let's just say t naught is minus 2. So slope will become positive, no? So it could be positive as well, it could be negative as well. I am considering t naught is positive. Okay? But slope could be positive, negative, anything. But it will be a straight line passing through the origin. Straight line passing through the origin. So for a distortion-less LTI system, what is the gain of your transfer function and what is the angle of your transfer function and what all are the graph? Will you be able to make it within 50 seconds? So all this process could be done within 50 seconds. We have discussed for roughly around 15 minutes, but the conclusion is of 1 minute only. What is the conclusion? Started with this magnitude distortion, phase distortion. Phase distortion means there will be different time delays. Magnitude distortion means different frequency component will have different amplification, right? Very simple thing. Then we go to know that for a distortionless LTI system, all the component will get the same shift, all the component will get the same phase. So yt could be written as ax t minus t naught. So you can calculate the transfer function very easily, a e to the power minus j omega t naught. You can calculate the phase, you can calculate the magnitude, you can calculate the phase as well, and then you can draw the graph. So this would be the graph for distortionless LTI systems. Transfer function of distortionless LTI system, magnitude spectrum and the phase spectrum. Okay. Now there are two terms, very important terms. If question is coming, then it will come from here. So terms are phase delay and group delay. So what do you mean by that? So forget about the definition. Let's just understand. So this is the LTI system. At the input of the LTI system, I am applying sin t. So sin t will have only one frequency component. No? Sin t will have only one frequency component, that is omega naught equals to 1. It is having only one frequency component. Only one frequency component it is having. That is omega naught. What is its Fourier transform? This is its Fourier transform. So it is having, just one second guys. So it is having only one frequency component, which is omega naught. So one frequency component, if one frequency component is getting some delay, so that is known as phase delay. So this will be known as phase delay. Okay, phase delay. At the input, if one frequency component is getting some delay, so that is known as phase delay. So basically for one frequency component, we define the delay as phase delay. Okay, and let's just say if at the input you apply the square wave. At the input what you are applying? You are applying the square wave. In the square wave, you know that what all components should be there? F naught, 3f naught, 5f naught and so on. So a lot of frequencies are there, a group of frequencies are there. And what if I say that my output yt is x of t minus 2? That means the whole waveform has been shifted. That means all the frequency component has been shifted. So f naught, 3f naught, 5f naught, these groups of frequency have got the same amount of delay. That means this is known as group delay. Are you able to understand this point? group delay. So phase delay, group delay means the delay experienced by one frequency component, that means it is phase delay. Group delay means the delay experienced by a group of frequencies. So there was an LTI system. If I apply at the input, if I apply only one frequency component and that frequency component is being delayed, that means that is the phase delay. That means only F0 frequency is getting a delay of 2 seconds. But here F0, 3 F0, 5 F0, all the group of frequency is getting the same kind of delay. Is that clear to you? So there are two formula. The phase delay is defined as minus h of omega divided by omega, and group delay is defined as d angle of h of omega divided by d omega and then negative sign. Those who have studied EMFT, they would know there was something called phase velocity, Vp equals to omega by beta, and there was something called group velocity, d omega by d beta. So whenever this group word comes, you always have to differentiate. Okay, always you have to differentiate. And how will you remember? They are the unit of time, right? They are the unit of time. Time unit is there, right? So whenever you write down this angle, whenever I wrote down this angle of h of omega, what that was coming out to be? Minus omega t naught. Just a way to remember, I am telling. Minus omega t naught. When I wrote down the angle, what I will remember, sir, yt is equals to x of t minus t naught. X of t minus t naught. So e to the power minus j omega t naught. So sir, angle of h of omega is minus omega t naught. So if I need to write down the something related to time, so that should come out to be angle of h of omega divided by omega minus sign. So this is my phase delay, and if I need to write down the group delay, that means I will differentiate it. D by d I need to put. So d angle of h of omega divided by d omega. Just a way to remember, I am telling. So group delay and phase delay are having the unit of second. What is the unit? Unit is seconds. What is the unit? Unit is seconds. So they are having the unit of second. What does that mean? Angle upon frequency, right? Angle is equals to omega t naught. So you need the unit of t naught. That means angle divided by omega. Angle divided by omega. And similar thing in the discrete time could be written as h e to the power j omega divided by omega, and dy minus d by d omega angle h e to the power j omega. Say yes or no? Right? Okay. For a distortionless LTI system providing a shift of t naught, what is the angle of h of omega? What is the angle of h of omega? That was coming out to be minus omega t naught. Can this there be in your mind? Even if it is not there in your mind, within seconds you can derive it. E to the power minus j omega t naught. So this is the angle minus omega t naught. If I calculate the phase delay, what is the formula of phase delay? Formula of phase delay is, again I have written e to the power j omega. That means I am already considering it in the discrete time. So we are seeing it with respect to continuous time. The ditto same analysis will go for the discrete time as well. So what is the formula of phase delay? Angle of h of omega divided by omega, then there is a negative sign. So what is angle of h of omega? Minus omega t naught divided by angle of h of omega is minus omega t naught, then there is another negative sign. So this will become plus. So what is the answer you are getting? T naught. What is the answer you are getting? T naught. And here what we need to do? D of d omega angle of h of omega, and then there is a negative sign. So minus d of d omega minus omega t naught. So t naught comes outward, negative will become plus. So here what you are getting? T naught. So what did you understand here? For distortionless LTI system, group delay is equals, phase delay is equals to group delay is equals to T naught. So in 1 mark, this can be asked. For distortionless LTI system, group delay and phase delay are equal. Okay. For distortionless LTI system, group delay and phase delay are equal. This you need to remember. It can be asked. And it is pretty obvious, no? Distortionless LTI system. Distortionless LTI system, that means all the frequency components should be getting the same kind of shift. So if there is one frequency component, or if there are a lot of frequency component, all should be getting the same kind of shift, and it is a LTI system as well. And what is the meaning of LTI system? The meaning of LTI system is that whatever the shift you will do in the input, the same shift will be reflected in the output as well. This is the meaning of LTI system, no? So yes, phase delay and group delay has to be the same, right? So in 1 mark, statement wise, this can be asked. So you understood the meaning of phase delay, you understood the meaning of group delay as well, right? let's see the questions. So there are 3 questions. All are based on discrete time. Okay, so analysis we have done with respect to continuous time. The ditto same analysis will go for discrete time only. So analysis will be based on, and the questions will be based on discrete time now. So try doing this one. H of n is real. This angle is given, that angle is given, these things are given. If x of n is this, you need to find y of n. Basically, you need to find y of n. I need to find y of n. Sinusoid. What is the applied input? Sinusoid. So if applied input is sinusoid, do you remember something? If your applied input is sinusoid, then you can directly write down the output. Do you remember this particular thing? If this is having h e to the power j omega and applied input is 3 sine 9 pi by 2n, 9 pi by 2n it is. Look guys, I can make it better, right? 9 pi by 2n, 9 pi by 2n. What I can write down? 4n pi plus n pi by 2, right? 4.5 I can write it down. So let's write down n pi by 2, right? N pi by 2 plus pi by 6. This was pretty obvious, no? 9 pi by 2. Why would you calculate in terms of 9 pi by 2? Doesn't make any sense. So this is how I can reduce it, right? Now what is the answer you will be getting? 3 angle h e to the power j omega. In place of omega, what you need to put? Pi by 2. Sine. Do you remember this thing? Magnitude will be multiplied with h e to the power j omega, and in place of omega, you need to put this particular thing. In place of omega, you need to put omega naught value, which is pi by 2. Sine n pi by 2 plus pi by 6 plus angle of h e to the power j omega. In place of omega, you need to put pi by 2. There you go. This is the answer. Are you having this particular thing? Surely you are having this particular thing, but you are not having this particular thing, right? You have the value 2 here, but you don't have this value. So this value you need to calculate. You are given the group delay. What you are given? You are given group delay. What is group delay? Tg omega. That is equals to d by d omega h e to the power j omega minus sign, and that is equals to 2. At pi by 2, that is equals to 2. So that is equals to 2 at pi by 2. At pi by 2. Okay. So first let's calculate at pi by 2 equals to 2. Doesn't make any sense, right? Group delay at a particular frequency you are giving. Doesn't make any sense. No. Group delay at pi by 2. I think there is something wrong with the question. This is wrong. Group delay at omega. This is the value of group delay. That is equals to 2. What I had written first? Group delay at pi by 2 equals to 2. So from here, how can I use this information then? I will not be able to use this information, no? Doesn't make any sense. This should be equals to omega only. Value of group delay is 2. Value of group delay is 2. So step by step I need to go, and if I go step by step, I will get my answer. So what you are getting? Angle of h e to the power j omega is coming out to be integration of 2 d omega, and negative sign is there, right? So what you will get? Angle of h e to the power j omega would be 2 omega minus 2 omega plus a constant. Basically this goes here, you need to do the integration. So if I integrate here, angle of h e to the power j omega, I will get here minus 2 omega plus constant. Now in place of omega, if I put 0, in place of omega, if I put 0, in place of omega, if I put 0, what you are getting? So don't forget this c, okay? That is very important. So in place of omega, if I am putting 0, what I am getting? 0 plus c, and that is equals to pi by 2. This is equals to pi by 2, right? 0 plus c is equals to pi by 2. So value of c is coming out to be pi by 2. Value of c is coming out to be pi by 2. So angle of h e to the power j omega is coming out to be minus 2 omega plus pi by 2. There you go. What we required angle h e to the power j omega. Then I got to know that something I can do with the group delay, because group delay definition I already know. From there I got the value of h e to the power j omega, but important part is constant would come. So this is what I have got, and now I need to calculate the angle at pi by 2. I need to calculate the angle at omega equals to pi by 2. So minus 2 omega equals to pi by 2 plus pi by 2. So minus pi plus pi by 2, that is equals to minus pi by 2. So what is your y of n? Y of n is coming out to be 3, not 3, and the magnitude is 2. So 3 into 2 sine n pi by 2 plus pi by 6 minus pi by 2, right? So what you are getting, y of n as 6 sine n pi by 2 minus pi by 3, right? Yeah, that's the answer. Okay, very simple. We started with this one, 3 into 2 sine 9 pi by 2n. So actually it would become pi by 2n plus pi by 6, and then angle of h to the power j omega was required. For calculating the angle, this calculation we did. We got to know that value of c is equals to pi by 2, because at 0 you are getting the angle of pi by 2. So that value you got, that is pi by 2. So minus 2 omega plus pi by 2. At which frequency you need to calculate? At pi by 2 frequency you need to calculate. So from here you got to know that it is minus pi plus pi by 2. So it is minus pi by 2. So minus pi by 2 you put here, and this is the final answer you are getting. Well and good, very simple. Let's go to the next one. H of n is there, you need to find the group delay. What you need to find? You need to find the group delay. So what is the definition of group delay? Minus d by d omega angle of h e to the power j omega. So always the only task is that you need to find angle of h e to the power j omega. Angle of h e to the power j omega. This is what you need to find. So if I want to find the angle, what I would do? Method 1. I would calculate h e to the power j omega. This is what I feel like, that let's calculate h e to the power j omega. From here I can get the angle and I can get the magnitude as well. So I tried calculating it. What I will get? 4 plus 5 e to the power minus j omega plus 6 e to the power minus j 2 omega plus 5 e to the power minus j 3 omega plus 4 e to the power minus j 4 omega. Now how do I get the angle out of it? Some symmetry I could see here. What I could see? Look, this 4 4, this 5 5, and this 6 alone, they could do something. They could do something out of it. If I take e to the power minus j 2 omega outside, how it will click to me? Look, you see these two things. 4 into 1 plus e to the power minus j omega minus j 4 omega. I always told you, if you get the form of e to the power j theta, what you need to do? You take the half out of it outside. So what you will get? Something you can make out of it, right? So here what I will take? I will take half of it outside. That means 4 e to the power minus j 2 omega. So what I will get? E to the power j 2 omega plus e to the power j 2 omega. So here as well I got the half out of it, and here also what I will do? In this one, let's see, 5 e to the power minus j omega 1 plus e to the power minus j 2 omega. Are you able to understand this point? These two I have picked. So what I will do? I will take half of it outside. So 5 e to the power minus j omega, e to the power minus j omega. So e to the power j omega plus e to the power minus j omega. Again something I can make out of it. So basically what is coming outside? E to the power minus j 2 omega, no? Are you able to understand this point? So let's write down that how did it click to me? How did it click to me that what I need to do? This is the method 1 we are seeing. That's 4 plus 4 e to the power minus j 4 omega plus 5 e to the power minus j omega plus 5 e to the power minus j 3 omega plus 6 e to the power minus j 2 omega. This is what clicked to me, sir. And then I thought that From here, if I take out these two negative signs, that means e to the power j 2 omega I will be left with, and here e to the power minus j 2 omega I will be left with, divided by 2 multiplied with 2. Plus 5 e to the power minus j omega 1 plus, no, I will take out 5 e to the power minus j 2 omega. So here I will be left with e to the power j omega plus e to the power minus j omega divided by 2 multiplied with 2, and in the end I am left with 6 e to the power minus j 2 omega. So what you are getting? 8, 4 into 2, 8. What is this? Cos 2 omega e to the power minus j 2 omega plus 5 into 2, 10. What is this? Cos omega e to the power minus j 2 omega plus 6 e to the power minus j 2 omega. So what you get? What you can take outside? E to the power minus j 2 omega you can take outside. 8 cos 2 omega plus 10 plus 10 cos omega plus 6. Now you can see that from here I can get the magnitude, but this is my angle, right? You got the angle. Angle of h e to the power j omega is coming out to be minus 2 omega, and that you can put here. So minus d by d omega minus 2 omega. So answer you are getting as 2. What is the answer you are getting? 2. So this was actually tough to think. This was actually tough to think. But how did I think that I should think in this direction? What I am saying, how did I think that I should think in this direction? I thought because this could be even. 4, 5, 6, 5, 4. Something clicking to you. If I do h of n plus 2, what if I do h of n plus 2? This is your h of n, which is equals to 4, 5, 6, 4, 5, 6, 5, 4. 4, 5, 6, 5, 4. And here is the arrow. If I make h of n plus 2, what I will get? 4, 5, 6, 5, 4. I am calling this as y of n. So what did you get to know? 5, 5, 4, 4. That means y of n is even. What is y of n? Y of n is even. Right? Well and good. So for even we directly remember the relation or forget about the relation. If you don't even remember the relation, what you can do, or like we have spent enough time, so you should be remembering the relation. What is the relation? That angle of positive frequency minus the angle at negative frequency will be equals to 2n pi, odd multiple of, sorry, even multiple of pi, right? Now y e to the power j omega is equals to what it is equals to? It is equals to h e to the power j omega e to the power j 2 omega. We agree to this point? Y e to the power j omega is equals to h e to the power j omega e to the power j 2 omega. Well and good. Okay. Now can I write down angle of y e to the power j omega would be equals to 2 omega plus angle of h e to the power j omega. Did you understand this point? What I mean to say is that this can be written as magnitude of y of omega e to the power j angle of y of e to the power j omega. We agree to this point? This side you are agreeing? Magnitude and angle. Here what do you see? Magnitude and angle. So angle if I compare y e to the power j omega, if I compare the angle y e to the power j omega is coming out to be angle h e to the power j omega plus 2 omega. So this is what we are getting, right? So from here I can put the values, Angle at positive frequency, angle at negative frequency will be equal to 2n pi. So what will be the value here? That in place of omega you put minus omega. So in place of omega you put minus omega, right? This is actually getting bigger. Needlessly it is getting bigger, right? Needlessly. Along with that, this is real as well, no? Y of n is even. Along with that, it is real as well, right? Are you able to understand this point? H of n is real, right? H of n is real. If you made a shift, that means it will be real as well. So your y of n is even plus real. So what would be your y e to the power j omega? Who is the deciding guy? Even is the deciding guy. Even will say that whatever that is there, that will come as it is. So it would also be even plus real. And if anything is real, that means its angle has to be, if anything is real, then its angle has to be even multiple of pi. So actually this was not even required. Are you able to understand what I am saying? Did you understand what did I do here? If anything is real, that means this should be the condition. Or how you can calculate? What is the condition for real? The condition for real is this, that it should be equals to even multiple of pi. And what is the condition for real? Condition for even was this. Condition for real was this. It should also be even multiple of pi. So if you add both of them, this and this will get cancelled. Here 2 will come. Here 4 will come. So 2 and 2 will get cancelled. What is the answer you are getting? Angle of y to the power j omega should be equals to even. Even multiple of pi. Are you able to understand this point? Or you can directly think, no, that if your y e to the power j omega is real, if it is real, then the angle has to be even multiple of pi, right? So this was the method 2 actually we are seeing. So this is the answer we are getting. So angle of h e to the power j omega plus 2 omega should be equals to 2n pi. So angle of h e to the power j omega is coming out to be minus 2 omega plus 2n pi. What you need to calculate? Group delay. Group delay means you need to differentiate with the negative sign. So if I differentiate this particular thing, what you will be getting? This is constant, so this will be gone, and differentiation of this will give you 2. So group delay with respect to the frequency, it is coming out to be 2. Is that clear to you? So this was the method 2 and this was the method 1. So if something is even, it may click to you, okay, if I make any shift, something becomes even, then yeah, I can find the phase. So here actually the question was you need to find the phase. Group delay is just simple differentiation. So you needed to find the phase. Okay. Here sir answer was coming minus 2 omega, sir. Here answer is coming minus 2 omega plus 2n pi. It is same only, no? Minus 2 omega plus 2n pi. In angle, if you add 2n pi, does that make any sense? Here also I could have written plus minus 2n pi. Right? So this answer both are same only. Plus minus 2n pi. Anything I could have written. This question, a very good question. A very, very good question. Group delay is given. That is 5 seconds. H e to the power j omega. Mode of h e to the power j omega is given. You need to find what is your h of n. So for h of n, what we need to find? We need to find h of n. So can we get it from h e to the power j omega? Yes. So what do we already know? We already know the phase. What we require? We require the angle. How can we get the angle? Using this particular thing, right? So Tg omega is given as 5. That would be equals to minus d by d omega h e to the power j omega. So angle of h e to the power j omega is coming out to be minus 5 omega plus c. Okay. What is given? H of n is real. What is given? H of n is real. H of n is real. This is given. So for real, what is the condition? That your magnitude spectrum should be even. Is it even? Magnitude spectrum should be even. Yes. First condition is fulfilled. And what is the condition about the angle? Condition about the angle is positive angle plus negative angle should be equals to 2n pi. So what is your positive angle? Minus 5 omega plus c. And what would be the negative angle? Negative angle would be, in place of omega you need to put minus omega. So what you are getting? 5 omega plus c. That should be equals to 2n pi. Minus 5 omega plus c, and here angle of h e to the power minus j omega, that means in place of omega I need to put minus omega, so you are getting 5 omega plus c. So what you are getting? C is equals to n pi. So c is coming out to be n pi. C is actually coming out to be a odd multiple of, sorry, any multiple of pi. Odd, even, it could be any multiple of pi. So interestingly, this is the angle you are getting. Angle is minus 5 omega plus n pi. Any multiple of pi would work. Is that clear to you or not? Is this equation clear to you? So you are having the magnitude. Along with that, you are having the phase as well. Your job is done. Right? Your job is done. This is the answer. So how will you get these answers? How will you match these options? Look, this particular thing is given. Can you draw the graph of this one? Sir, surely I can draw the graph of this one. Sir, the graph would go somewhat like this. Sir, between minus pi by 4 to 4, it is 0. And sir, since this is your frequency spectrum, sir, since this is the discrete time system, for discrete time system, the frequency spectrum or the Fourier transform will be periodic. So it should be periodic. Actually, they have given between minus pi by 4 to pi by 4, otherwise 0. That means they have talked about minus pi to pi window. No, they have talked about 2 pi window. Then in another 2 pi window, it will be same. Another 2 pi window, it will be same. So they are only talking about 2 pi window. So this is how it is repeated. Sorry guys, sorry. Okay. Sin an by pi n it was, no? Sin omega c by pi n. Not sin will not come here. I did the mistake in framing the problem, in framing the options. Sin will not come. Yeah. So this is your angle of, this is your mode of h e to the power j omega between minus pi by 4 to 4 and magnitude is 1. Between minus pi by 4 to 4, magnitude is 1. Right? What is omega? Can I say that magnitude of h e to the power j omega is equals to g e to the power j omega? Can I say it? Let's call it g e to the power j omega. Whatever the magnitude spectrum that you are getting, that I am calling as g e to the power j omega. So what would be your g of n? Your g of n would be sin omega c n, sin a n divided by pi n. Do you agree to this point? Do you agree to this point? That if I call this magnitude spectrum as g e to the power j omega, which is coming from g of n, that means this would have been my g of n. Now just let me know one thing. If I calculate g of, what is the phase I am getting? Minus 5 omega. If I calculate g of n minus 5, So what will be its Fourier transform? That would be g e to the power j omega. If g of n is having g to the power j omega, what I mean to say is that if your g of n is having g e to the power j omega, so g of n minus 5 will have g to the power j omega e to the power j omega naught n. So e to the power j omega n naught value is minus 5 omega n naught. This would be the answer, right? And what is this? What is this? This is your angle e to the power. And what you actually required? What you required? What was our requirement? Our requirement is finding h of n. Our requirement is finding h of n, but h of n is coming from h e to the power j omega. So h e to the power j omega is actually the magnitude and the phase. What is the phase? Plus n pi, right? Now value of n could be 0, value of n could be 1. Are you able to understand this point? This was our actual h e to the power j omega. This was our actual h e to the power j omega. What was our actual h e to the power j omega? Here I am writing down h e to the power j omega was magnitude of h e to the power j omega e to the power j angle. What was the angle? Angle was minus 5 omega plus n pi. Minus 5 omega plus n pi. Now n could be 0, n could be 1. These kind of things are possible. N could be 0 as well, n could be 1 as well. So let me write it down. H e to the power j omega is. If I put n equals to 0, what I will be getting? This particular thing I will be getting. If I put n equals to 1, what I will be getting? J minus 5 omega plus pi. So e to the power j pi will give you minus 1. So basically what you will be getting? Minus sign h e to the power j omega e to the power minus j 5 omega. So this answer is also possible. Basically your h e to the power j omega could be this as well, and h e to the power j omega could be this as well. Both of the answers are possible. What is this particular thing? From where this particular thing will come in action? This would have come from g of n minus 5. So your h of n is, if you take the inverse Fourier transform of this particular thing, you get h of n. If you take the inverse Fourier transform of this particular thing, what you are getting? G of n minus 5. So two answers are possible. If you are taking n equals to 0 and n equals to 1. If you take n equals to 2, again the same thing you will get. If you put n equals to 3, again the same thing you will get. So two answers are coming. Two possible answers are coming. When I am putting n equals to 0, this is the answer is coming. And when I am putting n equals to 1, then this is the answer coming. So both of the answers are possible. Are you able to understand this point? Both of the answers are possible. So what is your h of n is coming out to be? Sine pi by 4 n minus 5 divided by sine n minus 5. Right? All good? And what is your h of n is coming out to be? The similar but with the negative sign. So what all answers are possible? A, B and C. So did you understand what was the process? You needed to find h of n, that means you need h e to the power j omega. For h e to the power j omega, I am already having the magnitude, but I need the phase. For getting the phase, I can use this particular term, which is the group delay. So group delay is given. From there, I got my phase like this. Although I got the C here, but h of n was real, so I could use the condition, and C value is coming out to be n pi, which was the most interesting point here. Because C could be any multiple of pi. Not just odd multiple, not just even multiple, it could be any possible multiple of pi. This was the condition, right? So from here I got to know that my h e to the power j omega is magnitude of h e to the power j omega e to the power minus j omega plus n pi. Okay. Now magnitude of h e to the power j omega, this is something that I have already seen. So what did I call you? What did I call this one? H e to the power j omega, that I called as g e to the power j omega. So my g e to the power j omega, if I am saying that it is coming from g of n, so do I know g of n? Yes, I know g of n, that is sin a n by pi n. Now I noticed one thing, if I make a right shift of 5, that means if I give it a shift of minus 5, then what will happen is that the phase of minus 5 omega will come out. The phase of minus 5 omega will come out, and this is what I wanted. This is what I wanted. So that means g of n minus 5 is giving me h e to the power j omega e to the power minus j 5 omega. I have two possible answers. That my h e to the power j omega could be either mod of h e to the power j omega e to the power minus j 5 omega, or it could be mod of h e to the power j omega e to the power minus j 5 omega, and there is a negative sign. So two possible answers are there. From the first one you will get g of n minus 5, from the second one you will get g of minus of g n minus 5, minus of g n minus 5. So two of the possible answers are there. A very good question, a very thoughtful question. Okay. So yes, this is the end of signals and systems for EC and electrical students. But just stay there for 10 more minutes. Okay. EC and electrical guys, just stay there for 10 more minutes. Now in the PYQs of EC and electrical you can find some questions from FFT, but it is not there in your syllabus as of now. It was previously there, it is not there as of now, it has been completely removed. Okay, but stay there for 5 to 10 minutes, because in some PSU examination in ISRO, BARC, they can ask you questions from FFT, and if you just stay there for next 10 minutes, then you will be able to solve it. In any kind of examination, the question could be coming from FFT. So if you just stay here for next 10 minutes, then you will be able to solve it. Are you able to understand this point? Okay, so just stay here. Everyone will stay here. EC, electrical, instrumentation, everyone will stay. Instrumentation guys will stay till the end, but EC, electrical guys will stay for next 10 more minutes. So what is FFT? FFT is DFT only. What is FFT? FFT is DFT only. But DFT is a slower process. When you calculate a DFT, like you will design a particular device, okay, or you will design a particular algorithm, and you will put x of 0, x of 1, x of 2, x of 3, and then you will ask that particular block. Let's just say I have designed a particular block and I am putting 4.x of n, x of 0, x of 1 until x of 4, then I will ask until x of 3, then I will ask him to calculate DFT. So he will calculate you x of 1, x of 2, x of 3 and x of 0, x of 1, x of 2, x of 3. So it takes more time. So we designed a particular algorithm, and the name of that particular algorithm is fast Fourier transform. So we designed that particular algorithm, and with the help of that algorithm we have made the process faster. So this is FFT. FFT is nothing but it is DFT only, but the faster computation of DFT. So FFT is nothing but faster computation of DFT. Okay. So if someone asks you, calculate 4.FFT of 4.x of n, what you will say? This will be equals to 4.DFT of 4.x of n. There you go. So you can calculate DFT of this particular thing, which was equals to 10 minus 2 minus 2j minus 2 minus 2 plus 2j, as far as I remember. So if someone is asking you to calculate the FFT, that means they are asking you the DFT only. Okay. Now there is this algorithm, there is this FFT algorithm. We need to study about that particular algorithm. But before that, let's solve a question. Let's just say this question is coming in your examination. Sir, you did not teach FFT at all. Sir, you did not even teach the FFT. How you are expecting us to solve the problem? You will be able to solve the problem, believe me. A very simple problem it is. Because I told you FFT is nothing but a DFT only. So how will you use your brain in the examination? Sir, I don't know anything about FFT. 6-point decimation in time, sir, what they are saying, I don't know anything. For a signal flow graph corresponding x of 1, I know this. So from here I am getting the value of capital X of 1. I know this particular thing, right? And what they are saying, W6, that also I know, e to the power minus j 2 pi by n. This also I know. What should be the coefficient of A1, A2, A3 in terms of W6 so that you get X of 1? So in 6-point DFT, can you calculate X of 1? What I mean to say is that, first, can you write down the formula of 6-point DFT? That would be, sir, X of k summation n goes from 0 to 5, X of n e to the power minus j 2 pi by n kn. Sir, what I need to calculate? X of 1. So, sir, it would be going from 0 to 5, X of n e to the power, let's write down this as, because you need the final answer in terms of omega 6. So let's write down this as omega 6. Sir, in place of k I need to put 1. So in place of k I have put 1. So what is the answer you are getting? Sir, x of 0 plus, then I will put, because w6 to the power 0, that would be 1 only, then I will put 1. So x of 1 w6, then I will put 2. So x of 2 w6 to the power 2, then I will put 3, w6 to the power 3, then I will put 4, w6 to the power 4, and then I will put 5, w6 to the power 5. So this is my x of 1. Do you agree to this point? This is your actual x of 1. Let's go to the diagram what they have given. What do you think what is happening in the diagram? This x of 0 is fed with 3 nodes, A1, A2 and A3. And this A1 node is coming from this particular node. This A1, basically A1, what I mean to say is that this particular node is coming from these nodes. This node and this node. And these nodes are coming from different nodes. From these nodes and need nodes. So from node to node you need to solve. Have you seen the signal flow graph? Signal flow graph in your control system. If you have studied it, then you would have seen it. In your whole electronics, whenever I make any kind of diagram like this, that means simply the multiplication. And if there is some node, that means simply it means the addition. Node means addition, and if I have made an arrow like this, that means this is multiplication. If you have studied enough electronics, then you will be able to understand that this means multiplication only, this means multiplication, and this dot means addition. So what is happening at this particular dot? X of 0 is coming and x of 3 is coming, but with the negative sign. This is the potential of this node. What is the potential of this node? X of 1 is coming, x of 4 is coming, but with the negative sign. X of 1 is coming, x of 4 is coming. Look, here addition should be done. X of 0 plus x of minus 3 multiplied with minus 1. So that's why I am writing down negative sign. Actually, what was happening at this node? Let's call this node as A. Okay, this node I am calling as A, this B, and this is C. So what would be my node A in the diagram? In the diagram, my node A would have been x of 0 would come, x of minus 3 would come, x of 0 would come plus, at the node addition should be there. At the node addition should be there, but x of 3 is being multiplied with minus 1. X of 3 is being multiplied with minus 1. So what you are getting? X of 0 minus x of 3. At node B, what will happen? So I don't need to write down all these things. Okay. Now I can directly write down here. So here what will happen? X of 1 minus x of 4. And here what will happen? X of 2 minus x of 5. And then what will happen? They will be multiplied with A3, A2 and A1, and then they will give you the value of x of 1. So let's write down the value of x of 1. So your node A will be multiplied. What is your node A? x0 minus x3 will be multiplied with what? Will be multiplied with A1 plus your node B, this node, x1 minus x4 will be multiplied with A2 plus this node, x2 minus x5, x2 minus x5 will be multiplied with A3. Okay, this is the process that is happening. Can you simplify this particular thing? If I have a page, no, I don't have a page, so I can borrow a page from here. What I am doing is that now this is my x of 1, this is my x of 1. So my target is now to compare these two, compare this with this, because this is your actual x of 1 and this is the x of 1 that you are getting from the diagram. So now you need to compare, that's it, nothing else. So what you can see here, w6 to the power 3, w6 to the power 3, e to the power minus j 2 pi by 6 into 3, what that would be equals to? That would be equals to 6, that would be equals to minus 1. So this is your minus 1, right? And what kind of options are there? W6 to the power 2, W6 to the power 1. So basically we need to convert all these. Now what I need to see, x of 1 and x of 4, x of 1 and x of 4. So this is your W6 to the power 1 and here you are having W6 to the power 4. So W6 to the power 4 can be written as W6 to the power 3 into W6 to the power 1. Why I am doing so? Because x of 1 and x of 4 are coming together here, no? So something I need to do, right? And x of 2 and x of 5 are coming together, so something I need to do. So this is what I am doing. So W6 to the power 4 can be written as W6 to the power 3 into W6 to the power 1. And that can be, this is minus 1. So what you are getting? Minus W6 to the power 1, right? And what about the last? This guy and this guy is coming together. No, sorry. 2 and 5 are coming together. So W6 to the power 5 can be written as W6 to the power 3, W6 to the power 2, and W6 to the power 3 is minus 1. So you are getting W6 to the power 2. So how you can write down your x of 1? X of 1 is this x of 0 as it is. Let me write it down properly. So your x of 1 is x of 0 as it is, and then x of 0 minus x of 3, x of 0 minus x of 3. So x of 0 minus x of 3 you are getting, plus this is your x of 1, this is your x of 4. So x of 4 is being multiplied with W6 to the power 4, that would be equals to W6 to the power minus W6 to the power 1, and here also there is W6 to the power 1. So what you are getting? X of 1, and this is this particular thing. So there will be negative sign common. So minus x to the power minus x4 W6 to the power 1 plus here x of 2, x of 5. So here also minus sign can come common. So x of 2 minus x of 5 is equals to W6 to the power 5. So x of 2 minus x of 5 is equals to W6 to the power 2, not 5, sorry, W6 to the power 2, W6 to the power 2. So what did you get to know? That your A1 is coming out to be 1, A2 is coming out to be W6, and A3 is coming out to be W6 to the power 2. Is that clear to you or not? So where is the answer? 1, 6 and 2. Answer is C. Without even understanding FFT, you are able to solve this particular question. And surely in the examination as well, you would be able to solve. So you know FFT. For EC and electrical guys, I am telling, you know FFT, okay? So in any examination, if someone asks you, do you know FFT? Yes sir, I know. I will be able to solve the problem. But algorithm and everything, I will teach to instrumentation students now. So electrical and EC students will leave. Your journey of signal system ends here. You can solve the PYQs, you can solve the test series as well. Whatever you want to do, now you can do it. So you can leave now. Only the instrumentation students will stay. So for them, I will teach FFT, but again, for them as well, I will teach it on the surface level only. Okay. So FFT we will see on the surface level only. Everything else we have seen in depth, but FFT on surface level only, because this is what is required. From FFT there has been only 3 questions. All the questions have been come only in the EC question paper, right? In instrumentation they never asked any question on FFT. So yeah, so we will only study it on the surface level and then we will be done with that. Okay, so EC student and electrical student also know about FFT. This is what I wanted to tell from this particular question. So just you write down the expression and then you compare with the actual expression, you will be able to tell the answer. Well and good. So I will take a break and then instrumentation students will meet and we will study about DFT, that what is the problem with the DFT and how do we eradicate using FFT. Yeah, so let's meet after some time. I will take a break. You can also take a break. Yeah, welcome back. So we were studying about FFT and now only instrumentation student will be watching this particular part. EC and electrical students can leave, right? So we were studying our FFT and I told you FFT is nothing but a faster computation method of DFT only. So what is the problem with DFT? Let's check that. So in DFT, how many multiplication and summation do you require? Here I have written the word complex. What is the meaning of this complex? Complex multiplication means like 1 by 2j into 1 plus j. So these are two complex number. So two complex number are being multiplied. This is known as complex multiplication. Okay. Multiplication of complex number, addition of complex number. So complex means not tough. Complex means complex number. Okay. So how many complex multiplications are there in your 3-point DFT? So this is your matrix. So what you will do? First this will be multiplied with this one, right? 1 multiplication. Then this will be multiplied with this one, 2 multiplication. Then this will be multiplied with this one, 3 multiplication. And similar thing will be happening to this guy as well. Similar thing will be happening to this guy as well. So number of complex multiplication are 3 into 3. Now someone will say that, sir, this is not even a complex number. This is a real number, sir. Omega 3 to the power 0 is a real number. So how you are saying that it is a complex multiplication? What I mean to say is that someone can say that, sir, x naught could be anything. Let's just say it is 1 plus 2j. Now it is being multiplied with 1. So w 3 to the power 0 is actually 1. How you can say it is a complex multiplication? Yeah, I know that it is not a complex multiplication, but always we will assume that all the numbers that are written here, they will be complex only. What I am saying, w3 to the power 0 also I will assume complex. w3 to the power 1 also I will assume complex. w4 to the power 4 also I will assume complex only. So all the numbers are complex. We will take the worst case. Like if you see the 4 cross 4 matrix for 4-point DFT, here none of the number is complex, no? None of the number is complex. So actually here there is no complex multiplication. In this particular case, there is no complex multiplication. But still we will take the worst case. We will say that every number is a complex. 1, 1, 1, 1, this is also complex. Minus j, this is also complex. Here what you are getting? E to the power minus j 2 pi by 3. Now this is a complex number. This will be written in terms of a plus jb. So yeah, this is a complex number. But every number we will treat as complex only. We will take the worst case. So worst case is that you need to perform 3 into 3. That means you need to perform 9 multiplications. And how many additions would be there? Look in the first row, what you are doing. First what will happen is that w3 to the power 0 is multiplied with x of 0. So 1 multiplication, then addition. w3 to the power 0 is multiplied with x of 1. Another multiplication, then addition. w3 to the power x of 2. w3 to the power 0 x of 2. So here how many addition you are doing? 2 addition you are doing. And you will do it for 3 rows. So 2 into 3, the answer is 6. Let me know the similar kind of calculation for 4-point DFT. So 4-point x of n is x0, x1, x2, x3. 4-point DFT is x1, x0, x1, x2, x3. You need to tell me the number of complex multiplication. You need to tell me the number of complex summation. So how many multiplication would be there? 1 will be multiplied with x of 0, 1 will be multiplied with x of 1, 1 will be multiplied with x of 2, and 1 will be multiplied with x of 4. So 4 multiplication are there, and same you will do it for 4 rows. So total multiplication are 16. And how many additions are there? So 1 will be multiplied with x of 0, plus 1 will be multiplied with x of 1, plus 1 will be multiplied with x of 2, plus 1 will be multiplied with x of 3, and you will get your capital X of 1. So how many additions are there? 1, 2, and 3. So 3 additions are there in 4 rows. So what is the answer? 12. So 4-point DFT, 3-point DFT, If it was your n point DFT, so how many number of multiplication would have been there? N cross n, 3 cross 3, 4 cross 4. So for n point DFT, number of complex multiplication would have been n cross n, or you can say n square, and number of complex summation would have been n into n minus 1, n minus 1 into n, n minus 1 into n. So number of complex multiplication would have been n into n minus 1, that would have been n square minus n. So for n point DFT, number of complex multiplication is n square, and number of complex addition is n into n minus 1, or you can call it n square minus n. So whenever you design a particular algorithm, whenever you design a particular system, designing multiplication is tougher, but designing addition is very easy. What I am saying, designing addition is very easy, but designing multiplication is tough task. Okay, but we are assuming that both are taking some time. Basically, to perform this DFT, you need to make n square multiplication and n into n minus 1 addition. So how many total operation you need to do? Total operation you need to do n square plus n into n minus 1. These are the total operation you need to do, and one operation is taking 1 microsecond. This is what I am assuming. Practically what will happen is that this n square will take more time, but this will take very less time. Negligible time it will take. Practically I am telling. Multiplication will take a lot more time than the addition. Okay, but what we are assuming is that every single operation, whether it is addition or multiplication, every single operation is taking 1 microsecond time. What you need to calculate? You need to calculate 2 to the power 20 point DFT. That means what is the value of n? 2 to the power 20. Actually 4 point DFT, this 2 point DFT, 4 point DFT, 8 point DFT, these are not practical. Practically you calculate 1000 point DFT, 10,000 point DFT, 20,000 point DFT. These kind of DFT you calculate. 1024 point DFT, 2046 point DFT. So these kind of DFT, 2048 point DFT. So these kind of DFT actually you calculate. 2.4 point are there just to understand the concept, but actual DFT you calculate these much. Okay, 2 to the power 10, 2 to the power 11, 2 to the power 12. These point DFT you calculate. So what point DFT I need to calculate? 2 to the power 20 point DFT I need to calculate. That means value of n is 2 to the power 20. So how many total calculations I need to do? N number of multiplication is n square, and number of addition is n square minus n. So this is the total number of calculation. Total number of calculation. This is the total number of calculation. And every computation, basically every calculation is taking 1 microsecond time. So what is the total time? 2n square minus n into 1 microsecond. So 2 into 2 to the power 40 minus 2 to the power 20 into 1 microsecond. Right? So you solve it and you will get roughly around 13 days. I have already calculated it, but let's calculate it once more. कहाँ गया भाई कैलकुलेटर? 2 to the power 41 divided by 1000, because 1 microsecond is there. No, sorry, 1 2 3 4 5 6, this much second. Seconds divided by 60 will give you minutes, divided by 60 will give you hours, and divided by 24 will give you days. I am getting 25 days, but previously I was getting 30 days. Am I doing any calculation error? Again, let's do it. 2 to the power 41, okay, into 1 microsecond divided by 1 2 3 4 5 6 divided by 60 will give you minutes, divided by 60 will give you hours, and divided by 24 will give you days. So you are getting roughly around 25 days. This is not important. I am just telling that if you calculate this time, it is coming out to be roughly around 25.5 days. So to calculate 2 to the power 20 point DFT, 25.5 days will be required. What we need to do? We need to make this process faster. And to make this process faster, we use fast Fourier transform. Okay. So basically, you first design this particular block. This kind of block you design that block, and here you inserted 2 to the power 20 points, and you expected the DFT output. So you inserted the point. This was the input. This was your DFT block. You inserted 2 to the power 20 points, and you expected the output. The output came after 26 days. How will you work? Okay, you will be fired in 26 days. You will be fired, right? So you need to make a better algo. So for that we developed fast Fourier transform. So with the help of fast Fourier transform, the number of complex calculation, the number of complex multiplications, will become n by 2 log 2. Sir, how it will become? That I will tell. N by 2 log 2n. Okay. Number of complex multiplication will become n by 2 log 2n, and number of complex addition will become n log 2n. With the help of FFT algorithm, the number of multiplication will become n by 2 log 2n, and number of complex addition will become n log 2n. Okay. So let's check how much time it will be taken for the same process, and your computation is done. Every single computation, that means every single calculation, every single multiplication, every single addition is done in 1 microsecond. So how much time total it will take? N log 2n plus n log 2n into 1 microsecond. So answer would be 3 by 2 into n. What is the value of n? 2 to the power 20 into log 2 to the power 20. So I have already solved it. So 30 into 2 to the power 20. 2 to the power 20 into 30 divided by 1, 2, 3, 4, 5, 6. So answer is coming out to be 31.4 second. So in 31 second, what is the answer coming out to be? 31 second. So this process was taking 26 days and this is taking 31 seconds. So what you will do, you have designed the FFT block, which is DFT block only. You applied the inputs, and within 31 seconds you got the output. Within 31 seconds you got that DFT. So that's why we use the FFT algorithm. Now how this algorithm is derived, what is the formula behind that? All these points we don't need to see. How the algorithm is derived, that algorithm derivation we don't need to see. Whatever the algorithm that has been made, we need to read that algorithm. And what is that algorithm? That algorithm is this, that we saw in this particular question. So you should know how to read this algorithm. You do not need to design it. Are you able to understand this point? At the gate level, till this point in the instrumentation question paper, there has not been a single question from FFT. So what I would say is that you just need to read it. And there are some important points that we are going to study about FFT. So some important points which are necessary for your examination, and you should know how to read it. That much would be more than enough. Okay, that much would be more than enough. So let's try designing it. Let's try designing a 2-point FFT flow chart. That this kind of flow chart we will design. Here this was 6-point FFT, or you can say 6-point DFT. So for 2-point DFT we can design, for 2-point FFT we can design a flow chart. Okay. So here what we write down, 1, 1, 1, minus 1, right? This is how we write it down. This matrix you already know. So what is your capital X of 0? That is small x of 0. And what is your capital X of 1? Sorry, small x of 0, right? So what you do? Look, your input will be x of 0, x of 1. So input I will write down this side. This will be my input. And what will be my output? I need the DFT. This will be the output. Now what I will do is that from the input I will draw 2 lines. Basically from input I need to go to the output. So how will I go to the x of 1? X of 0 should be added with x of 1. X of 0 should be added with x of 1. And then I need to make this arrow. Arrow means it is going ahead. Arrow means it is going ahead. And how will you reach to capital X of 1? अरे यार ये क्या कर रहा हूँ मैं? This is x of 0, this is x of 1. Sorry guys. This is x of 0 and this is x of 1. So how will you reach to capital X of 0? That is small x of 0 plus small x of 1. So 1, 1 you don't need to write down. If arrow is made, that means it is multiplication with 1 only. Right? So 1 I am not writing down. Now how will you reach to x of 1? X of 0 multiplied with x of minus 1. That means this x of 0 will come. X of 0 will come. But multiply with x of minus 1. Are you able to understand this point? X of 0 was there, it came as it is, but x of 1 came with the multiplication of minus 1, so you got capital X of 1. And what about this capital X of 0? X of 0 came as it is and multiplied with x of 1. So x of 0 plus x of 1, and this was your x of 0 minus x of 1. Here you felt like that, sir, there is actually no complex multiplication. Right? There is no complex multiplication. Here I can see that, sir, there are two addition. One addition and this is also addition only. Right? This was also addition only. So, sir, addition are 2. I agree. 2 additions are there. But I don't think, sir, there is any complex multiplication. There is actually a complex multiplication. Okay? There is a complex multiplication that comes from here. This is w to the power 0. Okay? So, x of 1 will be multiplied with w to the power 0 first. And then all the process will happen. Actually, w to the power 0 is 1 only. But the actual algorithm says that you should design in this manner. Why you should design in this manner, that is not important for you. What I am telling is that actually you will design in this manner, that x of 0 plus w to the power 0, x of 1. And x of 0 minus w to the power 0, x of 1. If you design in this manner, then there will be some symmetry in 4-point DFT, some symmetry would be there in 8-point DFT, some symmetry would be there in 16-point DFT. So if you design in this particular manner, then it would be a correct design. So if you are multiplying with any twiddle factor, multiplication with any twiddle factor is known as complex multiplication. Okay. In this DFT flow chart, if you are multiplying with any twiddle factor, that is known as complex multiplication. This multiplication with 1, multiplication with minus 1 is not complex multiplication. This is the complex multiplication. So how many complex multiplication do you see here? Multiplication that are 1 only. And how many complex addition do you see here? Complex addition, I see 2. Okay. We will develop the formula, although we have already written here, but we will develop the formula from here. Okay. Now this particular cross is known as butterfly. Okay. This particular cross is known as butterfly. Now there is radix 2 butterfly. What I am saying? Radix 2 butterfly, radix 4 butterfly, radix 2, radix 4, radix 5, anything it could be there. So radix r butterfly would be there. Now what will be the value of this r? So in this butterfly, how many number of inputs are there? 2 inputs are there, no? In this particular butterfly, how many number of inputs are there? 2 inputs are there. So this is known as radix r algorithm. Radix r FFT. Radix r 2-point FFT. Radix r 2-point FFT. So what this radix r is showing? Sorry, radix 2 2-point DFT. Radix 2 2-point FFT. What this 2 is showing? This 2 is showing that to this butterfly, how many number of inputs are there? So there are 2 number of inputs. In this particular butterfly, how many number of inputs are there? That is 2. So this is known as radix 2 2-point FFT. Is that clear to you? So what all things we have seen here? That, sir, usually I would calculate my x of 0 in this manner. Here I would have written 1, but some particular algorithm is there which I don't know, which sir is not teaching me, which is not useful for me. So some particular algorithm is there. Based on that, they will write down w to the power 0, w to the power 0. So here I go to know that my x of 1 will be multiplied with w to the power 0. So this is my one of the complex multiplication, and this is the addition. So 2 addition and 1 complex multiplication is there. Now sir, this crossed kind of structure is known as butterfly. So this is known as butterfly diagram. This is the butterfly diagram. Now sir, what will be the name of this FFT? The name of this FFT would be radix R 2-point FFT. You are calculating 2-point FFT, so 2-point FFT. Now what will be the value of R? So in this butterfly, how many number of inputs are there? That is known as value of R. So radix 2-point FFT. Is that clear to you? All good? Let's see 4-point FFT. So 4-point FFT, what you will do? 1 1 1 1 1 1 1 1. Then right in the middle 1 minus 1 minus 1 minus 1 minus 1 minus j plus j minus j plus j. Sir, according to me, it feels like that, sir, there is no complex multiplication, because everything is either this is purely imaginary or this is purely real. Purely real or purely imaginary, purely real, purely real, purely real, purely imaginary. So complex multiplication is not there, but luckily it is not there. Luckily, right? So from here you can get x of 0, x of 1, x of 2, in that manner you can get it, right? Anything you can get. What you can see is that I will get my x of 0, x of 1, x of 2, x of 3. So in the similar manner, what I did here, I made the 2 lines. So in the similar manner, what I will do, I will make the 4 lines. I will make the 4 lines. I will make the 4 lines. And somehow I will connect all of them. This should be small, right? This should be small. Basically, this is my input. Small x of 0 I am having, small x of 1 I am having, small x of 2 I am having, small x of 3 I am having. So based on these, x of 0 plus x of 1 plus x of 2 plus x of 3 will be equals to capital X of 0. So some connections I will make, like for this particular thing I can make this kind of connection, right? This kind of connection I can make. So some kind of connections I will make, and I will be able to get my FFT. So this could be one of the process, right? Whatever the thing that I did here, the same thing I am doing here. X of 1, x of 2, x of 3. Then similarly for x of 1 as well I can do the same thing, that it will, once something will be multiplied with minus j, then minus 1 j. So in the same manner I can get my x of 1 as well. Same, in the same manner I can get my x of 2. In the same manner I will get my x of 3. So this kind of design you will be getting. So you will be designing in this manner, roughly in this manner, a very complex design. What will be the name of this design? So how many butterfly you can see? Only one butterfly. This is only one butterfly. One butterfly. Like this is a number of crosses are there. So this is only one butterfly. Now this particular butterfly is having how many number of input? 4 number of input. So radix 4-point FFT. Why 4-point FFT? Because number of outputs are 4. So this is not a pretty good method. So what they have developed, like here there is a lot of complexity, no? So designing this would be very difficult. Designing this particular algorithm will be very difficult. So what they did, they broke down 4-point FFT into smaller 2-point FFTs. They broke down 4-point FFT into smaller 2-point FFTs in this particular manner. Sir, how this came into action, you don't need to worry about that. How this came into action, you don't need to worry about that. You can see kind of symmetry is there. And what is the value of capital X of 0? That is x of 0 plus x of 2 plus x of 1 plus x of 3. W4 to the power 0, 0, 0, 0. Everything is 0, 0 only. What is the value of capital X of 1? That is x of 0 plus j x of, x of 0 minus j x of 1 minus x of 2 plus j x of 3. Similar thing is happening. Like whatever the answer that we actually get, from this matrix, the same answer I have written here, but in some symmetric form. Because I wanted to break it down into smaller 2-point DFT, smaller 2-point FFT. How did you break it down, sir? How this thing came into action? You don't need to worry about that. So at the input side, this is what I have written: x of 0, x of 2, x of 1, x of 3. And then I have made the same kind of thing, same kind of flow graph I have made, and I will get the value of x of 0, x of 1, x of 2, x of 3. Is that clear to you? So what this will be known as? Now here this is the butterfly, right? Now one particular butterfly is having how many numbers of input? Only 2 inputs it is having. This is also a butterfly. How many inputs it is having? 2 inputs. This is also a butterfly. How many inputs it is having? 2 inputs, right? More butterflies are there. This is also a butterfly. 1 input and 1 input, 2 input. So every particular butterfly is having 2 inputs. So what it will be known as? Radix 2. What will be the name of this one? Radix 2. Here something will come that is known as decimation in time. Okay, what it is known as? I will explain you the meaning of this one. Decimation in time. Decimation in time, 4-point FFT. Okay. What is the meaning of this decimation in time? Look here, first what we were writing down, x of 0, x of 1, x of 2, x of 3, right from starting to end. But here what we are writing down, what is this side? This side is of time, right? This side is of time. X of 0, x of 1, x of 2, x of 3, this is coming from x of n, which is the axis of time. But all these are coming from x of k, which is the axis of frequency. So here frequency terms are coming in line only, x of 0, x of 1, x of 2, x of 3. But time terms are not coming in line. X of 0, then x of 2 is coming, then x of 1 is coming, then x of 3 is coming. So this is known as decimation in time. Why this radix 2? Because this is the minimum butterfly, and butterfly is having 2 inputs. All the butterflies are having 2 inputs. So radix 2, decimation in time, 4-point FFT. Why 4-point FFT? 4-point FFT. So these names are important. All these kind of things are important. Other things are also important that I will tell you. But algo is not that important. That how did you design that algo? That no one will ask you. But you need to read this algo. Will you be able to read the algo? What I mean to say is that from using this algorithm, can you let me know what will be the value of x of 1? Yes. What you will say? Sir, this x of 1 node is coming from this branch and this branch. Okay. Here it is coming from, sir, this particular branch. And sir, this is coming from here. So will you be able to write down what will be the point here? Sir, x of 1 is coming as it is. X of 1 is coming as it is. X of 3 is being multiplied with w4 to the power 0 and then multiply with minus 1. Right? Then sir, this whole thing will be multiplied with w4 to the power 1 and then directly coming here. So can you see this particular thing here? Then sir, another input is coming which is coming from here. So another input is coming which is coming from here. So sir, x of 0 is coming as it is, but sir, x of 2 is coming, multiply with w4 to the power 0 and multiply with minus 1. Multiply with w4 to the power 0, multiply with minus 1 and then simply both of them are added. So you will be able to get x of 1. So you should be able to read it. You are able to read it for sure, right? How to design all these things is not a matter of concern. What else they can ask? They can ask, like, they will write down x of 0, x of 1, x of 2, x of 3 here. Then they will say that it is radix 2, decimation in time, 4-point FFT. And then they will not give this thing. They will ask you to write down these things on your own. X of 0, here what will come, here what will come, here what will come. So this they can ask on your own. So what you will do? So usually this is how we were supposed to write x of 0, x of 1, x of 2, x of 3. This is how we were supposed to write. Can you make the binary out of it? What is the binary of 0? That is 0, 0. What is the binary of 1? That is 0, 1. What is the binary of 2? That is 1, 0. And what is the binary of 3? That is 1, 1. I hope this much basics you know. If you don't know, then in digital electronics you will learn it. This is the binary of 0, binary of 1, binary of 2 and binary of 3. What you need to do? You need to do the bit reversal. What you need to do? Bit reversal. So this bit goes here, this bit goes here. So what you will get? 0, 0 only. 1 goes ahead and 0 goes here. You get 1, 0. 0 goes ahead, 1 comes here. And 1 goes ahead, another 1 comes here. What is the equivalent of 0, 0? That is 0 only. What is the equivalent of 0, 0? That is 0 only. What is the equivalent of 1, 0? That is 2. What is the equivalent of 0, 1? That is 1. And what is the equivalent of 1, 1? That is 3. So this will be the actual order. Are you able to understand this point? So what we do the bit reversal. In case of decimation in time, there will be something called decimation in frequency. So whatever that is happening with the time, the same thing will happen with frequency as well. So that will be known as decimation in frequency. Are the terms clear to you? And what kind of questions can be coming, that is also clear to you, right? So you should know how to read the flow graph. Along with that, you should be knowing this thing that here I can write down in this manner. Here, this is the meaning of decimation in time. If they ask me what should be the order here, then what I will do is that how I am supposed to write, then do the bit reversal, then I will be able to write down the order here as well. So radix to decimation in time 4 FFT it was, and image credit goes to ResearchGate. So this is a very good website for research papers. So here you can read out the research paper of a lot of scientists, right? And you can connect with them as well. So this is a pretty good website. But after the gate examination, once you go into the masters, you can use this particular website. So image I am getting from there. I hope I will not get a copyright strike. Okay, hopefully there will not be any copyright. Yeah. Now some random FFT I have made. You need to tell the name of these FFT. So what do you think? What is happening here? Look, what if this was not given? What if this was not given? Will you be able to write down that what will come first, what will come later on? Let's check, will you be able to write down or not? So I am asking that what should be the, this is your x of n, right? This would be your x of n. So I am asking what would be the order of x of n. So you will say that, sir, I am supposed to write down in this order 0, 1, 2, 3, 4, 5, 6, 7. What is the binary? 0, 0, 0, 0, 0, 1. 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. What I need to do? I need to do the bit reversal. So complete reversal has to be there. Complete reversal I need to do. So here you will not be able to understand because all are 0. But here what will happen? This 1 goes here, this 0 here, and this 0 here. Complete reversal is there. Are you able to understand this point? So what it will become? 1, 0, 0. Let's check what was given here. Okay, complete 1 will be gone. So 1, 0, 0. Now this 0 goes here, this 0 comes here, and this 1 comes here. So what you will get? 0, 0, 1. This 1 comes here, this 0 comes here, and this 1 comes here. Complete reversal is there. So 1, 0, and 1. 0 goes here, 1 to the next. 1 goes here, 1 goes here, 0. 0 goes here, 1, 1. And then 1, 1, 1. So what is the order you are getting? 0, 4, 1, 5, 2, 6, 3, 7. So this is the order. So this they can ask 0, 4, 1, 5, 2, 6, 3, 7. So just write down in the way you are supposed to write down, and this is how you can write down. Okay. This was your x of n, this was your x of k. So what would be the name? This is your 8 FFT. You already know. We are calculating 8 FFT. Why so? Because we are getting 8 point out of it. Decimation in time or decimation in frequency? Decimation in time. Decimation in time. What is your minimum butterfly here? This is the minimum butterfly. How many number of inputs are there? 2 inputs are there. How many number of inputs are there? 2 inputs are there. What does that mean? It is radix to decimation in time 8 FFT. There you go. Radix to decimation in time 8 FFT. Now more questions can be coming. So can you feel like that? Now something I have to fill up. So isn't it like a stage 1, then stage 2, and then stage 3? Aren't these like 3 different stages? Stage 1, stage 2, stage 3. So how many stages are there? This is your stage 1, stage 2, stage 3. Here in this case, how many stages were there? Stage 1, right? And stage 2. Number of stages were 2. Here how many stages were there? Only 1 stage was there. Here only 1 stage was there. Stage 1 only. Okay. and here also only one stage was there. Where? Here also only one stage was there. Stage 1. This was radix 4. So as of now you forget about radix 4. This example we have seen in radix 2. This example was radix 2. This example was also radix 2. And this example is also radix 2. So as of now we care about only radix 2. So can you let me know what is the number of stages? Number of stages, that is equals to log 2n. In radix 2, number of stages is equals to log 2n. Do you agree to this point? When n was 4, your answer was 2. When n was 2, your answer was 1. When n is 8, your answer is 2 to the power 3, that is 3. So number of stages, stage 1, stage 2, stage 3. Is that clear to you? Okay. Number of butterfly in each stage. How many butterflies are there? 4. How many butterflies are there? 1, 2, 3 and 4. 4. Here 1, 2, 3 and 4. Here also 4 butterflies are there. So everywhere how many butterflies are there? Number of butterflies 4, 4 and 4. Here how many butterflies were there? 1 and 2. Here how many butterflies were there? 1 and 2. So one thing is for sure, that in every stage number of butterflies are same. And here how many butterflies were there? 2. Here also 2. Here what was the scenario? Here the butterfly was 1. So 1, 2 and then 4. So what do you think, what is the formula? Number of butterflies. Number of butterflies. Number of butterflies. The formula is coming out to be n by 2. Number of butterflies in each stage. In each stage. Number of butterfly in each stage, that is coming out to be n by 2. N by 2, n by 2, n by 2. What is the value of n here? 4. So here there are 4 butterfly, 4 butterfly, 4 butterfly. And in each stage, the number of butterflies are same. So what is the total number of butterfly? Total number of butterfly would be, in each stage I am having n by 2. And how many total number of stages are there? Log 2n. How many total number of stages are there? How many total number of stages are there? Log 2n, no? And in the each stage, n by 2 butterflies are there. In the each stage, n by 2 butterflies are there. So what is the total number of butterfly? N by 2 log 2n. And you can see one more thing, that each butterfly is giving you one complex calculation, one complex multiplication. Each butterfly gives you one complex multiplication, one complex multiplication. So in each stage there are 4 complex multiplication, 4 complex multiplication, 4 complex multiplication. So what is the total number of complex multiplication? That is coming out to be n by 2 log 2n. Total number of multiplication is also coming out to be n by 2 log 2n. And each butterfly is giving you 2 complex addition, because one addition will be here, 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 one addition will be here. So in every stage, number of complex additions are n. Here how many number of complex additions are there? 8. Here also 8 and here also 8. So in each stage, number of complex additions are n. So how many total number of stages are there? Log 2n. So this will be the number of total complex addition, and this will be the number of total complex multiplication. And in each stage, how many number of butterflies are there? That is n by 2. How many total number of butterflies are there? N by 2 log 2n. How many total number of stages are there? Log 2n. Are all these points clear to you or not? Although we will write down everything, but all these points are clear or not? Let me repeat everything again. Let me repeat everything again for you. Number of stages are 1, 2, 3, which is log 2n. Previously it was 1, 2. Previously here it was 1, 2. That is log 2, 4. Here it is log 2, 8. Log 2, 8. So number of stages are log 2n. In each stage, the number of butterflies are n by 2. In each stage, number of butterflies are n by 2. So total number of butterflies will be, in each stage n by 2 butterflies are there, and total number of state is log 2n. So total number of butterflies are n by 2 into log 2n. Now each butterfly is giving you one multiplication. That means total number of complex multiplication will be n by 2 log 2n. And each butterfly is giving you 2 addition. That means total number of addition would be 2 into n by 2 log 2n. There you go. We will write down all these points, but are you able to understand all these points now? Right? So we will surely write down. So what I would say is that keep the diagram in your mind. So you will be able to tell, okay, 8-point FFT diagram was there. So 3 stages were there. So number of stages log 2n. And in each stage radix 2 it was, so 4 number of butterflies were there. So in each stage n by 4 butterflies were there. Sorry, n by 2 butterflies were there. Then total number of multiplication, total number of addition, and total number of butterflies, that also you will be able to write down. Okay. Now tell me the name of this one. Here what is happening? Decimation in time or decimation in frequency? Decimation in frequency, right? And what is the minimum butterfly? What is the butterfly? This is the butterfly which I can clearly see. So 2-point butterfly. In each butterfly, how many number of inputs are there? 2 inputs are there. That means it is radix 2. So radix 2. Decimation in frequency. And how many outputs are there? 8. 8-point FFT. Okay, this is the name. Radix 2, decimation in frequency, 8-point FFT. How this algorithm came into action, no need to worry. Okay. What about this one? First thing you can see that total number of outputs are 16. So 16-point FFT. Right? 16-point FFT. Decimation in time or decimation in frequency? Decimation in time, right? Decimation in time. Decimation in time. Radix what? See the butterfly. One butterfly. Here it is not possible to see, right? Very complex design. But here you can see 1 butterfly, 2 butterfly, 3 butterfly, 4 butterfly. Right? And each butterfly is having 4 kind of input. 4 inputs. Number of inputs are 4. So radix 4. Although in any competitive examination, I have never seen any question from radix 4 or radix 8, radix 6, whatever it is, they will always ask the question from radix 2 only. Okay, but still we are going to see the complete concept. That's why we have to see everything. So we cannot ignore. So radix 2, 8-point FFT, radix 4, decimation in time, 16-point FFT. Now just try answering this particular thing. Using radix 2, calculating n-point FFT is possible. So what all are the possible values of n? That means using radix 2, what all kind of FFT we calculated? First we calculated 2-point FFT, then we calculated 4-point FFT, then we calculated 8-point FFT, then we can calculate 16-point FFT and so on, which can be written as 2 to the power m, where m belongs to integer. So using radix 2, you can calculate 2-point, 4-point, 8-point, 16-point and so on. So n has to be equals to 2 to the power m. Using radix 4, first what we calculated? 4-point FFT. After that what we calculated? 16-point FFT. After that what we calculated? After that what we will calculate? 64-point FFT. So in the similar manner, n should be equals to 4 to the power m, where m belongs to integer. So using radix r, what all are the possible FFT you can calculate? R to the power 2, r to the power 3, and n should be equals to r to the power m, where m belongs to integer. 2-point FFT, 4-point FFT, 8-point FFT, 16-point FFT, all these you can calculate using radix 2. From radix 4, you can calculate 4, 16, 64 and in that manner. And using any radix r, you can calculate r to the power 2, r to the power 3 and in that manner. For a n point FFT algorithm with capital N equals to 2 to the power m, where m belongs to integer, find the radix value. Radix 2, right? Radix 2. Radix 2. Because you are writing down n, you are writing down in terms of 2 to the power m. The value of m could be anything. It could be 1, 2, 3, 4. So radix 2, right? It would be radix 2. So here you need to see radix 2. So using radix 2, you can calculate only the numbers which are coming as a power of 2. That means which are coming as a integer power of 2. Integer power of 2. Using radix 4, you can calculate only those FFTs which are coming as integer power of 4. So better remember these diagrams. Remember this diagram. Okay, 4 FFT was there. So 4, first we calculated 4, then directly we calculated 16. So in radix 4, we calculated 4 and 16. That means I can calculate 4, 4 to the power 2, 4 to the power 3, 4 to the power m. In radix 2, sir, we started with the 2 point, then 4 point, and then 8 point. That means with radix 2, you can calculate 2 to the power 2, 2 to the power 3, that means 2 to the power m. So in that manner, you will be able to relate. Is that clear to you? So this particular slide is clear to you. Now let's write down all these things. So for radix 2, all these things we were seeing for radix 2, this particular example was there for radix 2 only. So in each stage, how many, let's write down whatever they are asking. Number of stages. So remember your 8 point FFT. So number of stages was 1, 2, 3. So for 8 point it was 1, 2, 3. That means number of stages are log 2n. Okay. Number of butterfly in each stage. Number of butterfly in each stage. So here 4, 4, 4. That means n by 2. So total number of butterfly will be n by 2 log 2n. And we remember each butterfly was giving me one complex calculation. Each butterfly was giving me one complex calculation, one complex, one complex, one complex. So total number of complex multiplication, not calculation. Total number of complex multiplication will be n by 2 log 2n. And each butterfly is giving me two additions, two complex additions. So number of complex additions would be n log 2n. Total number of total unique twiddle factors. So let's come here. Here how many twiddle factors are there? W8 to the power 0, W8 to the power 1, W8 to the power 2, W8 to the power 3. Here also the same thing is there. Wn to the power 0, Wn to the power 2. Here Wn to the power 0, Wn to the power 1, Wn to the power 2, Wn to the power 3. Apart from these, nothing new is there. Right? Let's go to the 4.1. So here you are having W4 to the power 0 and W4 to the power 1. W4 to the power 0 and W4 to the power 0 only. So W4 to the power 0 and W4 to the power n. So two unique twiddle factors are there, and here 4 unique twiddle factors are there. That means how many unique twiddle factor would be there? N by 2. So if you keep this diagram in your mind, then you will be able to answer everything. Keep this diagram in your mind. Basically, what all things you need to keep in the mind, I can highlight it. I can highlight it as well. That this thing you can keep in mind. The number of stages you can keep in mind. Right? Right. That radix 2 you can keep in mind. And in each stage there are 4 butterfly, that also you can keep in mind. Right? In each stage there are 4 butterfly, that also you can keep in mind. So with that you will be able to write down these answers, but at least these two are very, very important. Number of complex multiplication and number of complex addition. Since they are very important, they will not ask it. Okay? They are very important, so they will not ask it. For radix 2 we have write down. Can you make it for radix r? So wherever you have wrote down 2, just replace this with r. So number of stages in radix r, that would be log rn. Number of butterflies in each stage, n by r. Total number of butterflies will be n by r into log rn. Let's drop this total number of multiplication. Let's talk about total number of complex addition, n log rn. Total number of unique twiddle factor, n by r. Here total number of complex multiplication, you thought that it should be n by r log rn, but there will be something multiply r minus 1. So r minus 1 will also be multiplied. What I mean to say is that let's just say I am calculating 16 point FFT using radix 4. So how many total number of complex multiplication would be there? This is the question. So what I will think? That sir, using radix 2, this was the number. So using radix 4, this would be the number. But just remember one thing, that r minus 1 will be multiplied. 4 minus 1, 3 will be multiplied. Here also you can say that r minus 1 is multiplied. 2 minus 1 is being multiplied. What I mean to say is that here also this particular formula is there, no? N by 2 log 2n. It is being multiplied with 2 minus 1. So here you can remember r minus 1. So what would be the answer? 3n by 4. What is the value of n? Divided by 4. Log 4, 4 to the power 2. So what you are getting? 3, 16, 4, 2, 8, 24. So number of complex multiplication will be 24. Okay. So in that manner you can solve the problem. Is that clear to you? Right. Now read this note. In any radix or FFT algorithm, in place computation requires only n node data. In place computation requires storage of only n node data. What is the meaning of this? In place computation means, look here you see, after every line what you are getting? You are getting 8 kind of output. After every line you are getting n kind of output. After this line as well you will get n kind of output. After this line as well you will get n kind of output, and here n kind of input was also there. That means 8 inputs were there. After one stage you get 8 output, then again you get 8 output, then again you get 8 output. So if you don't use in place computation, then you will have to make different arrays. What is the meaning of array? Array you understand by a room. That means you will have to make the different rooms for all these outputs. But if you use in place computation, that means you will have to use only one room. In one room only this output can be stored. After that what will happen? This output will be erased and this output will be stored, and after that what will happen? This output will be erased and this output will be stored. So write back operation will be used here. So only one line you need to remember. What is the line you need to remember? What you will remember is that sir, 8 number of inputs would be there, 8 number of output would be there. So n number of input would be there, n number of output would be there. If I am using in place computation, that means I will have to use the storage of n data only. So I need an array of n data only. So my storage would requires a storage of only n node data. Okay. So this particular statement have been asked in whether it is true or false. So that's why I wrote down this particular statement. So again I am telling that I am teaching FFT on a very surface level. I know that, but this is only required. FFT is not required in depth. It is required on the surface level only. And 100% I am saying that if question is coming from FFT, it will not come after this. And if it is coming after this, then it will be tough only. You will not be able to solve. So the thing is, questions will be coming from these parts only. So everything we have seen. Now try doing this question on your own. These kind of questions should be skipped in the examination hall, but you try doing this on your own. Okay. So think about it and let's see if you are able to do it or not. If you are able to do it or not, I will take a break because it's been a long time. I will have to take a break. Okay. Yeah. So did you guys try this question? So a continuous time speech signal XAT is there, which is sampled at a rate of 8 kHz. So there is an analog signal which is being sampled at 8 kHz. What does that mean? That means sampling time is 1 by 8k, or you can write it down as 10 to the power minus 3 will go upward. So what I can do, 10 to the power 3 divided by 8 microseconds. Is that clear to you? 10 to the power minus 3 would go upward. Then I multiply with 10 to the power 6 and then divided by 10 to the power 6. So what it would become? 10 to the power 3 divided by 8 microsecond. So 125 microsecond. So what does that mean? That there is an analog signal. In that particular analog signal, you are calculating samples after every 125 microsecond. In that analog signal, this is the analog signal you are having. In this particular analog signal, after every 125 microsecond, you are calculating samples. After every 125 microsecond, you are calculating the samples. Okay. So let's just assume till this point there are n samples. So to calculate these n minus 1 I will write down, and this is the 0th sample. So to calculate these samples, how many number of samples are there? N. How much time you would have taken? You would have taken 125 n microseconds. This much time you have taken. So in that manner you are calculating n samples. Read the statement. And the samples are subsequently grouped in blocks. So you are calculating n sample, you are making them as a group. Then you calculated n samples, you make them as a group. Then you calculate n sample, you make them as a group. Basically this is n sample, right? Similarly, you could have calculated some other n sample as well. Some other n samples as well. Other n samples as well. So in that manner you have calculated other n samples as well. So these are also n in number. What is this? These are also n samples. These will also take you at the same time only, right? So n samples you are calculating. Now what you are doing? The DFT of each block is to be computed in real time using the radix to decimation in frequency FFT algorithm. So radix to decimation in frequency FFT algorithm we are doing. We understand the meaning of everything. If radix 2 is there, that means n has to be 2 to the power m, where m belongs to any integer. So value of m would be 2 to the power something. Value of n would be 2 to the power something, right? And m has to be integer. If the processor performs all the operation subsequently and takes 20 microseconds for computing each complex multiplication, including the multiplication by 1 and minus 1, and the time required for addition subtraction is negligible, then the maximum value of n is. Okay, so what they are saying, processor performs all the operation sequentially. So what we are doing, what we were doing, we were calculating the samples, n samples we were calculating, then we were giving these samples, to a particular sampler, sorry, to a particular processor, FFT processor, to a particular FFT processor. Now what this processor is doing? This processor is taking n samples, performing the DFT, performing the FFT, or you can say performing the n point FFT, and then giving you the result. What it is doing? It is taking n samples into action, performing the FFT, and then giving you the result. Are you able to understand this point? So to perform n point FFT, how much time it will take? It will take the time of n by 2 log 2n into every operation is taking 20 microseconds. And you need to ignore the time taken by addition and subtraction. So n log 2n, that we will ignore. So this is the number of complex multiplication, and every complex multiplication is taking 20 microseconds. So this processor is giving you the results after every 20 microsecond, after every n by 2 log 2n into 20 microsecond. So when you applied this input here, it gives you the result after this much time. Are you able to understand this point? Right? Well and good. Now what they are saying, what should be the maximum value of n? What should be the maximum value of n? That means this particular time should be less than what? This 125 n microsecond. Why is that so? Because what is happening? You are having n samples. These n samples will go into the processor. They will give the result. Then other n sample will come into action. Are you able to understand this point? So basically, this processor needs to give the result faster. No, let's just say, let's just take the value of n equals to 1. Okay, randomly I am saying that to make these n samples, we are taking 250 microseconds, 250 seconds. To make these n samples, you require 250 seconds. And your FFT takes 300 seconds to give this final output. What I am saying, n samples are coming. To make the n samples, you take 250 seconds. So previously, these n samples have been made. Just as this n sample came here, the process of making these samples have started. Again, let me repeat the statement. These n samples have been already created. So these created n samples have come here. Okay, these samples have come here. Now you are supposed to calculate the FFT of these particular samples. Just as these samples came here, the process of making these samples have been started. That means sampling is still going on. So you know one particular thing is that after 250 seconds, these samples will be made. But what if this processor is taking 300 seconds? If this processor is taking 300 seconds, okay, if this processor is taking 300 seconds and after 250 seconds, what this function will say? That sir, I am ready with n samples. But processor will say that I need 50 seconds more to compute the FFT of these particular samples. That means new samples are already present, but you are still computing the FFT of the previous samples. Are you able to understand this point? Let me repeat what really happened here. There was an analog signal. The analog signal was creating blocks of n samples. The analog signal was creating blocks of n sample, n sample, n sample. Let's just say some particular block of n sample is coming to the processor. We are calculating the FFT of that. We are saying that it is taking us 300 second time. But to create the samples, it is taking only 250 seconds. So when this particular block came at the input, the process of making these samples have already been started. So they will be made in 250 seconds only. But processor is saying that I need 300 seconds. The processor is saying that I need 300 seconds. That means when these samples will be ready, this processor will say that I actually need total 300 seconds. That means I need 50 seconds more. After 50 seconds, you can apply these samples, which is not possible because this processor is performing all the operations sequentially. That means first this will come, performed, then gone. Then this will come, performed, and then gone. Basically, this processor will not stop. Every time samples will keep on coming. So what does that mean? Whatever the time this processor is taking, it should be lesser than the time that is required to make these samples. There you go. This is the equation that we are getting. Okay. Microsecond is there. So microsecond get cancelled out. N get cancelled out. Log 2n is equals to 12.5. So from here what you are getting, n should be less than or equals to 2 to the power 12.5. What should be the answer? What do you think? That sir, I calculate 2 to the power 12.5. Whatever the answer I get, that would be the answer. Is that so? No. N has to be 2 to the power m, no. Radix 2. This was the important line. Radix 2. So n has to be 2 to the power m. So one condition you are getting, what all are the two conditions you are getting? That n should be less than or equals to 2 to the power 12.5. Along with that, n is 2 to the power m, where m belongs to integer. That means the final answer of n will be 2 to the power 12, which is equals to I should have remembered this, but I am just rechecking it. 4096. This is the value of n. Okay, well and good. So very good question. So all the questions from FFT we have seen. One more question was there which was based on these formula. So if you remember these formula, then that question you would be able to answer. So only 3 questions were there. This particular question, and the first question that we solved without even understanding FFT. So these questions were there which we have solved. All clear, all fine. So very rare chance that question would be coming from FFT, but there is very high chance that question would be coming from DFT. But still, whatever that is required for your FFT, that we have seen. Okay, so I hope you enjoyed this complete lecture series of signal system. You have seen me, you have watched me, and you have tortured me. Not tortured me, sorry. I used the wrong word. You have like what is the word? सहन करने को क्या कहते हैं यार इंग्लिश में? सहन करने को वर्ड याद नहीं आ रहा. सो आप लोगों ने मेरे को सहन किया है पूरे 132 आवर्स. यू हैव bear everything for the last 132 hours. So yeah, the content of signal system is completed. The same kind of effort we are going to put in that test series as well. Okay, so yeah, let's see the test series. You can solve the PYQs and a lot of questions will be there in the test series. So with that, your practice will also be completed. Yeah, thank you very much. Let's meet in the communication system now. So communication system is just the continuation of signal system. So that we are going to see now. Thank you.